with this paper, right, we said it's the June 2020, no, the June 2018 Math grade 12 paper 1 full memo from start to finish without leaving anything out. So here we go. It says here solve for x, right? If you're going to solve for x, I mean, this one is a bit straightforward, because what we know is we just need to equate each bracket to a 0. Now, the one thing I can mention about what we're actually doing here is a common mistake that happens in cases where the number on the right is not a 0. So if this specific question here was given as this, and then they have here x plus 4, right? If they say this is equal to like 3, what you need to do is don't make the mistake of saying x minus 1 is equal to 3, or x plus 4 is equal to 3. This is wrong. You see, the reason why this is wrong is because we only make each of these equal to 0 because this is somewhat specific to an expression like this, because this is saying that you have a value here multiplied by another value equal to 0. Now, the only way this expression is going to be equal to a 0 is if the first is equal to a 0 or the second one is equal to a 0, you see, because 0 times anything is a 0. So this is basically saying that this could be the 0 or this one could be the 0. You see, that's why we do this for cases where you factorize and it's equal to 0. And that's why we cannot do it for cases where your two brackets are equal to a specific number, because the same logic does not apply. You see, you cannot say this is equal to 3 or this is equal to 3. The same logic does not apply. It only applies when it's equal to 0, because each of these could individually be the 0. We don't know which one it is. So hence we work out both of them. So carrying on from here, I mean, like, it's just 3x equal to 1, divide by 3 on both sides, x is equal to a third. So because this was like a straightforward question, I think what we mentioned just now is a bit relevant, because you do get a lot of cases where people do stuff like this. I mean, like, I don't mark past papers or anything, but hey, I've seen things, man. I've seen things. So for 4 marks here, we're just gonna use the quadratic formula. So the quadratic formula is going to be negative b plus minus e squared minus 4ac over 2a. And then for questions like these, I mean, like, you can imagine the only thing you need to worry about is putting your information in your equation properly, you see. So, oh yeah, in your calculator also. So let's see, x is equal to minus b. So while I'm writing it out, if anyone has already gotten the answer, I mean, you know, you're free to be the plug, but it's fine. We'll just like work it out. 2 here for a, c is like a negative 14. The whole thing is equal to what? We don't know, but we're about to find out in the calculator. So let's see, fraction negative 9 square root 9 squared minus 4 the 2 negative 14 2 and 2. So well, they did say we should leave it to 2 decimal places, so it's fine. So this is x is equal to 1.22, or x is equal to, what is it now? X is equal to negative 5.72. Negative 5.72. So those look believable. But the thing is, whatever answers you get in your calculator, right? I mean, like, it's not going to hurt you to just check. You can just use one of them to check. So meaning here, I'm going to put 2 in the calculator, open bracket, and then I press the ans button. Then I square it, let's say plus 9 here, ans again, and then minus 14. Let's see. Yep, it balances out, because you just want to check your answer. Because remember, next to the equal to button, you have that button that's written ans for answer, for you to be able to throw in your answer into wherever you need to throw it to check your answer. Yeah, I advise all the peoples in the universe to check their answers, especially for questions like solve for x. Always check your answers, because you don't want to lose marks for like dumb things, you know. Okay, for 4 marks now, we're dealing with the third question type or whatever. Anything with thirds, as long as it's a full fraction on the left and a full fraction on the right, just square both sides. You see 3 minus 26x squared. And then here 3x squared. The reason for doing this is because we want to get rid of the square root symbol. So we're going to have 3 minus 26x equal to 9x squared. So the one thing I can just re-emphasize is, with things like question 1, right, you're likely to lose your marks from doing silly mistakes.
Why did you share on the group?
Pardon? Unless you're talking here or not. Are you talking here? No, yes, going once, going twice, gone. Okay, sorry. Anyway, so we're going to put everything on one side here, which is like 9x squared plus 26x minus 3. 3. So let's see all this in the calculator. Let's see, x is equal to minus b plus minus b squared minus 4 ac over 2a. So you may be asking yourself, do you have to write down the quadratic formula all the time you use it? Well, the simplest answer is, I mean, like, your ink is, pretend your ink is not going to finish, so just write it out. You don't want to cause any unnecessary problems for yourself, so just write it out first. And then here plus minus, or b squared, b is like 26 there, a is positive 9, and this is like negative 3, as they say. So a here is a 9, and usually when I find myself just like rushing and all these things, yeah, I'm always thinking to myself, hey, I hope I didn't make a mistake, hey? Because to be honest with you, hey, with math, it's always gonna creep up on you. So yeah, I think the easiest thing to do is to just stay humble. Like now, you see, I did write -3, but it's not very clear. Let me just add somebody here. I think whoever has a calculator, please put. Okay, no, I'm putting in the calculator now. -3 there, and then whoa, what just happened? And then Johnny, Moses. Okay, no, it's fine now. So let's see. This is 2 times 9. Everything in the calculator. It's giving us 1 over 9 as the first answer. Oh, what's the other answer? The other answer is -3. The other answer is -3. So with that being said, let's keep on moving forward, because why not? But here you have to be careful, actually, especially questions with surds, because usually the ones with a negative don't work out. So you always need to check your answers. So if you check your answers here, let's see if the left and the right balance out if you put a -3. So if you put a -3, let's check in the calculator. Square root of 3 minus 26 times -3, right? In the calculator, the left side gives you a 9, but then on the right, it's obviously going to give you a -9, you see. So the -3 doesn't work. And that's usually the rule of thumb with third questions. Always test your answers. Because out of 4, you would have only gotten 3 if you left out this here. If you left this as a valid answer, you're not going to get all your marks. But then let's test it with the 1/9 over there. So in your calculator, 3 minus 26 multiplied by 1 over 9. Let's see, the whole thing is equal to a third, and then on the other side, 3 multiplied by 1 over 9 is also going to be a third. So this one is a valid answer. So don't feel as though when you take a second or two to like double check your answer, you're wasting time. Like, no, like, come on. Of course not. Double checking your answer is the best thing you can do for yourself. So be glad to do it. Moving on, first 5-mark question. Okay. So with inequalities, right? I mean, just like whatever it is that we're doing, there's nothing too crazy about inequalities. There's just a way to work them out. So the easiest thing to do is just FOIL out everything, just put everything on one side, and firstly see what kind of an equation you're dealing with. So on the left, you're going to have x times x, which is x squared there. Oh, what happened here? Squared. And then that is like -4x, negative x plus the 4 bigger than x plus 11. Nice. Now it's like x squared minus 4 minus 1, that is like minus 5. And then it's like 4 here. Then this is like x plus 11. So you're going to take everything on the left here. X squared, negative 5, negative x, and then negative 11. If you spot any silly mistake, please just let me know, because yes, those mistakes, they will always just come back to bite us later. So this is going to be negative 6, and then this, calculator, boss. Yeah, but 4 minus 11, because why not? Why not use the calculator? It is 100% free, and I've never had this battery die anyway, so I will always use the calculator, regardless of what kind of equation it looks like. So anytime you have now done this, right, you've put everything on one side. This is a 7, by the way. You've put everything on one side, right? Now you need to answer your question. Your question here is literally asking you, where does this parabola have y values that are bigger than 0? Because remember, this portion here is representing y. This question is just asking, where is y bigger than 0? That's exactly what that question is asking. So what you need to do for yourself to answer this question, let me just write this a bit better. What you need to do to answer this question, you need to firstly have an idea of what the sketch looks like. Now, the one way to have an idea of what the sketch looks like is just look at the a value, the number in front here. Just look whether it's a positive or negative. It's a positive number here, so you know that your image is smiling. That's the first thing you do. Now you need at least the x-intercept of this equation, because you cannot work out where it's above 0 if you don't know where it's equal to 0, you see. So use the portion where it's equal to 0 as a way to like help you answer your question. So that's why when you work out an inequality, you actually solve for x first. You know, you have to get the x-intercept. So fortunately here, we're dealing with a 7 and a 6. So we need factors of 7 that can give us a 6. It's just 7 and 1. Now we need to see what calculation needs to be performed for us to get a negative 6. And the easiest one is negative 7 plus 1. And we just put an x and the x here. So we can do whatever we've done here as long as there's like a 1 in front there, right? So here, this we can say x is equal to 7 or x is equal to negative 1, because each bracket is going to have a 10 like be equated to 0. Like, yeah, I'm just doing it because I just feel guilty for not writing all the steps. You never know who's watching. So the other bracket here is going to be x plus 1 equal to 0, x is equal to negative 1. So what you've done for yourself is you now have some kind of an idea of where your x-intercepts are. So you have an x-intercept at negative 1, you have an x-intercept at positive 7. So that's what you do. Your equation helps you to draw the picture. Just draw a smiling face. You don't need to do anything fancy. That equation, you then use it to get x-intercepts, as we just did here. X-intercept number 1, x-intercept number 2. Now we know that these are the x values where your graph is specifically equal to 0. We want x values where it's above 0. You see, we want to see where are the y values above 0. Now all you do is you use your image to answer that question. The y values are above 0 here, and the y values are above 0 here, because everything under the pink line, those are y values that are below 0. The ones above 0 are these ones in green. So to answer your question, for you to be getting these y values that are above 0, your x values need to be smaller than negative 1, or your x values need to be bigger than positive 7. Now, as long as your question does not have an extra line over there, then these answers won't have extra lines. The reason for that is, if a question is asking where is it above or equal to 0, the question would look like this. This is asking where is it bigger or equal to 0. So your answer would need to say x is smaller or equal to negative 1, or x is bigger or equal to 7, because to accommodate this extra portion. Because specifically at negative 1, it's equal to 0. Specifically at positive 7, it's equal to 0. Anything after the 7, that's where it's above 0. Anything below the negative 1, that's where it's below 0. So as long as this extra line is not there, you don't have to worry about it. But if it's there, you can just remember to put it for your final answers. So what we've written out now this is what's going to get you your 5 marks. Now, one question that's always being asked is, how do you write out your answer? It's a choice. You can either write it out like this is 100% fine. Others would have said something like x is an element of negative infinity up until negative 1, or x is an element of positive 7 up until infinity. This is one way people would have written it out. If you want to do it like this, 100% fine. You can do it like that. Another way is they like to put it in one single line. So they'll put maybe x in the middle here. So this is saying x is smaller than negative 1, right? So they'll say x is smaller than negative 1, or x is bigger than positive 7. This is also another way to like write out an answer. All three ways are 100% valid. You don't have to write all three of them. You just write the one that works for you. Okay, let me add this person, and then we shall carry the on. We shall carry the on. So with these 3 marks here, right? The next question is out of 3. So with questions that work with surds, right? Yeah, these are not bad because there's just always a way to go about them. So questions that deal with surds, right? You normally want to see what you can take out as common in everything. So here, I mean, like we can clearly see that the other thing with surds is that how you normally work with them is the surd applies for everything under it, as long as it's not like plusing or minusing. You see, yo, shaman network is bad. But anyway, so let's see here. Your surd here goes for the 16 and the x to the power of 7. Your surd here goes for the 25 and the x to the power of 7 there. So what you can do for yourself is you can just maybe like distribute the surd. You see, because that's like a valid thing to do to make your life easier. And it's something you can always remember for other questions in the future. So having to have done this, fortunately, we know that square root of 16 is a 4. And let's just leave the what you may call the square root of 7 for now. Let's not do too many things at the same time. So the reason for us not doing too many things at the same time is so that we can explain whatever we need to explain nice and slow, because what is the rush, you know? We're all probably going to live to 70 here. Okay, maybe not, but you get the idea. So now that you have done what you've done, you also want to now recognize that, I mean, like one way or the other, there should be a way you can take out something common amongst all these 3. So to do that, I mean, at the top, you can take out the what you may call the square root of 7, the square root of x to the power of 7 out, fine. But then, yeah, that's not gonna help you very much. Or is it? So the thing that you can do is just keep in mind that anything with a square root, right, there's like a tiny 2 there, tiny 2 there, tiny 2 there. And then anything without a specific exponent there's just a 1. Now the reason for doing this is we are always able to rewrite expressions that have surds in the following format. So this, we can write it as the 2 goes under the 7 over there. Same here. The 2 goes under the 7 over there. And then the 2 here goes under the 1 there. Now you are able to at least maybe see how you can take out something as a common factor. But to make your life easier, you can already see that everything at least has x to the power of half in it. Now, if you take out x to the power of half everywhere, what you're actually going to have is at the top, if you take out x to the power of half, this is what you're going to have left, and I'll explain it slowly. So if you take out x to the power of half at the top, here you're going to be left with a 4, right? And then here you're actually going to be left with x to the power of 7. And the reason for that is when your bases are the same, no, oh no, that was wrong. I need to see what needs to be here for us to have this. And let me think nicely. This multiplied by your, let me think. Because if your bases are the same, right, you add the exponents. So let me see, 7 over 2 minus a half. 7 over 2 minus a half. It means what is left inside the brackets is actually a 3 over here. The reason for that is whatever you're going to do, right, remember, what you end up at, you should always be able to go back where you started. So what I mean is, if you were to multiply inside your brackets here, you should always end up here. See? So here, if you were to multiply inside, you would have 4 multiplied by you'd have 4 3x cubed, right? If you multiplied by x to the power of a half, the idea is here your bases are the same. So your exponents, you would need to add them, of which if you were to add your exponents, you would have the 7 over 2 there. So that's why that's why here we have x to the power of 3, and that's why here we have x to the power of 3. Because when if you were to multiply back into this bracket, if you were to do it, right, you should always be able to go back to the 7 over 2 here. Now, the way you're going to go back to the 7 over 2 is if this is a 3 and if this is a 3. Because if your bases are the same and you're multiplying, you add the exponent. So 3 plus the half is what gives us a 7 over 2. So having to have done that, we can already see that what is taken out, we can cancel out. This cancels. Whoa. That's an error. It's a 2. Zoop. See, because this is just at the bottom. So these cancel out. And then what you have is 4x to the power of 3 minus 5x to the power of 3, which is clearly just 4 minus 1. No, 4 minus 5, which is minus x to the power of 3. Whew, okay, quite an interesting question. But before we move on, we always have to fact check what we did. The best way to check your answer when you're dealing with things to do with x is something similar to what we did when we were dealing with that other trigonometric question before we started the session. So what you can do for yourself is for you to just verify if this answer is correct. I mean, the one thing you can do is go back to the very beginning up here and then choose a random value for x. Don't make it too big. You can even choose, like, let's say x is a 3. Put 3 wherever x is, get an answer, and then put 3 over here and see if the answers match. So let's do it. So it's a fraction button, and then square root of 16, and then next to the 16, you're going to put a 3 there, to the power of 7. And then out of the square root symbol, you're going to put a minus. And then we have square root of 25. Where the x is, we said, let's just choose a random number, which is a 3. So let me just put a 3 over there. I'll add Amy just now. Put a 3 over there to the power of 7. Down here, square root, and then let's put a 3 wherever x is. So after putting a 3 wherever x was, we're getting there negative 27, right? And the fortunate thing is if you were to put a 3 here, where the x is, you're definitely also going to get a negative 27. So yeah, this is how you can double check if your answer was correct. Just throw in a random value for x here and throw the exact same random value where you ended up. That's how you're able to see that whatever you did here was correct. So let us add who we need to add and let us keep moving forward, because why go back? Why? So we've just, let's see, I think there should be some nature of roots. Oh no, simultaneous equations, 5 marks. Okay, yeah, so anything to do with simultaneous equations, I mean, similar vibe. Whenever you do finish the question, just double check it. And also, what now? Yeah, you just double check your answer, because it's easy to make a mistake. So here, let's see, we could isolate either x or y. They're equally balanced here. So let's isolate x. So x is going to be 9 over y. And then we're going to throw this into this equation. So how that's going to look is we're going to have 9 over y minus 2y minus 3. So because we have a fraction here, we might as well make everything a fraction as well, because fractions make the world go round. But yeah, they do make the world go round. But let's see here, I would much rather, let's say, take everything to one side and leave this fraction here. You're going to have 9 over y. This is going to be positive 2y plus 3. And then let's put all this over 1 now. The reason for doing this is when you're dealing with a fraction, you can get an LCD, yes. But then the main reason for you getting an LCD in an equation is because you're trying to get rid of the denominator. So here it looks like it's easier to get rid of the denominator if we take everything to the one side, and then here we can just cross multiply. You're only able to cross multiply if you have a specific fraction on the left and a specific fraction on the right. So here we need to cross multiply now. 1 times the 9 gives us a 9. Y times this, we need to use brackets. Otherwise, yeah, the total is going to dance. So let's do that and then do that. That's like 3y equal to 9. Everything on one side, you would have 2y squared plus 3y minus 9. Whew. Okay. Interessant. Before I put this in the calculator, let me add whoever needs to be added. Anyway, so after having to have done whatever it is that we've done here, let us see what the calculator is going to give us. So it's like 2, no. Y is equal to minus b plus minus b squared minus 4ac. So I am definitely addicted to the quadratic formula, but I think these days I use it less. Sometimes I actually do factorize if I need to. But yeah, 80% of the time, or let's just say 90% of the time, you'll see me use the quadratic formula because it's safer. I like being safe. I like keeping things safe because the universe is dangerous. So let's see, let's see. A is a 2, C is a negative 9, and then we have A there as 2. Okay, let's see what this gives us in the calculator. Unless someone has already gotten the answer, then they can just save us. But I think whoever has the answer is probably going to keep it to themselves. Probably they're like, oh, I'm keeping my answer. I'm not letting it out. What if it's wrong? Guys, that's not a nice way to think. But hey, I understand. I understand. It's just how human beings are wired. It's just how human beings are wired. It's so weird how the only people on like the planet, the one or the other, that watch stuff, that can understand. It's like human beings, but then human beings are so afraid of each other, dude. Like human beings, they're just so scared of other human beings. That's how like people don't. Um, yeah, it is what it is. But 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 where's that thing? Where's that thing? Oh yeah, we need to carry on. We need to carry on. So where's that thing? Let's see. Let's see. Oh yeah, where's the thing? We need to carry on now. So I think this question is fine. No, we have to get the x values. So after getting all these y values, to get the corresponding x, we can just put it in this equation. So I don't know why I don't have enough space here. Whoo! Let's see. Do this. Do that. Let's see here. There's like is that thing? X, y is equal to 9. So y here is like negative 3, right? So x is going to be 9 over negative 3, which is negative 3. Awkward. What's the answer here? Is it negative 3? Yeah. 9 divided by negative 3 is negative 3. Yeah, mathematics. So the next one says, I should put this thing on silent. The next portion of our answer, let's see. Wait, what's that thing? X times y. You see these texts that are coming in, they're distracting me. It's supposed to be focusing here. 3 over 2 equal to 9. So the funny thing is, even though it's a fraction, like legit, I would just divide the fraction on both sides. Don't discriminate against fractions. You're better than that. So let's see, this cancels this. And then in the calculator, 9 divided by that fraction, 9 divided by 3/2, that's a 6. That's a 6. That's a 6. That's a 6. Equal to 6. There we go. 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 So there we go. So everything is good. So we can carry on. Oh, no. We said before carrying on, we need to test our answers. So the easiest way to test your answers, I mean, like, yeah, just use the one that maybe looks a bit more complicated. Like throw numbers, throw a set of X and Y values in there, and then see if it balances out. And then, so let us do that. Like, it's almost like you just can handle dead silence. I could just be quiet checking the answer, but nope. Somebody has to be making sound. So for the -3 and the 9, it seems as though the equation does not balance. Balenciaga. No. It's -3 and -3. Yeah. Because the y was a -3 and the x was also a -3. I'm referring to this answer. You see here where we got -3. For x, we also got a -3. So if you put all these, they balance out. Chances are these are also going to balance out. Yeah. So we can move on to, I think, the one question that is actually, yeah. So yeah. Yeah. So with this question, it's quite an interesting question. It's out of 4. So we need to be careful. We definitely need to be careful. Let me see here. I had sent her. So I was actually responding to a text like, oops, busted. Sorry, Bazalwane. Sorry, comrades. So for 4 marks, right, it says you prove that this expression cannot be negative. So, I mean, for my side, on my side, fortunately, or I don't want to seem all whatever. So for questions like these, right, if you bump into a question like this and you already have like chills and you're not happy, save yourself the time and move on and only come back when the whole paper is done, you see. Because yeah, there's no point in you wasting time and then you don't get to the questions that actually make you happy and make you smile. But for a question like this one, you want to put yourself in a situation where you obviously want to yeah, for a question like this one, you would need to factorize in a way. Yeah, you need to factorize one way or the other. So without making anything too crazy, they say it proves that this cannot be a negative for x for all values of y, meaning regardless of whatever you throw in for y. What? Proves that this cannot be negative. Or they just mean for all values of x and y, meaning that whatever x value you throw in and whatever y value you throw in, you need to prove that this expression will never be a negative. That's what this portion means. They could have just written it separately. They could have just said prove that this cannot be a negative for x is an element of R or y is an element of R, you see. But then here they just wrote it all in one line, hence the comma over there. So they're trying to tell us that whatever, we should prove that whatever x value and whatever y value you throw into expression, it will never be a negative. Now the easiest way to do that is your variable for x and y. Always rearrange this in such a way that your variable x, wherever it will be inside the bracket squared. Same with your y, wherever it will be, you want to make sure that it will be inside brackets squared, all of them. But then here you see the x and the y, it's like they're on their own. So there's really not a way of saying that this will always be a positive because of the way it looks here. So without like beating around the bush too much, for a question like this is a kind of a question where it's not going to be straightforward. You don't like just dive into this question and boom, you're good to go. So normally what you may want to do is you do want to arrange this in a way that you can factorize by grouping. Because, I mean, like you're seeing here, there's 3 terms. It's a trinomial. But then the way it looks here, if you're going to factorize by grouping, one way you could have thought of doing it is by maybe splitting up this to xy plus xy. If you were to do that, this is what you would end up with. In the middle here, you'd have xy plus xy, and then 2 y squared. So you now have 4 terms. You split this up in the middle because you're trying to have 4 terms so that you can then, factorize by grouping. So let's see what where that takes us. Here you can take out an x as a common factor, and then you're going to have x plus y. And then here you can take out y as a common factor. You're going to have x plus 2y. Will you? Yeah. But then the unfortunate thing is, you see here, you cannot, these brackets don't match. You have not really gone anywhere here that will help you answer your question. So if this is, let's say, like your first attempt, then you don't have, you can just scrape it. It's not working out, so you can just scrape it and then try something else. You trying something else, you could now maybe turn to this one and say, let's maybe have 4 terms where this is split up. So you'd have the x squared plus 2xy, and then here you would have y squared plus y squared maybe. So having to have done that, yeah, it doesn't look very promising. I don't wanna lie. It still looks a bit shaky. So you can maybe just group 2 terms and other 2 terms. So I mean, let's see here. Yeah, it doesn't look very nice. Let's see what happens if we pair the x squared and the y squared. Okay, so what we know is this term will always be a positive. This term will always be a positive, but then for these two, we still don't have a way of saying that this will always be a positive. So let's see. I mean, like here, this is sorted. This will always be a positive. This will always be a positive. For these two, you could think to yourself, why don't we take out y as a common factor? I don't think it's going to really do much. If you take out y as a common factor here, we have the, what's that thing? There's going to be 2x here and then plus y. It's still bombing out, you see. So 2 things that we have done so far, they don't look like they're getting anywhere, you see. So this is what I'm saying with this kind of a question in an exam, you really don't want to do it when you still have a bunch of questions to go. However, in terms of us like maybe using different math tools that we can use, let's see what happens if we were to take out here. I mean, there's a common factor here, which is 2y. So I'm thinking to myself, the 2y, if it was to be taken out as, no. Hold on, let me rewrite this. Because there's something that I cannot let go from here. Oh yeah, I think this method is gonna work. The reason why I think this is gonna work is because if you look at these three terms here, I think this can be factorized. Yeah, I think this can be factorized. And then this, because this is already sorted, this will always be a positive number. So let's see what happens if you are to only factorize these 3 here, because our job here is to show that this can never be a negative. Now, the one way to show it is to have it in such a way that everything is going to be under square brackets or under a square root, or no, you just want to make sure that everything is squared, because that way it will show that nothing will ever be a negative. So let's factorize this. So factorizing this, you can do that now by grouping, meaning this here you can split it up into xy plus xy. And then let's see what happens here. So if you're going to factorize this, you can take out x as a common factor here. You're going to have x plus y left. Here you can take out y as a common factor. And then you're going to have x plus y left. And then the y squared is just out here. So this y squared is this y squared over here. And then amongst these 4 here, all we did was, here we took out x as a common factor. So it's out there. Here we took out y as a common factor. So it's out there. Now, fortunately, you can already see that amongst this and this, you can already see that the x plus y bracket is a common factor. So you can take out this bracket, the whole x plus y bracket. So if this bracket is gone, x will be left there. If this bracket is gone, y will be left there. And then here you're literally home free because this is the exact same bracket twice, meaning you'll have x plus y, the whole thing squared, plus y squared. Yep, this is gonna get us our 4 marks. The reason why this is gonna get us our 4 marks is because whatever x or y value you'll put in here, this is showing you that you're gonna square it anyways. So this will always come out as a positive. And then whatever y value you'll think of, you're gonna square it anyways. So this will always come out as a positive. So we have proven that this cannot be a negative for all x or y values, just because of the way we have rearranged it. And you saw how we did it. We just tried what we could. We firstly tried to group, we tried grouping by using all three together. And then later on, we tried grouping by firstly splitting up this and then just working with that. So depending on the different kinds of questions that you're going to be doing on your own, you'll be able to bump into different examples that will help you like learn different ways of answering questions. With this question two says, given the quadratic pattern 5, 10, 17, 26, this looks like such a generic question. Write down the next two terms. Okay, I mean, like, depending on how many past papers you've done, I mean, like, you will already know what's coming from all this. They're probably going to ask us to get the general term, and then they're probably going to ask us to use the general term to get something. You know, it's just so straightforward. So don't lose marks like this because it's so easy. 10 minus 5 is 5, 17 minus 10 is 7, 30, 26 minus 17 is, I think, 11. Is it? No, 9. Oopsie. So the second common difference here is just 2. That's the second common difference. And then you can just work backwards. So you working backwards, all you have to do is, you see, it's like 5 plus 2 is a 7. 7 plus 2 is a 9. So meaning here, 9 plus 2 would give you 11. You see, all that's happening from the top here, it's just 5 plus 5 is 10. 10 plus 7 is 17. 17 plus 9 is 26. 26 plus 11 is giving you 37. And then down here, you know the second common difference is a 2. So 11 plus 2 is 13. And then here, 37 plus 13 is going to give you 50. That is the way we like it. So the next two terms, they're just 37 and 50. That's going to give you 2 marks. Ka-chow. Anyways, the next one, as we have already predicted, they're asking for the general term of the pattern for 4 easy marks. So all we need for the general term is, yeah, we technically just need this actually. Yeah, we literally just need this part of what we've just written out, because all we need is the numbers on the far left here. 1, 2, 3. The one right at the bottom, we're gonna make it equal to 2a. This one we're gonna make it equal to 3a plus b. This one we're gonna make it equal to a plus b plus c. Now this is already something a lot of people know, which is good because it's 3 marks. Working out your formula, we know we just need to get Tn is equal to An squared plus Bn plus C. We're gonna start from the bottom as usual. 2a is equal to 2, so a here is a 1 because we're gonna divide both sides by 2. We're gonna throw a 1 there, and then your b here is 5 minus 3, which is a 2. Here you're gonna put a 1 plus 2 plus c is equal to 5. And then your c value here, this is a 3, right? So when the 3 goes to the other side, it's going to be 5 minus 3, which is a 2. Now, yeah, these I have to test them out when we're done because we're moving way too fast. So let's see here. N is A is 1, right? So you're going to put a 1 there. It's just n squared because there's a 1 there. There you're going to put a 2, so it's like 2n. There you're going to put a 2, which is a 2. Now you want to test out your answer. You can test out by putting, let's say, n as 4. You want to put n as 4 and see if you're going to get like a 26 there. So I'll just do that now as soon as we are at our fallen comrade here. So let's do that. So let's see if putting in n as 4 is going to give us 26. If n is a 4 here, it's 4 squared is 16. 16 plus 8 is like 24. 24 plus 2 is 26. Yep. It's 4 marks in the Z bag. Now, the next question here, also out of 4, right? It's saying which term in the pattern will be equal to this value. So as already said in the beginning, these questions, you can almost predict what they're going to ask. They're going to ask for the next two terms, then they're going to ask for the general term, and then they're going to ask for a specific term in the sequence. It's quite straightforward. Always get those marks because they're free marks. So they want us to get which term in the sequence is equal to this. So this is Tn. And then they're asking for the value of n that produces this value of Tn. So they're saying which position in the sequence gives you this term. So Tn, where Tn is, we're going to put 1765. And then we just need to solve for n. And solving for n here is just the quadratic formula. So you're getting 4 marks for using the quadratic formula, which is like nice. You see, so 2 minus this number is going to give you 1763, like that. So let's put this in our calculator, or rather in the quadratic formula first. Minus b plus minus b squared minus 4ac over 2a, and here's minus b plus minus b squared minus 4. A is a 1, c is this number, and then what you got? 2a is a 1 over there. Nice. So let's just be careful. Ooh, I don't have a calculator. Yo, somebody's gonna have to work it out, please. Like, oh, please take one for the team, because this boy don't got a calculator, and it's kind of far. Like, ish. Trust me when I say it's far. So if anyone has a calculator, please do the honors, and save the pandas, and please give us the answer. But if you're going to do it with your head, let's see here. Well, the first answer is definitely gonna be invalid, because it's like what? I think n is negative 43. Other one, no. Hey, goodness. That one's gonna be a 4. But this one we have to disregard it. But no. Can someone with the calculator please confirm the answers? Otherwise, we is going to be stuck. And being stuck is no. I think it's 41, not 4. Well, why did I write 4? I meant 41. I forgot the 1. So, anyways, let me see if there's something in the chat box here. Problemo 41 or 23. Oh, thank you. Yes. So this one is not valid because it's a negative number. You cannot have a position that's like position negative something. It doesn't make any sense. But anyways, moving on. What does it say now? You have here. Yeah, that's that for 2.1 actually. 5 marks is 5. The fifth question here is a classic question. They love this kind of equation. It says the first 24 terms of an arithmetic sequence are these. This is important. They're telling how many terms you have. First 24 terms, meaning starting from here until here, you have 24 terms. This is T1, T24. And then they said, calculate the sum of all natural numbers. This is where you need to know what natural numbers are. Natural numbers are numbers starting from 1. You see, 1, 2, 3, 4, 5, going all the way to infinity. Those are natural numbers. They say calculate the sum of all natural numbers from 35 to 196. So if they're saying you should start from 35 to 196, I mean, like, natural numbers are all the numbers from 1 to infinity, yes. However, if they're talking about natural numbers from 35 to 196, then you need to be thinking of every consecutive number from 35, meaning you're going to think of 35 36, 37, 38, going on and on. These are all the natural numbers from 35 going to 196. It's consecutive numbers, one after each other. So they say calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7. So this question, it's quite common, not specifically these numbers or whatever. No, what's common is this part. They're not divisible by whatever, whatever, or even sometimes they'll say divisible by whatever, whatever. So if anyone has like gone through the sequences and series course, I mean, like you've probably bumped into a couple of these already because they're just so common. Now, these kinds of questions, you always look out for the kind of a sequence you're given. Now, the kind of a sequence you're given is never a coincidence for these kinds of questions. The sequence you're given always goes with the question, because if you look at this sequence, it's so blunt. This sequence literally has multiples of 7. You can see here it's 35, that's a multiple of 7. 42, that's a multiple of 7. 49, that's a multiple of 7, going all the way to 196. These are all multiples of 7. Specifically in this sequence, or series rather, you have multiples of 7. Like we can see it. It's so much in our face. Now the idea is this sequence has multiples of 7s only. But then the question is asking us to add up every single number from 35 to 196. That is not divisible by 7. I'll repeat. Our sequence looks like this, but then the question wants us to add 35, 36, 37, 38, 39, 40, 41, 42, 43, going on and on. I feel like you get the idea. So if our question wants us to add up every natural number that is not divisible by 7, this is what you're going to do. And this is a method you can use for all questions like this because it's the same way of thinking anyways. So what you're trying to think of is you have all these numbers, right? From 35 all the way until 196. Now what you want to remember is amongst all those numbers, right? You have a number that's divisible by 7 here, and then somewhere here another one is divisible by 7, and then another one, and then another one, and then another one, going on and on and on and on. You have all these numbers here that would be divisible by 7. All of them, all the way until 196. The ones in the middle, those are the ones that are not divisible by 7, you see. The ones in the middle here are the ones that are not divisible by 7. If you're thinking of all consecutive numbers from 35 to 196. Because if you look at how I was even writing it out here, right? 35 is divisible by 7, right? But then every one of these here, all the way until like 42, none of these are divisible by by 7. And then what we already can see is that this is going to be happening over and over again until 196, because between 35 and 196, I mean, more numbers are not divisible by 7 than the ones that are divisible by 7. But without making anything too complicated, if the question here is saying calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7, they want you to add up all these numbers that are in between the numbers that are divisible by 7. Now to do that, it's actually quite simple. All you have to do is you have to add up every natural number from 35 to 196, meaning every single number. You have to take 35 plus 36 plus 37 all the way to 196. You have to add up everything. After adding up everything, you need to subtract the ones that are divisible by 7. You see, because if you add up everything and you remove the ones that are divisible by 7, you're going to be left with the ones that are not divisible by 7. You see, I'll repeat. If you add up everything and you remove the ones that are divisible by 7, the ones that you're going to be left with are the ones that are not divisible by 7. You see. Now, the fortunate thing is adding up everything is easy. Adding up all the ones that are divisible by 7 is also easy, because you'll then just be able to say everything together minus the ones divisible by 7 you're going to be left with the ones that are not divisible by 7. Now, adding everything up is quite straightforward. You're going to use your SN formula, because that's the first thing you need to do. You need to add everything up, meaning you want the sum of everything from 35 to 96. Now, the idea is, if you're going to add up terms or numbers from 35 to 196, you can use this formula. Sn is equal to A. No, Sn is equal to N over 2 A plus L. You see, this is one of your Sn formulas for an arithmetic sequence. You can use it as long as you have the first term and the last term. You see here, first term, and then here you have last term. You see, now adding up everything, we can just use that formula because we have the last term, which is 196. We have the first term, which is 35. Now we have to be careful about what we make n. N, this is something very important, and this is something that always kills people. Your value of n is always the last term minus the first plus 1. That's if you're adding up all natural numbers from one place until another place. You always have to say the last one minus the first one and then you plus 1 for you to see how many individual numbers you're dealing with. Now, to make better sense of this, let's use fewer numbers. If you had the numbers 1, 2, 3, 4, and 5, and you want to add them up, if you look at it nicely, you're adding up 5 numbers. But then, if you had said you're adding up 5 minus 1 numbers, you'd be wrong. You see, you don't. If you want to add up numbers from 1, 2, 3, 4, and 5, you don't say that. Yeah. Hello.
Hi.
Yes, madam. I think the network is like not doing the things. But let me see. If the network is like not clear, you can write out your question.
No, I just wanted to say,
You wanted to say what? Oh wait, the network. I cannot hear. I think because of the rain. Because it's been raining the whole day today, like literally, properly. You can type it out. You can type it out. Send. So you can type out the question. I'll just come back to this just now. But then what I'm trying to say here is, if you're gonna add up, if you wanna see how many numbers are there between 35 and 196, you're gonna have to say 196 minus 35, and then you have to plus 1. So in your calculator, let's see what this gives you. 196 minus 35 plus 1. This is telling you actually have 162 numbers that you're adding up. You have 162 numbers that you're adding up. That's the value of n. So what I was trying to say is, the easiest way to look at it is, if you're looking at, let's say, fewer numbers. Let's say you're adding up numbers like 2, 3, 4, 5, and 6. So you can see you're adding up 5 numbers here. But then if you had said the number of numbers you're adding up is 6 minus 2, you'd be wrong, you see. Because if you're adding up numbers from 2, 3, 4, 5, and 6, you're not just going to say 6 minus the 2 there. You're going to have to say 6 minus 2 plus a 1, so that you can include the number in the front there, so that you can see your 5 digits. And let me re-add Chloe, because yeah, I think her network was ring, so I couldn't even hear her either. But anyways, I'll just add her now, and then we'll see what she's going to ask. But then before that, let's see here. So adding up everything here, right? In our calculator or in our formula, would have put here S162, N would be like 162, and then A, the first term, which is like 35, A is like 196. Everything in the calculator. Let's see what it gives us there. Blah, 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 yada, yada, yada. So everything in the calculator here, wait a minute. Yeah, everything in the calculator here is giving us 18,000. Let's put it here, 18,000. 711. Before I move on, are you back, Chloe? Do you have your question so that we can answer it or not? But if you don't have a question anymore, let's just carry on and finish for now. So this is the sum of absolutely everything. So in addition to the sum of absolutely everything, you want the sum of the ones that are actually divisible by 7. So the ones that are divisible by 7, you adding all these up, you can use the same formula. Sn is equal to n over 2 a plus l. Because here, the only issue here is, you see you have 24 terms now, instead of you dealing with the whole whatever 162. In this sequence, you have the first term is this, the last term is this, right? But then you're not dealing with natural numbers here, you're dealing with just these ones. So you already know that they told you have 24 terms. So n is a 24. The first term here is 35, the last term here is 196. All this in the calculator. Let us see what this gives us. Or in the head rather. 12 and then 196 plus 35. You know, this is dangerous, blah blah blah. 231 times the 12. 2 times that. 2 plus 2 times 1 is a 2. Okay, so this will be 2,772. If you've worked it out in the calculator and you're getting something different, please let the boy know before the boy messes up good. So you see, this is the sum of absolutely everything. This is the sum of the ones that are divisible by 7. So the sum of the ones that are not divisible by 7, it's going to be 100. It's going to be like the 18,711 minus 2,772. And then let's see what that would be. 2 minus 1 would give you, oh no. This is no, it would be 1 minus 2, it can't, so you'd have like 11 minus 2, which is like a 9 there. And then I think we'd have like a 3 here. And then another 9 there. Oh yeah, 1 5. 15,939. That is going to be the number that you get if you add up all the terms or all the numbers that are not divisible by 7. So it says here, Temba is planning a bicycle trip from Cape Town to Pretoria. Good luck. Good luck. It says here the total distance covered during the trip will be 1,500 kilometers. He plans to travel 500 kilometers on the first day. For every following day, he plans to cover 94% of the distance he covered the previous day. So these words here, right, we need to be able to understand them very, very well. Otherwise, it's going to be a problem. So with all that they said here, they said, what distance will he cover on day 3? So I think this question is quite simple, but I think for the others, we may have to revisit our description here. So they said he wants to cover this distance, fine, but then he's going to be covering 100 kilometers every day. I mean, no, he's going to cover 100 kilometers the first day, and then every following day, he plans to cover only 94% of the distance he covered on the previous day. So these two key words here, this is, I think, where most people would like get choked. But then that's what we're going to clarify a bit more. So on the first day, right, he's going to cycle for 100 kilometers. But you need to remember, the second day, he is going to cycle 94% of the previous distance. What that means is On the next day, he's going to cycle 94% of 100. You see, that's what he's going to cycle the next day, of which off means times. So you can just see what he cycles the following day by putting this in your calculator. So in your calculator, you can just press 94. You can put it over 100, or you can just write the percentage symbol by pressing shift and then the percentage button, which is like in your calculator, if you're using Casio, it's like the bracket button. If you press shift and then that button, the percentage symbol pops up, times that by 100, you're going to get 94 as expected. Now, for the third term, the same idea. The next day, he is going to travel 94% of 94. So I'm doing this manually so that we can find a way to easily work out a value of R for all our other questions, because clearly we need it. Let me just maybe leave this out for the PDF file. So for the third day, it's going to be 94% of the previous day, which is 94. 94% of 94. Let's see what the calculator says. 94% of 94. That's going to be, it's 88.36. I would have written it as a fraction, but yeah, I think let's write it as a fraction because we're dealing with, sequences and series. But most people don't like fractions. So, sorry. So this is the third term, but it's fine. I'll write it as a decimal, I'll write it as a decimal so that we don't make enemies unnecessarily. So it's 88.86 here. So this is going to be 88.86. So once you have done this manually, it's clear for you to see that your value of R is just 94% because you're taking every term, you're just multiplying it by 94%, you see. So that's literally what you need to keep in mind. R here is just 94% because what we did for term number 2 was we just multiplied by 94%. What we did for term number 3, we just multiplied by 94%. As in whatever we had. The previous term, we keep on multiplying by 94%. So if you want to see what the value of R is, the value of R is just going to be 94%, of which 94% is just the number 0.94. But then if you're obviously maybe a bit skeptical or something like that, you can always just check it here. You see, this divided by this is equal to this divided by that, of which this fraction, all these fractions in their simplest form is just going to be 0.94. That's the easiest way it can be. But then 94 over 100, I think that number would be 47 over 50 or something, but it doesn't matter. It doesn't matter. Let's just keep in mind what our value of R is. Our value of R is just 0.94. So that's going to help for follow-up questions. In the next question, so again, if there are any questions, you have to switch on your mic and then just say something. Otherwise, I might miss it here, you see. So anyways, let's see. It says here for 4 marks. On what day of the trip will Temba pass the halfway point? So with questions like these, don't be quick to panic or don't be quick to judge them either. Just take things bit by bit. So what I mean by that is they said on what day will he pass the halfway point? So the first question is, what is the halfway point? So the halfway point is obviously going to be half of this, which is 750 kilometers. So our job now is we have to think creatively. Now, the fortunate thing is because you already know it's a sequences and series question, just be thinking in that way. You already know it's a sequences and series question, so just think in terms of how sequences and series work. Now, with sequences and series, we know that what we will need to do is we need to take the kilometers that he's traveling, right? And then we obviously need to be adding them up bit by bit. You see, we need to be adding up these kilometers as this person is riding throughout these days. So what we need to do is for us to see what day of the trip he's going to pass the halfway point, we need to think of the SN formula. We need to think of the SN formula. Because this is a geometric sequence, we would be thinking Sn is equal to A R. Let me do the one where it's 1 minus R to the power of N, 1 minus R. So with your Sn formula, you have to remember you have two options. You have the option like this, and then you have an option like this. So normally you may want to use this option for cases where your value of R is below 1. For cases where your value of R is above 1, you can just use 1 where these two are swapped around. If these two are swapped around, then the bottom also has to be swapped around. And then if these are like this, then this has to be like this. So because our value of R is a number that is smaller than 1, you may want to use this option. So the reason why we're thinking of the SN formula is because we're trying to see how many of these terms do we need to add up for us to at least have 750. That's how we're going to see how many days will he need to travel for him to pass the halfway point. So if there are any questions, feel free to switch on the mic and ask. So far we know we want to work out where Sn is 750. We don't know how many days that will be, so N is open. A is the first term, which is 100. R is our common ratio, which is 0.9. Oh, whew, okay. So we're trying to solve for N, right? So because N is an exponent, it's fine. You just have to keep calm and deed the does, you know. So R here is 0.94 to the power of N. And then this is 1 minus 0.94. Now, obviously, the bottom part here, you may want to just multiply that on the left and on the right to get rid of it. So the bottom part, you can just say, you're going to multiply by 1 minus this on the right. Then you're going to multiply by 1 minus that on the left. So let us, actually, yeah. So whatever I'm going to do, you may not want to put this stuff in your calculator just yet. You may want to do it right towards the end usually, because these kinds of answers, they're going to come out with like long decimals, and you really don't want to be like, what you call, you don't want to round off too early and stuff like that. So this is what we have so far, right? With the 100 here, 1 minus 0.94 to the power of N. Now the next step is, because you're trying to isolate, no, that fraction, or rather that exponent, in the wrong place. Whew, much better. So with what we have here, we can see that both sides you're going to have to divide by 100. So if you divide by 100 there, this is what you're going to have. Divide by 100 here, this is what you're going to have. And then the idea is, this is what I normally do. So the funny thing is, this here, right, has a negative. So you may want to take this to the left so that it becomes a positive. And then you may want to take this whole thing to the right. If you take this whole thing to the right, you're going to have negative 750, 1 minus 0.94, the whole thing over 100. Okay. So at this point in time, you may be thinking, bro, can we not just maybe put all this in the calculator and like be done with it? Yeah, we're getting there. You know, we're getting there. So because now we want to isolate an exponent, right? What you need to do is just remember that everything on the right-hand side here, this is together. This is just one big number. And then you have an exponent, and then you have a base. So anytime you want to isolate an exponent, you isolate the exponent, and then what you do is you press log. Whatever the base of the exponent is, you make that the base of the log. And then whatever this number is, it's the number that's going to come over here. And all this, you can easily just put it in your calculator. You see, you don't want to think to yourself that you're going to like mess up or something like that, because you're not, you know. Have confidence. So you can already see that the way it's structured, from pressing your log button, the one under the on button on your calculator, you'll have a slot to put something here, and then you'll have a slot to put this whole thing there. So let's do it, and let's hope we don't get an error, because if you do get an error, hey, Yeah, it's chai. So let's see, log 0.941 and then minus a fraction button, 750, 1 minus 0.94, 100. Moment of truth. Whew, at least, yo. Hey, with logs, you know, sometimes you never know. So normally if your expression gives you an error, right, it means that it means that you'd have normally put a negative somewhere, either here or there, and you don't want to do that. So for cases like that, yeah, you may want to just double check what you would have done. But if push comes to shove, like just use positive values and then use whatever you get to try and get an idea of what your answer could be. So this is giving us n is 9.66. Now this is not uncommon for this kind of a situation, because remember, this 9.66 is giving us an idea of what day this person is going to pass the halfway point. So technically speaking, if n is 9.66, the question here says, on what day will Temba pass the halfway point? So technically, after the 9th day, right, we can safely say here, on what day will Temba pass? Yeah, he will pass the halfway point technically on the 10th day. On the 10th day. The reason why we say on the 10th day is because if you think of day number 9, exactly day number 9, we know that he would not have covered 750 kilometers. But then during the process of going from day number 9 to day number 10, we can see that that's where he's going to pass the halfway point, because this 9.66 here is just telling us that if you had, let's say, the general term of this equation, this is basically just telling us that if you're adding all these terms, right, and you add up until term number 9, you would still not have 750. But the moment you add term number 10, then you would at least have something above 750 kilometers. So that's why he was saying that the day that he's going to pass the halfway point is on the 10th day. So in terms of the explanation why we chose day number 10, if there are any questions, please be comfortable to ask, so that we can do the things that make things to be done. But then if the answer is fine and everyone is okay, then let's move on. Let us move on to this final question for today. Remember, the next session is on Thursday. So I think if we end up with this question 3.3, it is good. It is okay. It says Temba must cover a certain percentage of the previous day's distance to ensure that he will eventually reach Pretoria. Calculate all possible values of this percentage for 3 marks. You know, yeah. Well, it's a 3-mark question, and I mean, me reacting the way I reacted, I mean, I'm just trying to not sugarcoat it. You know, this question is not very straightforward. I'm not saying it's like crazy difficult or anything. It is out of 3, so it just means there's like just a way to do it. But then, I mean, also going back to what I said when we were at that question where they asked for, you know, show that the expression will always be, cannot be negative, blah, blah, blah. All we did there was we basically we just winged it. No, we didn't exactly wing it. We just, yeah, we did whatever we could. But I think here, this kind of a question, you may want to read it again, because it may seem crazy, but if you read it again, there may be some method to the madness. And this is what I mean. With this kind of a question, right, it says here, Temba must cover a certain percentage of the previous day's distance. So we already know that if they're talking about a certain percentage of the previous day's distance, they're talking about R. You see, because R is the certain percentage of the previous day's distance. That's what R is. That's why here R was 0.94, because 0.94 is 24%. So 24% here is the value of R, which is a certain distance that is originally covered of the previous day. So it says here, Temba must cover a certain percentage of the previous day's distance to ensure that he will eventually reach Pretoria. So what they mean is, right, he's starting with like 100 kilometers, and then these 100 kilometers, they're just going to get less and less and less and less and less and less and less. So what they mean is, right, depending on what your value of R is, there's a scenario where if he covers, let's say your value of R is 50%, then it means that on the first day he's going to travel 100, on the next day he's going to travel 50, on the next day he's going to travel 25, on the next day he's only going to travel 12.5, on the next day he's only going to travel 6 point something something. So you can imagine if your value of R was like 50%, one way or the other, this is easy for us to see that there is no ways this person is eventually going to make up what you call 1,500 kilometers. Like it could go forever and he will never reach Pretoria. Because remember, this is a sequence, yes, but then our scenario is talking about days. So if this gives us like, you know, yeah, what I'm trying to say is if R was like a 50, it clearly would not work out. So they want us to work out what specific value of R or what range of values of R will always ensure that this person at least reaches 1,500 kilometers eventually. So the easiest way to go about questions like these is the way you can already see the wording. You see here they're talking about R, and then here they're talking about the word eventually. So words like these, and also just the nature of the question, words like these, they should remind you of sum to infinity. The reason why these words should remind you of sum to infinity is because what we already know is that regardless of how many kilometers it travels day by day, what needs to happen is when we add up all his days, they should at least add up to 1,500. Now, that kind of a scenario, that's how sum to infinity works. Because sum to infinity takes into account a sequence where numbers are decreasing, but then as those numbers are decreasing, right, they will, when you will add them up, they will always add up to a specific whole number. So in our case here, we need to use our sum to infinity formula and work out a value of R that will ensure a specific sum to infinity if we're starting at a specific point. I'll repeat. We know that we're definitely starting at 100 kilometers. So that one is fixed. A is 100. We know that. What we also know is everything that we're going to add up, we at least need it to add up to 1,500. So our sum to infinity can be 1,500. Now our value of R, we can just work that out now, because whatever value of R we work out, that value of R will tell us what R needs to be for us to at least have a total distance covered of like 1,500. So after getting this value of R, we'll also then be able to see what other values of R are viable, of which those will technically be values of R that are going to be bigger than whatever answer we're going to get here. But without like talking too much, right, let's just do this question, because once the answer is out, it's going to be much more easier also to understand. So from here, our sum to infinity, we're making it 1,500 because that's the distance that we know he needs to cover for him to go from Cape Town to Pretoria. Our A value, we know that he's starting off with 100 kilometers. Now, if you saw for R here, remember, as long as this is a fraction, you can make this a fraction as well, so that we can just, cross multiply. So 1 times 100 is 100. This times 1,500 is just going to give us this. And then since we're working out R, don't multiply inside. You see, there's no need for that. Since we're working out a value for R, you can just divide by 1,500 on both sides. You see? And then the one can go over to the other side. 100 over 1,500. You're subtracting a 1, right? So this is negative R. So this minus 1, let's see what you're going to get here. 100 divided by 1,500 minus 1. It's giving you negative 14 over 15, negative 14 over 15. Now, obviously, both sides you can just divide by negative 1. R is 14 over 1, 5. So obviously this, you may want to see it as a decimal. So as a decimal, you're getting the 0.9, what are you getting here? 0.933333333, going on and on and on and on. So this is clearly, approximately 93%, like one way or the other, because it's 0.9333333. It's approximately 93.33%. Because let's just maybe put this to 4 decimal places, and then as a percentage, right? We know that if you multiply this by 100, you're gonna have R is 93.33%. So what this is telling us is that for us to have a sum to infinity of 1,500, or for us to eventually reach a sum of 1,500, our R needs to be at least 93.33%, you see. So in terms of giving an answer here, what do they say? Calculate all possible values of R of this percentage. So it looks as though for us to give a viable answer here, right, you may want to maybe use this, because this is at least not rounded off and all that shandies. So using this number, if you were to multiply it by 100, you would have 1,400 over 15%. Okay, so this is more accurate than all these others down here. So we might as well remove these ones, you see. So our value for R as a percentage, we multiplied by 100. So this is telling us 1,400 over 15%. So that's the percentage that's going to allow us to have a sum to infinity of 1,500. So if you think of it logically, any other percentage that's higher than this, he will always eventually reach Pretoria, because if he covers like 95% of the previous distance, like he's covering more than the 23%, I mean than the 93%. If he were to cover 96% or 97% or even 100% of the previous distance, we can see just from this that he's eventually going to make it. So here we can say that for him to always be able to make it, the value of R, right, needs to be bigger or equal to this number here as a percentage. Remember, we know that this is like 93.333333%. So this is what your value of R is going to be. You're just going to say that R needs to be bigger than or equal, R needs to be bigger or equal to 1,400 over 15%. However, because we're dealing with sum to infinity, remember your sum to infinity, because I want to add, I don't want to overcomplicate this question. With sum to infinity, your values for R always need to be between -1 and 1 specifically. But then, yeah, let me not overcomplicate it. For this question, this will be good enough, you see. Because if your value of R is bigger than 1,400 over 15%, it means that your percentage that he covers of the previous day, it's always going to be large enough for him to eventually cover a distance of 1,500. With something like functions and graphs, right? I mean, your theory is a big deal. Your basics are like a proper big deal. So whatever we're going to be doing, there are certain things that we're going to say that are basically just almost generic. So for example, here it says the graph of f of x is this. So whenever you see a graph where it's a log expression, you see, that is always linked to an exponential graph in some way. Because whenever you have an exponential graph, the idea is normally if you perform inverse, right, you end up with a log graph. You see, this is more like the, what can we call it? I don't know. It's like the normal run of things. if you have an exponential graph and you perform inverse, you end up with a log graph. Now the idea is this also works in reverse. If you have a log graph, right, and yo, dude, that's not how you spell graph. If you have a log graph and you perform inverse, remember me, whenever I say perform inverse, or if you hear me say words like that, I'm literally just referring to how you'll have to make x a y and you'll have to make y and x, you see. So if you have a log graph and you perform inverse, you're always going to end up with an exponential graph, exponential graph. So this piece of information, it may seem a bit useless or whatever, but it just makes your life easier because, I mean, like sometimes people think that a log graph is like something brand new and something crazy or not. No, it's just another function with all normal properties, just like anything else. If you throw x there, you get y. So it says this log graph is drawn and we have point B on this log graph, and point B is at this particular point. It's a coordinate where the y value is not given. So for 2 marks now, they're saying for which values of x is log 4/3x smaller or equal to 0. So if you look nicely, our equation here, our equation of f of x is log 4/3x. So this is our log graph. This question is practically saying where is f of x smaller or equal to 0? You see, because I mean, like this entire portion here is just representing f of x. Now, what you want to remember is that f of x just represents the y values of our graph here. So our question here is practically asking where are the y values of this graph below or equal to 0? So whenever you answer questions like these, you have to give your answer in terms of x, you see, for which values of x is log smaller or equal to 0. And it's a 2-mark question. So answering questions like these, it's much easier if you have like an image to refer to, because your image here, I mean, you can already see this is the point where your y values are equal to 0, you see, and then anything below that, this is the part where your y values are below 0. So this part here, we know that our y values are below or equal to 0. And then obviously the part above that, which is like this whole part here, this is the part where our y values are bigger than 0. You see, that's as simply put as we can put it. So answering your question, this question wants you to give the x values that are producing this blue line. Now, if you look at it nicely, I mean, like the x values that are producing this blue portion is just x values from whatever this x value is up until the x value 0, you see. So to answer our question for 2 marks, we have to find out what is the x value here, so that in terms of giving our answer, we can say that the graph is below or equal to 0, where x is between 0 to whatever this x value is. So us finding this specific x value, it's not a hassle because we have the equation of the graph anyways. Now, because we want the x value here, we just need to throw in what y value this is. So this is nowhere up and it's nowhere down. So the y value here is a 0. So in our equation of f of x, we already know that the first task is to just work out where is y a 0. Because the moment we work out where y is a 0, we will be able to get this specific x value. So in the equation of the f of x, let's see here, where f of x is, we're just going to throw a 0 there. Now, this is what we do when we need to like work with logs. So seeing this, right, logs is, it's nothing crazy. You never want to put yourself in a situation where logs are a bit, you know, complicated. So this is what you do. Whenever you work with logs, try and focus mainly on 2 specific values, you see. Try and focus on this value here and this value over here. You see? So depending on what you want to isolate, or depending on what you want to make the subject of the formula, you focusing on these 2 here is your best bet, because the idea is this will always be referred to as the base of the log. Now this value that will always be on its own, it's weird if I say it this way, but this will always be like your base, and then this, you always want to think of it as your exponent. Because whenever you think of logs, I mean, you're going to be dealing with exponents one way or the other. Now, you like mumbo jumbling this, or you reverse engineering this whole thing to get rid of the log. All you have to remember is that your expression is in this format. You'll always have a base here, and then you'll always have an exponent over here. You see, as long as you can just remember this, then you're fine, because whatever goes here is just always going to be a value on its own. You see, this will always be a base, this will always be an exponent, and then this will be a value on its own. So the reason for doing all that is, since we want to get rid of the log here, we just have to remember that this will be the base, this will be the exponent. So we'll have a base, and then we'll have an exponent, and then we'll always just equate it to whatever this value is, which in our case here is just the x. Let me actually just color code it properly, change colore. Let us make it, right, let me see here. Here's the color now, I think it's this one, eh? Yep, let's do this also. Change color, yeah, there we go. So that's the idea. This will be the base, this will be the exponent. Don't even worry about this, because as long as you know that this is base, this is exponent, this will be left on its own. So here we can clearly see that our value of x is just going to be a 1. And I kind of do feel like I've spent quite a bit of time on this question, a bit too long actually, and it's kind of feeling a bit weird. So let me actually just rush through and move on to more difficult questions. So x here is a positive 1. So in terms of answering your 2-mark question here, you're going to have to say your x values are an element of 0 until positive 1. And I'll explain why now I've put this round bracket and why I've put this square bracket. So the idea behind putting this round bracket where 0 is because our x values, right, we know that they are between 0 and 1. However, specifically at 0, the graph will never have an x value of 0. You see, because we can see just because of the shape, the x value 0 is an asymptote, which this graph is not touching. The image is clearly just showing us that. So that's why at 0, we have a round bracket here to show that the graph does approach 0, but it will never touch the 0. And then specifically at 1, we have a square bracket here, because specifically at 1, we know that the graph is equal to 0. You see, it also forms part of the question, because the question is asking where is the graph below or equal to 0. So it's below 0 anywhere smaller than 1 and anywhere above 0, but it's specifically equal to 0 specifically at 1. So you can give your answer like this, or you can write it many other ways. Some people would have said x is bigger than 0 and then x is smaller or equal to 1. These are like another way to do it. So you can write it like this. This is like option 1. This is like option 2. Let me think. Another way people would have written it is they would have said something like x is bigger than 0 or x is smaller or equal to 1. That's just like option 3. Or these 3. You don't have to write all 3 of them. You just write whichever one works best for you, whichever one suits you. So for 2 marks, I think that is that. If there are any questions, oh yeah, I think I should also state this. If there are any questions, right, the easiest thing is to just switch on your mic and then just ask, just in case I don't come back to these chats in time. So say, sir, I'm not understanding how you got the 1. Any number to the power of 1, any number to the power of 0 is 1. Yes, 100%. So the reason we have the 1 there is because any number to the power of 0 is always a 1. You can just use your calculator to get this. That's how we got the 1. That's how we know this x value is a 1. So for 3 marks, let us move on. It says we need to determine the value of p without the use of a calculator. Oh well, I mean, that's fine. I mean, p is just the y value, whereas this is the x value. So this is more like, it's more of a straightforward question, really, because you're asked for a y value, whereas you're given an x value. So questions like these, I mean, you just cruise through them, no need to stress too much. So the idea behind you being asked to not use a calculator, I always say not being asked to use a calculator does not mean throw your calculator away and then do everything in your head. No. When they say don't use your calculator, they just mean show your steps. You see? So it means you do use your calculator, but just do it step by step. So here we know that we are given a y value, an x value, which is 16/9, and we need a y value. So here we are looking for a y value, and the x value we're given is just 16/9. So with what we have here, it's giving us an opportunity to like showcase what we mentioned over here, you see, because exactly what we mentioned here, right? We're gonna just execute the exact same thing here, because as long as you have something in this format, right, always just remember this is a base, this is an exponent, and then this is a value, regardless of what you want to isolate. So what I mean by that is all we have to recognize here is that this is a base, and then this is an exponent, and then this will just be a value on its own. Meaning we're gonna have here, we don't even have to, isolate anything here, because I think me mentioning what I'm mentioning now is I've sometimes seen people like rearrange this and then bomb out. But then in this case, we kind of do have to rearrange it because they said we should not use our calculator. Because here, if we were to use our calculator, we could just easily just, put everything in the calculator and get an answer. But then we cannot do that here. So we have to think creatively. Us thinking creatively, we kind of have to get rid of the log, obviously. So to get rid of the log, we have to remember that this is a base, this is an exponent. So we'll have here a base, and then we'll have here an exponent. And then on this side, we'll just have the value, which is 16/9. It's just like what we said here, base, exponent, and then a value. So here we had a base, an exponent, and then the value over there, which is what we're doing here, base, exponent, and then the value. So the fortunate thing here is our exponent is y, you see. And working out y, it's a bit easier now because we can just do it by observation. We don't even need our calculator here. So when I say we can just do it by observation, I just mean, just compare the two sides, you see. From 3 to 9, you're kind of going to square the 3. From 4 to 16, you're obviously going to also square the 4. So here it's easy to see that y is just a 2, you see. If you maybe had not seen it, you could have just maybe gone a step further and have just executed your exponential laws. So exponential laws will tell you that the y goes for the number at the top, the y goes for the number at the bottom. And then you can also then look again now, you see. 4 to the power of what gives you a 16, it's just a 2. 3 to the power of what gives you a 9, it's also just a 2. So here you'll be able to say, therefore, y is equal to 2. And your 3 marks here, they're going to come from the steps that you would have shown to go from this. So this is obviously going to be 1 mark, and then another mark, and then obviously a final mark there for the last thing. And you didn't use your calculator here, So that's for 3 marks. If there are any questions on anything that we are going to write down, as mentioned, you want to just switch on your mic, and then you just want to speak, and you shall be heard. You won't be like being rude or anything. Nope, not really. If you need to say something, you kind of need to like switch on your mic, because if you say something via text, I'm probably not gonna see it unless I like go back out here and like look if someone has said anything. But let's move on. Let's try and like move on fast to like until we get to like the hard stuff, But anyways, it says here for 2 marks, write down the equation of the inverse of f. So as you can see here, it looks as though we are kind of still dealing with some of the easier questions, and it's okay, Some of these questions, they're easy, they're okay, you get your marks, you move on. So before you perform inverse here, you can just rewrite this normally, so that f of x, you just show that it is a y. So if you haven't started with inverse yet, with inverse, the idea is all you have to do is you have to take an original function, and then you literally have to swap x and y. Like x becomes y, and then y becomes x. You literally swap these around. That's what inverse is. When you've done that, you end up with a new equation. You see, that new equation will be the inverse of the original one. You see, and this symbol here is the symbol used for inverse. So with us performing inverse, you see here we have not done inverse yet. Everything is still normally the way it was, but then here we're going to perform inverse. So as long as you have shown this somewhere on your paper, just the x becoming a y and the y becoming an x, you can then just do it. You see, y here becomes x, and then x here becomes y. And then we're going to do exactly what we said at the top again. You know, this is something you will repeat over and over again. This is a base, this is an exponent. So that's exactly what we need to keep in mind here. This is a base, and this is an exponent. You see, it makes your life easy. Base, exponent, and then whatever this is just whatever value. You see, and then you've performed inverse here. I mean, if you want, you can just write the y first, you know, just for the vibes, but meh, it is what it is. So this will give you your 2 marks. Now, I think in terms of the questions that we're doing here, if you're feeling that they're easy, that's fine, because they actually are. These are the kinds of questions you should always just blaze through them in your paper. Now, don't maybe do silly mistakes, you know, and not get all these 2-3 marks and all that. Like, don't make silly mistakes with easy questions. So for example, here they're asking us to write down the range of f of x. So them asking us to write down the range of, they're asking us to write down the range of the inverse. You see, so I almost made a mistake there. So anytime you see this symbol, we know they're speaking of inverse. So don't confuse it later on with the symbol for first derivative. You see, if you haven't started with differentiation, it's fine. I'm like, as we're going through this paper, we're obviously going to touch on differentiation. So differentiation, it's a different symbol. It's more like, what is this thing? I don't know, hyphen, no, apostrophe, whatever they call this punctuation mark. This is for differentiation. This is for first derivative, first derivative. So if this is not like making sense, don't worry, it's okay. Don't worry about it. This means inverse. So they want us to write down the range of the new graph. So the good news is the range of the new graph. This is one thing with inverse. Inverse should always be the kind of a section that you should always be very comfortable with, you know, because the idea of inverse is literally the whole what you call swapping around x and y. That's literally inverse in a nutshell. So let me explain this question in a way that incorporates the properties of inverse. It says write down the inverse of, write down the range of this new graph. So let me put it this way. With inverse, remember we said x becomes y, and then y becomes x. Now with inverse, it doesn't just end at swapping the x's and the y's. Whenever you perform inverse, every property of your original graph swaps around with the inverse. If anything, for example, whatever has to do with x for the original graph, it will be referring to y for the other one. Whatever has to do with y for the original graph, it will be referring to x for the other one. So this is what I mean. With an original graph, let me put it this way. You have an original graph here, original graph. Say you have an original graph here, and then say you have the inverse over here, right? So the idea is, oh, good Lord, shame, man. People are joining late. Hey, Tina, we're just going to carry on because, we have to carry on. Let me just add this person. So with the original graph and the inverse, right, this is what you want to remember. The domain of the original graph becomes the range of the inverse. The range of, just mute this mic because why not? Problemo. So let me just say that again. The domain of the original graph is the range of the inverse. The range of the original graph is the domain of the inverse. You see, so with inverse, not just the x and the y values swap, the properties of your graphs also swap, meaning whatever was the domain becomes the range. Whatever was the range becomes the domain. You will just write it in terms of y, and here you'll just write it in terms of x. So let me give you an example. So with this f of x, right, let's get the domain of f of x. So if we're looking for the domain of f of x, remember domain just asks you, where do you see the graph on the Cartesian plane if you're looking at the picture along the x-axis. So if you're looking at the picture along the x-axis here, let's look at the x-axis. The x-axis goes from left to right. Now, looking at the far left, we don't see any picture on the far left. You see? we only start seeing our graph after the x value 0. You see, after the x value 0, that's the only point where we start seeing our graph. So we know that from this point here, going all the way to infinity on the right side, that's where we see our graph. So that's the domain of our graph. The domain of our graph is literally just your x values are bigger than 0. That's your domain of the original graph. You see, the domain of f of x is just x is bigger than 0. So the domain here will say x is bigger than 0. So because we know the domain of the original graph, automatically the range of the inverse is going to be y is bigger than 0. Because literally all you do is the domain of the inverse is automatically the range of, the domain of the original graph is the range of the inverse. All you do is you swap the x and the y. Whatever is x here, you just make it y here. So to make better sense of this, let's get the range of this picture here, the range of our original graph. The range of our original graph, remember, range just asks you where do you see the image along the y-axis. So if you look at the y-axis, like looking up here, you do see the picture. You see up here, you are seeing the graph. You're seeing it over here. You see? So looking up here, you do see a curve over there. And then looking down here, you also do see a curve, and it goes all the way to like negative infinity. So you can see that your graph going downwards, it goes all the way to negative infinity. Upwards, it's clearly going to go all the way upwards to positive infinity. So the range of our original graph, we can clearly see it's just y is an element of R, because we see the graph going everywhere upwards, we see the graph going everywhere downwards along the y-axis. So this is the range of the what you may call of the original graph, right? So if this is the range of the original graph, automatically it means that the domain of the inverse is just x is an element of R. We don't even have to think of it. All we know is whatever is a property of x or y here, it just swaps around for the inverse. So whatever the domain was, it becomes the range. Whatever the range was, it becomes the domain. So when they ask us questions like these concerning the inverse, we just have to work with properties of the original graph and then use those properties to just know information about our inverse graph without even knowing what the image looks like, you see. So here, them asking for the range of the inverse, we just have to get the domain of the original graph. Because if you get the domain of the original graph, you automatically have the range of the inverse. So your answer here, which is our final answer, let me just delete this so that we don't confuse anyone. So for 4.4, the answer is that our range of our inverse is just going to be y is bigger than 0. You see, the reason we're putting y is bigger than 0 is because all we did was we worked out the domain of the original graph, and then what we then did was we just swapped it with a y. That will give us the range of the inverse. So here the range is just y is bigger than a 0. They'll give you 2 marks for just writing this out. All this that we've done is just an explanation, but on your side, all you'll have to do is to just put this as an answer. So let me just add here from Nwabisa, and then we shall carry on. So as mentioned, if there are any questions, always feel free to ask. And with all that I've mentioned now, the one thing I can also say that I think is going to be useful is literally just today, just today on the Zoom Sessions channel, because the Zoom Sessions channel is like low-key new. The tutorial that went up is a tutorial that was dealing with domain and range, like more in a detailed format. Because I think sometime last week or something, I was having a Zoom session and then someone asked about domain and range. And then we literally like went through, just step by step what domain and range is. So if you feel as though you need better clarity on what domain and range is, then my suggestion is that you watch me call. What's the name of the video? So the name of the channel, the Zoom Sessions channel, is just grade 12 math Zoom sessions. It's this one over here. You see, Maths grade 12 Zoom sessions. It's like super new, and tutorials, they are uploaded like every single day. That's why you see here, there's a video that went up about an hour ago, and you see here sometime in the afternoon, this is what was uploaded. Domain and range tutorial on all functions and graphs. So you can see here, this tutorial is going to be giving you the basics of a parabola, an exponential graph, a straight line graph, a cubic function, everything on domain and range. So what we have just discussed here, you can imagine that tutorial is going to give you a much more extended idea. So for 2 more marks here, what does it say? It says the function h of x is this. They said this function is obtained by applying 2 reflections on f. I'll repeat. They said here you have a new graph. This new graph, you're going to call it h of x. Now, h of x is 3 over 4 to the power of x. They said it is obtained by applying 2 reflections. So when they say applying 2 reflections, you just have to be a bit open-minded, because when they're talking about the reflections here, they're talking about either a reflection about the x-axis or a reflection about the y-axis, you see, either or. So here you can imagine you have a y-axis and then you also have an x-axis. So, and you also have like an original image to work with. So whatever our original image is here, let's actually deal with the original image, because what you want to take note of is no questions are just like standalone, you know, they're just there on their own. No, you don't have questions like that. All questions, they almost like just stack on each other. So let's just carry on reading. It says the function this is obtained by applying 2 reflections on f. So this is f, right? And then they say here, write down the coordinates of b, which is write down the coordinates of b with these 2 punctuation marks here. So we should write down this coordinate here, which is an image of b on this new graph. So what they mean is this picture here, this is f of x, right? This is like the original graph of f of x. We're seeing it here. Let me maybe make it a bit bigger, because why not? So we are seeing here the original image of f, right? It looks like this. Now the equation of f, we should not ignore what the equation of f of x is. The equation of f of x is this over iso. So let us take that iso and then let us post it down here. So this is the equation of f. Now, what did they say? They said that you have point B over here. So point B is, we worked it out to be, I think the P value was, what did we get for P again? Oh yeah, we got what? We got Y as a 2 there. I feel like, what did we do, Vele? Oh, we wanted to get a Y value here, and then we worked out the Y value to be a 2. Yeah, perfect. So here we got our Y value, which was 2. And let's just put here P is a 2. So the Y value that we worked out here is representing P, because P is the Y value of our graph. So yeah, P is a 2, right? So let me just put this here in our image. So P here is a positive 2. Let's just put that nicely, 2. Okay, so we have here B is 16 over 9, coordinate 2. Now they said, looking at f of x, we had 2 reflections happen, and then this is the new equation. So if you look at what originally is our image, our equation, right, is originally this. F of x is equal to log 4 over 3 with x there. This is the original graph. Now from here to go to this graph, you have to imagine, I mean, like, yeah, something has to happen. But without you like guessing or anything, just do it systematically. So one way to think about it is, firstly, when you hear the words reflection in your functions and graphs, right, a graph can be reflected about, it can be reflected about the y-axis, it can be reflected about the x-axis, and then something else that a graph can be reflected about is the line of inverse. You see, the line of inverse is the line y is equal to x, you see. So three lines, three distinct lines that you can potentially reflect a graph about. You can either reflect it about the y-axis or the x-axis or the line y is equal to x. So us knowing that, right, we have to think to ourselves, okay, fine. I mean, like, we have to think of these things bit by bit. To go from here to that, I mean, like, yeah, two reflections kind of make sense. So what you can do for yourself is our inverse function here. Where is the inverse of this graph? This is the inverse of f of x, right? So I think it's best if we maybe try and use this as one of the reflections. I mean, like, I don't think it's too far-fetched for us to think that from f of x to get to h of x, you probably reflected it about the line y is equal to x, meaning you performed inverse first. And then after performing inverse, I think one other step or one other reflection can eventually get us this, you see. So I think that's like the train of thought that we can use for this particular question. So here, let me just replace this with the inverse function symbol so that we are all on the same page. So based on our train of thought, right, for us to like get our answer here, we're saying that firstly we started with f of x, and then the first thing that happened was we reflected this graph about the line y is equal to x. So that's the first thing we did. And then secondly, we don't know what needs to happen next for us to end up with the equation h of x equal to 3/4. But I think this one is a bit easier to kind of like figure out, because what we're seeing here is that the 4 and the 3 practically swapped around. You see, the 4 and the 3, they practically swapped around here. Now, with this kind of a scenario, I mean, like, we kind of have to be just a little bit creative. And one thing we can think of is how fractions behave when you eventually like flip over the numerator and the denominator. So anytime you see that a fraction has been flipped over, right, it all has to do with the exponent of that fraction. So let me explain. So if you're starting off with 4 to the power of 3x, right, and you end up with 3 to the power of 4, I mean, and you end up with 3/4 to the power of x, from here to here, you can already see that all that has happened is the numerator and the denominator swapped around. And a scenario like this, it all has to do with negative exponents, you see. So all that has happened is from 4/3 to the power of x, right? If you have a negative exponent, if you, let's say, have here 4, oh, this thing is not writing. Come on, bro. Come on, man. We need you back. Hold on. Let me see here. There we go. Okay, it's writing again. So for you to go from this to this, right, you have to think to yourself, firstly, if you have 4 to the power of 3 with a negative x, you see, the one thing you can always look at this as, 4/3 to the power of -1 multiplied by the x here. And your exponential laws will always tell you that you can always deal with this together, and then whatever answer you have here, it'll just be to the power of x, of which, if you're looking at what we have over here, right, this is technically just going to be 4 to the power of -1, 3 to the power of -1, the whole thing to the power of x. And then because these have negative exponents, we will just be able to like swap them around, and then the exponents will become positive. So here the 3 will go on top, the 4 will go at the bottom, and then you'll just have your x over there. So just our train of thought, for us to go from this to this, the one element that puts all that in motion is a negative value over there. And us having a negative x over here, it is clearly a reflection about the y-axis. I'll explain just now. Us having a negative x here, it's a reflection about the y-axis. The reason why it's a reflection about the y-axis is because if you look at it nicely, remember on the right side here, you have positive x values. And then on the left side here, you have negative. Let me make these colors a bit distinct. On the right side, you have positive x values. On the left side, you have negative x values. Now, for you to go from a positive x to like a negative x, it's a reflection about the y-axis. You see, because like this is where your y-axis is. If you're going to go from plus to negative, you are being reflected about the y-axis. If you had gone from positive y values to negative y values, then you would have reflected about the x-axis. So in our case here, we're saying from us to go from a positive x value here to like a negative one, it's purely just a reflection about the y-axis. So now we know from this original graph, the first reflection was about the line of inverse. And then the second reflection here was about the y-axis. You see, those are the two reflections that occurred. And we're saying the second reflection is about the y-axis because to go from here to there, you would need to have a negative exponent over there. And the moment you're thinking of a negative exponent over here, it's a reflection about the y-axis. And we've just proved it right now because negative x here is the same as negative 1 times x, of which 4 over 3 as a fraction to the power of negative 1 and the x there. You can always just look at this part first, which is giving us this. And then because these are negative exponents, you can just swap them around. And then this is what you have. So with all this being said, right, like you can imagine, we're going through a past paper, you know, so if most of these questions, it's like, yeah, it makes sense, but you know that maybe in the future you won't necessarily be able to like remember, then I feel like then all you need to then do is you do need to enroll into like the functions and graphs course. Because remember, things like the online course platform, they basically go deeper into like individual topics so that you eventually know the train of thought of what to think about when you bump into a question, so that you don't feel as though you need to like guess or it's luck or whatever. Because you can imagine when we started with this question, right, two reflections, yes, but then from theory we knew that there can only be one of three things that could have happened: line of inverse, y-axis, or x-axis. And then here we just worked it out until we got, okay, it's a reflection about the line of inverse first, because that's how they went from this to this. And then from this to this, they just reflected it about the y-axis. So that's just 2 marks. So if these kinds of questions are not your cup of tea, then don't waste time trying to figure out a 2-mark question when you know it's not your cup of tea anyways, you see. So you'll just need to move on and then only come back to these later until you've like sorted out your theory. Anyways, question 5 here, right? Functions and graphs. We can clearly see here we're dealing with a hyperbola. So with this hyperbola, it says here the graphs of f of x and parabola g are drawn below. So while looking at what has been drawn down here, already we need to remember certain things about our standard form. So remember, your standard form already gives you the x asymptote. It already gives you like the y asymptote. But the issue is with the x asymptote, it's always the opposite. Meaning if it's a +1 here, on the actual Cartesian plane, you will see this at -1. They didn't show it here, but it's something we should know from the equation. For the y asymptote, we take it as it is, meaning whatever it is on the actual equation is what it is on the Cartesian plane. So this will be an actual 4. You see, there's a 4 there, so there's a 4 there. There's a +1 here, there's a -1, because for x it's the opposite. But then for y, you take it as it is, and I need to add these peoples and go back because we are busy. So anyways, with that being said, here they said C is the turning point of G. So the idea is, as you're going to be reading whatever it is that you'll be reading, right, always make sure to refer to your sketch. Because if you don't refer to your sketch and just read, that's a problem, you see. So that's one thing I can say repetitively. If you read something, always go back to the sketch and then just double check or verify what you're reading. Not to say what you're reading is going to be different from what you see. It's just so that it links up in your head. So the other thing is always take hints of other information they'll be giving you. Automatically here, you already know that the y value of C here is a 4, you see, because you can already see that the turning point is on the asymptote. And don't put yourself in a situation where you think things like the sketch is not to scale or whatever, because funny enough, these sketches are always to scale, you see, meaning if it's showing that it's passing through the origin here, don't think to yourself, it maybe just looks like it, but it probably isn't. Nope. What it looks like is what it is. So the y value here is a 4. You just don't know what the x value is here, but it doesn't matter. Instead of me like over analyzing, the one thing I'm trying to do here is to mention a lot of things that we need to just keep in mind about our graphs, you see, of which with this specific graph or with all parabolas, the one thing you should already know is that this x value and this x value, your turning point, the x value of your turning point is right in the middle. So if, for example, this is like an 8, no, that's a better example. If this is like a 6 and this is a 0, in the middle here, you're going to have a 3. You see, that's just an example, but let's move on. It says here the graph of G passes through the origin. Yes. And then it says B is a point on F such that BC is parallel to the x-axis. So BC is a line parallel to the y-axis. So it's a straight line going straight downwards. So okay, that's something they're probably going to refer to later. So all this being read, let's see what the first question is asking. The first question says, write down the domain of F for 2 marks. So as we said already about domain and range, right? We mentioned that domain will just be asking you, where do you see the image from left to right? Like which x values does this graph occupy? Now from left to right, the fortunate thing is with all hyperbolas, you know, the domain and the range, you always look at what your asymptotes are. So for domain, you're going to ask yourself from left to right, which x values does this graph not touch? Now, this x value, if you look at the curve, the way the curve is behaving, right? If you look at the way the curve is behaving, going to the far left is going to go everywhere. Going to the far right, it's also going to go everywhere. Now, as you can see how these curves are behaving, they are all approaching -1, but never touching -1. So the domain here, we're just going to say x is an element of R, meaning x can be any value. However, x cannot be equal to -1. You see, because your y value, x values of this graph, the ones that give a valid outcome are all the x values except for -1. You see, because if you were to throw -1 in here, you'd have -1 plus 1 at the bottom, which is like a 0, of which a 0 under the denominator is like undefined. But then if you were to throw in any x value into this equation, it's always going to come out with something valid except for -1. You see, that's what the domain is saying. Which x values give something valid when you throw them in there. And here we're saying it's all of them except for -1. So that's for 2 marks. Moving on. For 5.2, it says determine the x-intercept of F. So yeah, as well on this question, the one thing I can also just maybe say again is, yeah, with math, yeah, there's no need to be like take notes or something. So whatever is happening here, I think, yeah, let me just carry on. Let me not be too extra. So if you're gonna get the x-intercept of F, right? F is our exponential graph. Now the y-intercept, oh no, they said x-intercept. So the x-intercept is this one, where it's cutting the x-axis. So you're getting the x-intercept. I mean, we already know all you need to do is to make y equal to 0 in the equation, because an x-intercept is a coordinate. You see, you don't know what the x is, but you know that the y values are 0. Now, anytime you're dealing with the coordinate, always refer to the equation. You see, because your equation is like a big hack. You know, you just throw in x values, it gives you y. You throw in y values, it gives you x. So this is the equation of our graph. F of x is equal to, what is it? 2, and then x plus 1, and then the 4 down there. 2, and then x plus 1, and then plus 4. Now in this equation, all we have to do is Y we have to make it a 0, and then all we have to do now is to solve for x. Solving for x is practically our only job, you know. All right, our only what? Our only mission, really. So the 4 we can take it over. It's gonna be a -4. This is like 2x plus 1. As long as you're dealing with a fraction on one side, right, you might as well make the other side a fraction, because, you know, why not? This now we can cross multiply. 1 times the 2 is a 2. -4 times the x plus 1, you can just write it like that. And then you're going to have -4x minus 4 equal to 2. The 4 goes over to the other side. Then you're going to have -4x is equal to 2 plus, is it plus 4? Yeah, plus 4. And then divide both sides by a -4. We are going to get what? What are we going to get? Let us see. In your calculator, the simplified version of this, I think it's going to be like -3/2. And looking at our image, yeah, always try and use your image to boost your confidence, you see. Because if you're seeing an answer here that says -3/2, yeah, that's kind of valid. Because -3/2 is like -1.5. So if you have -1 here, -1.5, yes, it definitely is going to be close to that. So you can be rest assured that it's definitely 2 marks in the bag there. For 3 marks, they're asking us to calculate the value of k. So if you look at what we're doing, whatever question we have, we're always going back to the sketch and the description, because where else are you going to go? You know, where else are you going to go? So them asking for k, the idea is, okay, where is k mentioned? K is the x value of b. So that's what you should now boil down the question. The question is just asking for the x value of b. Now, the other thing is you ask yourself, okay, fine, where is b? B is a point on f. So these questions, they seem to be very direct, you know, they are just so direct. It's an x value, it's a y value. And they have an equation that you're given. So I mean, like, if you need the x value of b, you're just gonna throw in the y value in there. It's also the reason why this is also just a 3-mark question, because there's really nothing much that's special about the first 3 questions we've done. If you can look at the first 3 questions we've done, we've mainly just worked with the equation of the graph, you see, which is what we just need to be comfortable with. We need to be comfortable with working with the equation of a graph. If you can work with the equation of a graph, you is going to be unstoppable. So I don't know what is on my throat. I keep going and is annoying me. But let's see. This is the y values, this is the x value. So where y is, we're gonna put 14/3 there. And then where x is, we're just gonna put a k. And then we have to solve for k. So solving for k here, I mean, like, I think the issue with functions is being able to simplify and being able to break it down comfortably. That's honestly speaking the first thing, or that's basically all math. Being able to simplify, because sometimes you will know what to do, but it's like, but what happens? So here, let's just take everything to one side if it doesn't have a k. So this fraction, let's leave it. Let's take the 4 over to the other side. Now, what you can also do for yourself is get super comfortable with working with the calculator. I'm saying get super comfortable working with the calculator, but I'm looking at this and I'm like, I don't have a calculator close by, so aye. But 14/3 minus 4, it is going to be 2/3, if I'm not mistaken. Yeah, this is very, yeah, it's a dangerous game, you know, not using the calculator. It's like a super dangerous game. Now, if anyone has a calculator close by, as a belief, just double check this. If it's fine, it's fine. If it's not fine, please let us know, because yeah, we just want to be fine. But it looks okay, because all I just did was this. If you put it over 1 and you have here 3/3, you're gonna have 12 at the top. So 14 minus 12 is a 2, and then the denominator is just a 3. So that's what happened in my head, or I think that's what happened in our heads. So since we have a fraction here and a fraction here, we can now just cross multiply, because cross multiplying is as good as getting an LCD, but it's like, you know, just killing two birds with one stone. So here 3 times 2 is going to give us a 6, and then 2 times the k plus 1 is just that, you see. So from cross multiplying, this is what we end up with, you see, because remember, cross multiplying, just focus on what's at the bottom. The bottom times the top there, the bottom times the top over there, you see. And then that's how we ended up with this thing over here. So us having to have what we have here is just 2k plus 2 equals 6. And then you're going to have 6 minus 2, 2k. This is like 4, 2k, and then divide both sides by 2. You're going to have, yeah, I wrote the equal to sign too early, as always, as always. So here you're just going to have a k value of 2, which is, let's see if it's believable. K value is 2, meaning the x value of b is a 2. According to the sketch, I mean, could this potentially be a 2? Yeah, it looks like it. Because remember, we say this is a sketch to scale. So what you see, it needs to be believable. So if the distance here is like a 1, then it means to the right side, the distance 1 should end up here, you see. Meaning 1 again, you would have a 2 there. So that kind of does make sense, that the k value here is a 2. And you can see what I'm doing here. Get an answer, just try and fact check it. Don't just move on, you know, because there's no need to rush. You kind of have time. I know it's kind of like a condescending thing to say. Oh, it's not really condescending. Saying you have time. You do have time. The only thing is sometimes when you think you don't have time, that's when you end up not having time, because you're thinking about it the whole time. So you end up wasting time. And then the next thing you know, you don't have time. So yeah, it's just the way you think about it. And it looks like the next question is going to be again us working with the equation. 4 questions down the line, and we're literally working with the equation of the graph. Now, this is not something that should alarm us. It should educate us to know, okay, it looks like knowing how to work with the equation of a graph is 3 marks, because that's what all these are, all these questions. Them asking for C is the turning point of our parabola. Now, we don't have any equation of the parabola. But then if you remember what we mentioned in the beginning, we said that you need to know things like how if this is an x value and this is another x value, the turning point will always be directly in the middle. Or rather, your turning point will always be in the middle of your 2 x-intercepts. Now, the fortunate thing is here, wow, coincidentally, I just wrote the value, the coordinate of C in the previous question, just because of all the information we had filled in. Because if you can recall from the previous question, we had already stated things like how as long as our turning point here is on the asymptote, it means that the y value is a 4. And then we also did mention that as long as, maybe we didn't mention it, but they told us that BC is parallel to the y-axis. If BC is parallel to the y-axis, it means that BC is a straight line going down, meaning the x value of B is also the x value of C. So yeah, this was literally got an answer by mistake. Okay, not a mistake, but yeah, wasn't even looking for it. So it's gonna be a bit awkward for 3 marks, I mean for 2 marks to just put the coordinate here, but that's literally what they will give you 2 marks for, just writing it out, because working it out is purely by observation based on what you worked out. What you know is that the B and C have the same x value, so you put an x value of 2 there. What you also then know is that the y value of the turning point is on the asymptote, so you can just put a 4 there, because the asymptote is cutting your y-axis at 4, you see. Now, all this is good enough to get all your marks all the time. The only thing is, most of the time, we are always thinking, okay, I need to do some calculation to get my marks. And that is not true. If you can just get the answer by seeing it, and it's like 2 marks or 1 mark, just write the answer. Don't worry about working out anything, so that you don't spend time like stressing about what to write down, but yet the answer is like right in your face. So yeah, that's going to be 2 marks. Now, let's see what these follow-up questions look like. I feel like what's important about this question is the rest. So for 3 marks, right, they're asking us to get the equation of this parabola in this format. Now, the one thing I can say is them asking you to get an equation in this format, it's them being nice. But whichever format they'll usually ask you to get an equation is in, whatever format they'll be referring to, there's always a way to get it, especially based on the information given and all the questions asked. Now, the one thing you can always remember is that with all functions and graphs questions, or with math in general, especially how these papers are laid out, the thing that you have at your disposal is the information given originally and everything else that you worked out. So don't now think to yourself, oh snap, if I forget or if I lose one question, then I don't get the rest. Think of it in reverse. Think of it as if you can just understand the follow-up questions, you can be rest assured that the follow-up questions, the ones that come after whichever ones you answered, they're going to get easier and easier as long as you can make use of what you have just worked out. Just like what we're going to do here. The first thing is we need to know what all these variables mean, specifically P and Q, because A is just the shape. You see, A is just the shape of our graph. Whether it's smiling or frowning, it's purely based on the value of A, of which, if you look nicely, I mean, like, it's so in our faces, it's a frowning graph. So in as much as we don't know what A is, what we already know is that A is a negative value. You see, A is a negative, or as they like to write it, they'll say A is below 0. This is just saying A is a negative value. P and Q, we know that P and Q will always give you your turning point. You see, turning point, turning point. Now, the turning point, fortunately, we have it. It's the coordinate of C. So we have P and Q. But the issue is, with P and Q, whatever it is on your Cartesian plane, always keep in mind that for P, it's the opposite. But then for Q, it stays the same. What I mean is, in the equation of your graph, right, you have here y is equal to A. We don't have A yet, so let's just put A. Here, you need to be careful because your turning point is 2 coordinate 4. For P, you're going to have to put a -2, but then for Q, you take it as it is. I'm going to put a +4 there. So far you can imagine this is going to give you 2 marks so far because of this and because of that. But why get 2 marks when you can get all 3? Like, hello. So for the A, all you need is just a coordinate that the graph passes through. You see, you need a coordinate that the graph passes through. So you needing a coordinate that the graph passes through, it cannot be a random coordinate, but then it doesn't have to be anything difficult or crazy. Like, fortunately, you don't want to obviously use the turning point itself. It's not going to work, because if you use the turning point, you're going to put a 2 there, which is going to be 2 minus 2, and then this is a 0, 0 minus 0 times A. The A is gone, but you're trying to work it out. So if you're going to choose a coordinate that the graph passes through, use any other one, of which, fortunately, because of our description, as we all are probably thinking, the origin is a coordinate. Now, using the origin is something that most people sometimes don't even do, but I mean, it's as good as a coordinate as any other, you see. So x is a 0 there, and then the y value is also a 0, and then here you have 4a, because this is -2 squared, which is a 4. And then what you got? The 4 is gonna go over there. Divide both sides by a 4, you're gonna have the -1, so that's like A. And then you is done. So as expected, we expected a negative value. Whether it was 1, 2, 3, doesn't matter, as long as it's a negative. So here we're done. You see, therefore, y is equal to -1 x minus 2 squared A plus 4. There we go. Okay, so far so good. 5 marks, 5 questions down the line. And the one thing we can clearly see is how with functions, your sketch is important. Your sketch is very, very important. So with the next question, we have inequalities here. So stuff like this, right? I think if you check on the main channel, you will see questions like these in the inequalities playlist. Inequalities. Let's see. Now, for you to be able to answer these kinds of questions and get your full marks, you need to understand what the question wants. Because most of the time, people look at these and they bomb out because they just don't know what they mean. When I say they, I'm actually referring to myself once upon a time, because these were like, hey, you just look, you look twice, and then you keep going, because it's like, yeah, why not? Why struggle unnecessarily? But the way to understand these questions is you need to keep in mind that anytime they're referring to f of x, they're just talking about the y values of f. Anytime they're referring to g of x, they're just talking about the y values of g. You see? So the question is asking, where will this expression be a number that is smaller or equal to 0? That's what the question is saying. They're saying for which values of x will this expression be smaller or equal to 0? So what it means is, which x values, if you throw them in both equations, which x values, right, when you throw them into both equations, will result in this whole thing being a number that is smaller or equal to 0. So even though in interpreting it is like, okay, fine, I get it, y values of f, y values of g, where is this expression smaller than 0? Understanding that question is like step one. The next thing is knowing how to then answer that question. So the first way to know how to answer these kinds of questions is to remember that firstly you're dealing with a fraction. Now, a fraction, if it is going to be a number that is smaller than 0, let's deal with it being smaller than 0 for now. If your fraction here is going to be smaller than 0, let us rescue our fallen comrade. If your fraction here is going to be smaller than 0, it means that the only two cases where your fraction can be smaller than 0 is if the top is a positive number while the bottom one is a negative, or the top one is a negative while the bottom one is a plus. These are the only two scenarios where your fractions are smaller than 0. I'll repeat, this is a fraction. A fraction will be smaller than 0 if the top is a positive number while the bottom one is a negative. Vice versa, if the top one is a negative and the bottom one is a positive, the fraction will also be smaller than 0. So I mean, like, cases where this will be equal to 0, let me just put this here. Cases where this will be equal to 0, it's clearly cases where only the top is a 0, you see. So f of x over g of x will be equal to 0 if f of x is a 0, meaning if the top is a 0, Let me not even write it. Let me just show it as an image because it's easier to look at. So this will be equal to 0 if the top is a 0. It doesn't matter what the bottom is. The top just has to be a 0. But then whatever we do, the bottom should never be a 0, because that will just cause the whole thing to be undefined. Now, with all that I've said, right, sometimes it seems like a mouthful, which it is. But then the moment we will start working on this question and actually start solving it, you will start to see the logic behind all that we have said, you see. So let's actually start now answering the question so that we can move on. But before that, let me just do this. Sorry, madam. So anyways, let us move on. So with this question, right, these are how you answer these kinds of questions. You answering these kinds of questions, what you actually need is your sketch. This is why if you check in your in past papers, right, you'll always see that they normally actually do this for paper 2 actually. They will give you in your answer sheet, right, in your answer booklets, they'll always give you like images of sketches that you have in your question paper, so that you're always able to draw them and all that, so that you can see them better also. The reason for that is for questions like these. So with this kind of a question, it's purely a question where you're going to use your sketch. Literally, your sketch is going to answer questions for you. So this is how you answer this kind of a question. So you want cases where this is happening. Just focus on this first before worrying about this, because you want where this fraction is below 0. Now what you want to do is you want to, in your image here, just look for cases where the first thing you look for is cases where everything is equal to 0. Just look for cases where your graphs are cutting the x-intercept. Like, take note of those points. So that's happening over here, and over there, you see. So what you then do is you want to go to these x-intercepts, because remember, these are the cases where your graphs are equal to 0. They are not necessarily below 0, or they are not necessarily above 0. These are cases where your graphs are equal to 0, you see. These are cases where your y values of your graphs are equal to 0. So let's keep that in mind. Secondly, what you want to do is go to each of these. Oh snap, I messed up the image. Let me redraw again because I moved my image. Equal to 0 there, equal to 0 there, equal to 0 there. What you then do is just draw like dotted lines. So just put dotted lines here. Dotted line over there. Dotted line over there. A dotted line over here. Perfecto. Now this is all you need to do. So all you need to now do is you need to look in between each of these, right? For cases where this has positive while the other one has negative, or for cases where this has negative while the other one is positive. But let me simplify it. All you want to do is you want to look at your Cartesian plane from left to right. Looking at your Cartesian plane from left to right, you want portions of the sketch where the one graph has positive y values while the other one has negative y values, you see. So if you look nicely, this is not happening here. You don't have one graph having positive y values while the other one has negative y values. You don't see it in this space here. But then right in the middle here, you can see that it's not happening here. But then just here now, you can see that this graph has positive y values while the other one has negative y values. So this is a portion of the sketch that qualifies. Moving on, you can also see that this portion does not qualify here, because this portion only has this having positive y values, and this also has positive y values. So it doesn't qualify for our answer. So we keep moving forward. If we look after this dotted line now, we can see this portion qualifies for our answer, because we do have positive y values there, and down here we have negative y values, you see. So this portion here and this portion only, those are the only portions that qualify for our answer for now, before we go deeper. Because if you look nicely, right, we said we just want cases where one graph has positive y values while the other one has negative. We want a case where one graph has negative y values while the other one has positive. And we are seeing it only happening at these x values here and at these x values going to infinity. So as a portion of your answer, that's what you need to consider, you see. But before we write out an answer, we know that we should just be careful. But let me not overthink it yet. We'll overthink it after we give these answers for now. So giving our answers, right, we're going to have to say here, the portion of our question or the portion of our sketch that is going to give us an expression that is below 0 is where x is between, remember this here, we said this was like a -1. So looking at our sketch, you can see that the portion where your sketch qualifies is between -1 and 0, because we can see that this is just going to go down all the way to like infinity, but then it will never cross -1. Same here, this will just always go up, but it will never cross the -1. So the portion of our answer here that is valid is x is an element of -1 up until 0. The reason why we're putting a round bracket at 0 is because specifically at 0, the graph of G is a 0. You see, meaning if you do put a 0 down there, the whole thing is going to be undefined. So we want to make sure that we only say from -1 to 0 instead of saying from -1 to 0. but including the 0. So the round bracket there is us not including this specific number. We're just trying to say in between that space only. Now the other portion of our answer that is valid is where our x values are an element of positive. So you see here, we don't have this x-intercept, right? But then because of our general knowledge, we know what that x-intercept is because of what we said. We said that a parabola is symmetrical, meaning that the distance from the center or the x value of the turning point until one x-intercept is the same on the other side. So if this distance is 2, it means that this distance is also 2, meaning this is a 4. So that is already something we should know because they're not going to tell us. We should know it. So here we're saying that the graph or the image that qualifies for this question is from, I need to find the green now. It's from 4 all the way until positive infinity, like that, you see. So here we're not including the 4 because specifically at 4, the graph of G is 0. And we said that you cannot have a y value of 0 at the bottom, you see. Because if you throw a 4 in the graph of G, you're going to have a 0 come out, you see, meaning you're going to have a 0 there. And we said here, all this is saying is y values of G, you see. So here we cannot have a y value of G that's specifically equal to a 0. So that's why here we're excluding the 4, because if you throw a 4 in there, a 4 comes out as a 0, and having 0 down here is it's undefined, so it won't work. That's the reason why we have to make sure to put a round bracket here, because we're saying our answers are from 4 to positive infinity, but then the 4 we don't include it specifically. So for this question in particular, it's out of 4, but then this is all you need to say, because all you have said here is taking into consideration these 3 scenarios. These two scenarios, we covered them. And then this one will never happen because your expression is equal to 0 if the top is, oh wait, yeah, this one we have to consider it also. So these ones are covered, but then we should not forget this, because we said, remember, this is twofold. This is asking where is the expression smaller or equal to 0. Now we dealt with smaller than 0 first, which is these two. We got our answers. Now we said this will only be equal to 0 if the top is a 0, which is f of x. Now, if we look at our sketch, right, there's only one instance where the y value of f is a 0, and that specific instance is here. An x value of -1 is, no, this is not -1. This is, we worked it out to be -3/2. -3/2. So an x value of -3/2 gives us a y value of 0 for f, of which us having a y value of 0 for f means that our whole expression will be equal to 0, which is part of our answer, or it's part of the solution that qualifies for this. So this is an answer, this is an answer, and then we also have to say here, or x is equal to -3/2, because that's what the question is asking. For which x values will this expression be valid? And we said, just break it up. They're asking for which values of x will this expression be smaller or equal to 0. So we said it's smaller than 0 over here and over here. And then we said it's equal to 0 specifically over there only. That's why this question is a 4-mark question. Now, you looking at this question, you can imagine how it's not like an entry-level question. It's the kind of a question where you do need to have gone through, quite a few of, not a lot, but like a few of these, where you do work with, okay, y values of f, y values of g, going on and on and on. But the fortunate thing is, a lot of these kinds of questions, you can see they always come up in past papers, which is cases like, which is things that is like heavily covered in the functions and graphs course. Like if anyone has been on the course platform, which a lot of you have, what you'll note is that the functions and graphs course is like the heaviest one. Not necessarily heavy saying it's difficult, it's just the one that has a lot of examples. because yeah, you can imagine a lot of these things are also there. So if you need more clarity on that, then that is definitely your best bet.
Levi,
Yo, what's up, Chloe?
I know you want to move on to the next questions and stuff, but I don't know. This is how I concluded it. So, like, I saw you were busy with the f of x and the g of x. So, I was looking at both in asymptotes, right? So, like, you were working with the -1 and the 4. So that's also how you got from your 4 to your positive infinity, and from your -1 to 0. So I was looking at it as like working with the x-intercepts of your parabola. So yes, so like I was working with that. So that's just my conclusion. So to ever was struggling with like doing it your way, because I feel that's much more simpler than doing it algebraically, because you can like, that's just my conclusion. So I was just trying to simplify it for someone if that's going to be useful.
No, definitely. Because yeah, definitely. I would add, but I think you said everything. So x-intercepts are important because they are the ones that clearly just distinguish where are the positive y values and where are the negative y values. So just look out for x-intercepts and then work with those, because you can see even our answers, all our answers here have something to do with specifically x-intercepts. There's an x-intercept there, an x-intercept, technically, I mean, the asymptote is cutting the x-axis there. There's an x-intercept there, there's an x-intercept there. All these numbers have to do with the x-intercept. And then it's not a coincidence that in the previous questions, if you look at the things they asked us, they firstly asked us for like the x-intercept of f, which was this. We ended up needing to use it. And then we mentioned how they mentioned this is the origin. We ended up needing to use it. We worked out this for, as we said in the beginning, we need it. We ended up using it. So I think that's a proper conclusion. Work with your x-intercepts and then practice more of these kinds of questions, and then they'll definitely get better. So yeah, I think that is that for question 5.6. It looks like 5.7 is probably going to be I will see. I'll do 5.7, and then whoever wants to stay can stay. Whoever needs to go, they can go. I feel like I just need to finish this paper today, to be honest. And then remember, all the papers, once they're done, I just cut out what I need to cut out, and then I just upload them onto like the past papers channel. Meaning that whatever other questions we're gonna look at, if you need to like go through them, they will be there. Because remember, everything is like, being stored and saved and everything. So I'm just gonna go through 5.7, and then I think I'm gonna finish the paper today. Question number 4, right? I mean 5.7, sorry. It says use the graphs of f and g to determine the number of real roots of this equation. Give reasons for your answer for 4 marks. What? Hey. What? Good Lord. Hey. Yeah, so anytime you read questions like these, I mean, like, obviously you want to read again. But then the funny thing is, maybe not like haha funny, but the weird thing with these kinds of questions is, don't maybe put them on a pedestal. Well, the reason I reacted the way I reacted is because, I mean, yeah, it does look weird. I mean, like, no one likes to read words like real roots in a question. It's always like, yeah, it's just one of those questions. Anything to deal with roots, yeah, there's a stigma behind it, but not to a point where maybe you should not know how to answer the question. It's just maybe the way I reacted. It's just it was a reflex action. But anyways, reading it again, before I even read it again, this is the idea with these kinds of questions, and this is why going through past papers is helpful, because during past papers, right, you'll find yourself bumping into similar questions. And I mean, compared to the past papers I've gone through, I already have an idea of what has happened here. The reason I'm saying what I'm saying is, before I read this question again, if we look at what f of x is, the equation of f of x is 2, and then x plus 1, and then plus 4. The equation of g of x is negative 1, x minus 2, and then plus 4, x minus 2 squared, and then plus the 4. Is it plus 4? Yeah. Yeah, plus 4. So the idea is, right, before we read this question again, what you want to recognize is that what you're seeing on the left side here, this is literally just the equation of f of x shifted vertically and horizontally. Yo, good Lord, horizontally. Finally. So this is literally just like the graph of f shifted horizontally and vertically, meaning it has been shifted from top to bottom or from bottom to top, and it has also been shifted from left to right or from right to left. It doesn't matter. This also here is literally just g of x shifted vertically and horizontally. You see, it's not like a guess, it's more like intuition, you know. Apart from it just being intuition, it's just how it is with some of these questions, you see. And you can see it's like the last question. So me having to have said what I've said, let's read the question again. It says here, use the graphs of f and g to determine the number of real roots
Levi,
of this equation. What's up?
can I stop you? Like, I would like
Please
for
do.
the vertical and horizontal shift, right? Like, can't you look at like with your previous equation that we made for g of x? Remember, we look at like our p and our q's, so that determines whether there was a shift. So, like for whoever, you can look at your p and your q. So if you see your p is different and your q is different, then you know exactly there was a horizontal or vertical shift. And when you
go on. Oh yeah, I was saying yes, ma'am. Sorry, I interrupted you.
Okay, even with your f of x, same applies. You look at like your y asymptote and your x asymptote. So you can see there's no -1 next to the x, and you can see from 4 to 5 a -5. So you can see there was a shift. So you can look at those things for you to know whether it was vertically or horizontally.
Thank you very much, madam. Thank you so much. Yeah. So for those that are wondering, I'm not like trying to take any credit now, but then like Chloe has been going deep in the online courses. Yeah, and it shows. It shows. So yeah, basically what you said is 100% what we're saying now, right? That the reason why we know that these have been shifted horizontally and vertically is mainly because if you're comparing these original equations, right, and you're comparing what you're seeing here, all that has happened is, for example, the 2 over x here, you can see the +1 is gone, you see, and that's how you see that it was moved horizontally, like from left to right, because anytime you move a graph from left to right, directly where x is, it gets affected, you see. So if it was a +1 here and now you see there's nothing, it means that clearly the graph was moved to the right 1 unit. I'll repeat, because there's a +1 here, right? For you to end up with this, let's actually just do it nicely and slowly to see what has happened from f of x to get this here. So for the blue, all that has happened is, right, all they did was they took the equation of f of x, you see, and then what they did was clearly they moved, I'll say it and then I'll write it out. They moved the graph 1 unit to the right because they plused 1 here. I mean, they minused 1. So a +1, if you minus a 1 here, you end up with nothing, you see. And then from top to bottom, for you to go from a +4 to a -5, clearly they moved the graph 9 units downwards, you see. So let's just put it that way. Let's just write out what has happened from this original F to this one. So vertically, it was moved 9 units down. The reason we're saying it's 9 units down, it's because it's from a 4 to a negative 5. So from 4 to negative 5, you're going to go down 9 times. For the horizontal shift, we said it was moved 1 unit to the right. The reason we're saying it was moved 1 unit to the right is because directly next to x here, you're starting off with x plus 1. And you're ending up with technically x plus 0. So because you now have a 0 directly next to x, it means that what happened was this whole equation was moved 1 unit to the right. Because if you move your graph 1 unit to the right, this is what you would write out. An equation moved 1 unit to the right. Wherever x is, you would subtract a 1 there. Meaning that in your equation, down here where x is, right? Directly here, down here where x is, wherever x is, you would throw there x minus 1. And then this plus 1 is just there, you see. And then, I mean, like the 4 would have just been there. Doesn't matter. That's not our focus for now. Our focus is just what has happened from left to right. So when you would have simplified this, you would end up with like 2x plus a 0 there, but you don't write the 0. And then you would have your plus 4 there. This is what it would look like the moment it was just moved 1 unit to the right. But then the moment they also then moved it up and down, it then affected the 4 there. So we're dealing with the horizontal shift for now before working on the other graph. So we say here horizontally, it was shifted 1 unit to the right. It was moved 1 unit to the right because from plus 1, if you minus 1, that's how you end up with a 0. And that's a shift to the right because that's how it works with x. For G, we can also try and see what has happened horizontally and vertically. So horizontally, I think is the easiest one to start with. So you can see that here you started with like having a minus 2 here. And now here you have a minus 3. So obviously from a minus 2 to a minus 3, it means that here you had minus 1 somewhere. You see, meaning that in the equation of G, what happened was this. Wherever x is, you're going to put x minus 1. This is to show that you're moving your graph 1 unit to the right as well. You see, because I mean, like if you move this graph 1 unit to the right, that's how you're going to end up with x minus 3 here. I think looking at it with the image is going to be a bit easier because if you look at it nicely, right? Where's this thing here? Where's this parabola? Oh no, yeah, this is our parabola. So with our parabola, if you look at it nicely, right? If you move your graph 1 unit to the right, your turning point is going to be somewhere there, you see. And the x value of your turning point is going to be a positive 3. Now, if your x value of your turning point is a positive 3, inside the equation, you would see it as x minus 3 over there. Because remember we said in the equation, you always take it as the opposite compared to the image. So moving 1 unit to the right is how you see that there is a minus 3 there. Because from a minus 2 to a minus 3, you minus a 1. And minusing a 1 is moving 1 to the right. Yep, yeah, I think saying it out loud sometimes is just a bit weird because you're minusing, but you're still moving to the right. So horizontally, we said it was a shift 1 unit right. So we said here, compared to this negative 4 and this positive 4, we can see that from a 4 to a negative 5, this was clearly moved 9 units down, you see, because I'm like from a 4 to a negative 5, it was clearly moved 9 units down. So vertically, we said 9 units down. Okay, so this paints a very, very clear picture to us because I mean, like we did the homework as you saw. We said that, okay, compared to F and G, if you look at F and G compared to this is clearly the graph of F moved around. This is clearly the graph of G also moved around. So we then said, okay, fine, let's go and see the specifics. And we said this was moved 9 units down and 1 unit to the right. And then we're seeing the exact same thing for G. It was moved 9 units down and 1 unit to the right. So now we can understand the question better. The question is saying use your graphs of F to determine the number of real roots where this equation is equal to this equation. Give reasons for your answer. So when they're asking for the number of real roots, firstly, before we think of number of real roots, let's just talk about real roots. So them referring to real roots, they are literally talking about points where they meet. See, those are roots. Roots are cases where your graphs meet each other. So if you're looking at the original sketches here, there are no real roots here. Because firstly, if you look at where G is not touching F anyway. F is not touching G anyway. This original picture, there are no real roots. That's for the original picture. The reason why there are no real roots is because there are no points where they meet. You see, that's for the original images. They have no real roots because they have no points where they meet, because real roots just refer to points where they meet. So it makes it easier now when you're even looking at the equation here, because this equation is telling me that these two graphs were both moved the exact same way. So this is asking where will they meet each other. So logically speaking, right, if you see these two graphs here, right, I mean, like the way that they are, if they all both move exactly the exact same way, if they are all moved 9 units down and they are all moved 1 unit to the right, I mean, like hypothetically speaking, they'll still never meet anyways. The reason why they will still never meet is because the asymptotes also move as the graphs move. You see, as you can see here, this asymptote is telling you that your turning point will always go up until the asymptote. This, oh, wait a minute. No. I think this confused me. Nope. The number of real roots, they do have real roots. And this is the reason. This is an asymptote for your exponential, your hyperbola, yes. But then your parabola is not restricted by that asymptote. If you look nicely here, your parabola is going to go down forever. And your hyperbola, it's not going to have an x value of -1, yes. But then at some point in time, it is going to touch the parabola. Yeah, so I guess I was woodwinked there. I won't take this back. I will change it. So the number of real roots, so when I said I'll change it, I just mean, so the number of real roots here, it looks like we have 1 real root. Because if, I mean, looking at the way it is originally, it looks like it's not going to have real roots, but then you saw how I was almost woodwinked there. Because, I mean, like the sketch ends here, but then we know that hypothetically speaking, because arrows, it means that this is going to carry on forever. So this has 1 real root. That's the original image. So if you look at it, if you think of it nicely, if this original image, right, was moved 9 units down and 1 unit to the right, if everything was moved 1 unit down, and I mean, if everything was moved 1 unit to the right and 9 units downwards, these graphs would still only meet at one place, you see. So you have 1 real root because there is 1 point where they meet. You see, that's for the original sketch. But then it's going to stay the same if they're both moved the exact same way. So for a good 4 marks here, we literally just have to say words. So let's say here the graphs, or rather the equation, because that's the question. Use the graphs of blah, blah, blah to determine the number of real roots of this equation. So we're going to say here the equation has 1 real root. That's going to give us a mark. The equation has 1 real root because the graphs of f and G meet only once. Full stop. Now you have to justify why this is coming from the graph of f and g. So we say the equation has one real root. That's going to give us 1 mark because they asked how many roots. We said it has 1. And now we're giving a reason because the graphs of f and g meet only once. But that's not all. So we're saying that it has one real root because the graphs of f and g only have they only meet once. And here we're going to say that the equations on both sides of the equal to sign are the graphs of f and g shifted 9 units down and 1 unit to the right. So they will also only meet once. You see, the rest here is definitely worth the other 2 marks because here we said that the equations on both sides of the equal to sign, meaning this equation here and this equation here, the equations on both sides of the equal to sign are the graphs of f and g. Yes, they are shifted 9 units down and 1 unit to the right. So they'll still only meet once. That's going to be good enough for 4 marks. And you can see how the theory or the background knowledge of functions and graphs is important. You can see it's important for these questions here, the 4-mark question here and the 4-mark question there. That's like a whole 8 marks. So over time, if you keep finding yourself like leaving these questions out, yeah, those things kind of pile. So this is just to show that for you to be able to understand these kinds of wording, this kind of wording, you just need to go through like similar examples until you can see, okay, fine. If they mention real roots, they're just talking about points where they meet. If they're referring to stuff like this, don't just think of this as like new things. It's always going to be referring to what it is that you were just working on. And take note of how when I looked at this image, I said there are no real roots, which was like a big mistake because of how it looked. But then we said that this asymptote only applies for our hyperbola. Our parabola can still cross it. And the moment our parabola crosses it, it's eventually going to touch our hyperbola at some point in time. But it's only going to do it once, you see. So that is that for how there is a question. Here we are, question number 6. It's financial math in this June paper 1, 2018 full memo. So question 6, right? Just like any financial math question, what you may call, it's just a matter of making sure that you understand your questions. So always read your questions nice and slow, and then you don't need to read them once. For example, here it's a 4-mark question, and it says calculate how many years it will take for the value of a truck to depreciate. No, how many years it will take for the value of a truck to decrease to 50% of its original value if depreciation is calculated 15% per annum using the reducing balance method. So to be honest with you, questions like these, right, they are super common. And the more past papers we go through, I mean, the more I start to understand how teachers always used to make like math look too easy, because it's the same things over and over again, really. So the idea with a question like this one is they spoke of the reducing balance here. So the reducing balance is a formula. It's this formula: A is equal to P, and then 1 minus I to the power of N. That's the reducing balance formula. Now with this formula, I mean our information here, how many years will it take? So just this question, how many years? It's telling us that we're working out, N. So N is what we're working out. How many years will it take the value of a truck? So firstly, do we know the value of this truck? No, we don't. So we might as well make it X. How long will it take for the value of a truck to decrease to 50% of its original value? So P is always what you have before time has passed. A is always what you have after time has passed. Whether something is increasing or decreasing, it doesn't matter. P is what you have before time has passed. A is what you have after time has passed. Just like in the course, your P value is like the P4 value. See, P4, okay, meh, it is what it is. So P is what you have before time has passed, and then A is what you have after time has passed. So your A value and your P value, you can get it from this statement. The value of a truck, how long will it take the value of a truck to decrease to 50% of its original value? So the original value is X, and then the value after time has passed is just half of X, which is just X over 2, you see. So that's what you can put as P, that's what you can put as A. And don't worry about how you're putting X's here, you know, and you're gonna throw them into formula. These usually always cancel each other out anyways, eventually. It's almost like a trend that you can count on. The interest rate is 15% per annum. So there's no funny business here. You don't have to do anything to this number. It's just 15 over 100, which is just 0.15. So putting all this information into our formula, we have X over 2, P as X, 1 minus 0.15. N is open, and we have to work out a value of N here. So if you look now, here you can divide by X on both sides. So dividing by X on both sides, what's going to happen is you're technically going to have divide by X here and then divide by X here. It looks weird, but when you have a fraction divided by something, whatever you're dividing, you always multiply it with the denominator. I'll repeat. If you ever have a fraction divided by something, whatever you're dividing, always put it at the denominator, as in paste it together with whatever is at the denominator. See. So here you will have this canceling that, and then you're gonna have this minus 1 is just 0.85. Yeah, that was a nice Campbell. Campbell. Yo, wow, weird pronunciation is not. Hey, what did I just do now? I'm busy pressing things here. Yammer. Oh wait, what am I seeing? What questions are here? Sir, I can't hear you. Yo, really? For how long? Snap. All right, let me. Hooey. So carrying on from here, we know that what you may call the X here can cancel the X there, which is going to give you a half equal to 0.85 to the power of N. Now, anytime we need to like isolate an exponent, we have to use logs. So what you do is you do isolate the exponent because that's what you want to do. And then on the other side here, you write log. Whatever the base of the exponent is, you make that the base of the log. And then whatever this value is, it's just going to be there. See? So in your calculator, the button under the on button is the log one. You're going to put 0.85 there. And then you're going to put a half in that bracket there. So everything in your calculator, it's gonna be 4.27. 4.27. So when you get a question, when you get an answer like this, right, always just double check like what the actual question was, just so that you can just clarify. So the question in itself said, how many years will it take for the value of a truck to decrease to 50% of its original value? Yeah, so in terms of years, yeah, you can just say 4.27 years. It's roughly, I think it's normal, you know, 4.27 years. You don't have to worry about writing it in years and months. It's really not necessary. But for interest's sake, if you did want to write this as years and months, what you do is you take this 0.27 and you multiply it by 12. So if you take 0.27, right, and you multiply it by 12, you're getting the number, let's see, you're getting the number 3 point something. You're getting, let's just say approximately 3. You see, so in other words, this is like 4 years and 3 months. You see, in case you want to be all fancy and stuff like that. So if you write it as 4 years and 3 months, I feel like that's 100% still valid, you know? So this is still valid. This is also still valid. Like, yeah. So let's see. 6.2. I might just backtrack here, see if anything has been said. Nope. So we shall carry on. It says here, every month, Tsepo deposited 1,500 into his retirement. No, deposited 1,500 for his retirement into an account that paid interest at 9% per annum compounded monthly. And then it says that Tsepo made his first installment on his 23rd birthday. Yeah, this question, some of these questions these days, they're seeming so familiar. It's scary. But it says here, he made his first installment on his 23rd birthday. So the one thing I want to make clear is that on his 23rd birthday, so he turns 23 here, right? So on this day, he makes his first installment. And the last installment is made 1 month before his 55th birthday. So what we're seeing here is let's see. What is seen here is the following. From his 23rd birthday, right? If you trace it right until the 55th birthday, let's say here 23rd birthday, and then this is the 55th birthday. If you, before even carrying on, let's see here, it says his first installment is on is on his 23rd birthday, and his last installment is 1 month before his 55th birthday. Calculate how much money he had in the account on his 55th birthday. And it's a 5-mark question. Now, this is not a 5-mark question for nothing. It's also not a 5-mark question because it's difficult. We just have to think logically with these kinds of questions. So what I mean is, if you think of it nicely, right? My mind keeps going back to this question, to be honest. I really don't know why. But yeah, I hope someone else can also like feel the vibe with this 6.2 that we've just done. Because if the thing is, if he made a payment, right? Let's see here. It says here, every month, Tsepo deposited 1,500 for his retirement into an account that paid interest at 9.2% per annum compounded monthly. Tsepo made his installment on his birthday and the last installment 1 month before his birthday. So with these kinds of questions, I don't want to say my senses are tingling, but I have to use those words. If I feel a bit skeptical about the question, what I usually try to do is, you just want to maybe do things manually. So if he makes a payment, right, when he turned 23, we know that up until he turns 24, you're going to technically have, this is like January to January, you see, which is technically 13 months. And then from January to January again, let's see here, this is going to be January on when it turns, let's see, 25, 26, 27, 28, 29, all the way until it turns 55. So this is going to be January to January to January to January, going on and on and on and on and on. So it's like 13 months, right? And then from Feb until January again. I think this explanation is going to make better sense. Let me actually put my Januaries here so that we can all put our minds at ease, because I usually don't want to just leave questions. So let's just put a January over there, a January over there. Let's just put a few of them so that things can be a bit clearer. So if you look at things nicely, right, you can see here from this 1st January until this 2nd January, it's technically 13 payments that I made. Let me just get a different color here. It's technically 13 full payments that are being made, because you make one here in January, right? And then you're going to make one in Feb, March, April, May, June, July, August, September, October, November, December. That's going to be 12. When January comes again, that's going to be 13 payments. So if you think of it, February, March, April, May, June, July, August, September, October, November, December, and then January again, that's actually going to be like 12 months. And then from Feb to January again, that's going to be another 12 months, another 12 months, another 12 months, another 12 months. And then obviously at birthday 55, or rather at birthday 54, going to birthday 55, that's also going to technically have been 12 months. So if you look at it nicely, right, between 55 and 23, we said that you have 32 years, right? However, 32 years times 12, we know that it gave us 384. So if you think of it nicely, it would be like 12 plus 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 12, 32 times, which gives us 384. But then this first month, or this first batch, has 13 payments. So it's technically going to be 12 times the 32, but then we have to add 1, because in the beginning here, we actually have 13 payments. So in total, we have a space of like 385 times where this money gains interest. However, the time period where he was making installments, we know we have to remove 1 because of this last month here, because the last payment that he made was before his birthday, right? So we know that out of 385 times where money could have been made, he only made deposits 384 times. So it looks as though for this entire calculation, this is going to be 384. This still stays a 1, but then these are going to be 2 different answers. But then it's not like a big issue, because if we make this 384, let's see what the calculator is going to give us over here. Let me just put that in the calculator quickly. 1,500. Let me see here. And then we have fraction, but 1,500. And then inside the bracket, we have 1 plus 9.2 over 100 times 12. The whole thing, the power of 384, minus 1. Let me see here, 384, the whole thing minus 1. And then we're going to have the 9.2 at the bottom over 100 times 12. Okay, so that's going to give us 3,400,000. I'll add T just now. 3,478,620.49, of which that's the value that we're going to put in our formula for A here. So in our formula for A, this value is going to be our adjusted number. And then our final answer in the calculator, let's see here, it's going to be ans, open and close bracket, 1 plus interest, which is 9.2, 100 times 12. The whole thing to the power of 1. So it's giving you 3,505,289.91. That's going to be the final answer. Let me just add whoever I need to add, and I can go back. Admit. So for this question, I think normally with cases like these, right? I mean, yeah, if your senses are tingling and things are not like letting you go, if you just cannot leave the question alone, the one thing I can safely say is just always go back to it and check one more time if you know it like makes sense. If it doesn't make sense, then yeah, you definitely want to either go back to it immediately or just go back to it maybe like later on when you like finish the entire paper or something like that. With this next question, it said Abram has what? 150,000 to invest in 2 separate accounts. Okay, one account pays interest at a rate of 8.4% per annum, compounded quarterly. So let's actually keep this information neat. So there's account, let's call it account 1. Yeah, account number 1, it says here the interest is 8.4% per annum compounded quarterly. So down here you can just multiply by 4. This is what I is for account number 1. And then it says, and the other account at a rate of 9.6%. So this is account 2. Account 2. So the same way we're going through this question is the same way you may want to go through it. Just like be reading your information while like writing out what you have been given. So it's 9.6% per annum, compounded monthly. And then it says how much money should he invest in each account so that he will collect the same amount from each account at the end of 12 years. So questions like these, they may seem a bit over the top, but they're actually not. If you just write out the information you're given and you write out what you don't have and you write out what you're looking for. So for each account, you already know that there's a specific interest rate. Now, for each account, you also know that there are no monthly installments being made. So you're not going to think of the F formula at all. You're just going to think of the compound interest formula. You see, for both accounts, we are clearly just working with the compound interest formula because it looks as though we're just going to throw money in the account and then we're just going to leave it there for 12 years. And then after the 12 years, we have to find out how much it is. But then we have to structure the split in such a way that both accounts have the exact same money after 12 years. So what that means is of this 150,000, you're obviously not going to share it half-half. You see, some amount you're going to put here, some amount you're going to put there, and that's what we need to find out. So for the first account and the second account, remember we said that A is always the amount after time has passed. So what we know is that the A value here is exactly the same as the A value over there. So A here is A there, 100%. Now, the other thing now is P is different for the equation on the left, and then P is different for the equation on the right. Let's actually name this P1 and maybe P2 over there. Interest is different for the account on the left, interest is different for the account on the right. But then N is the same for both of them. The value of N here is the same as the value of N over there. So let's maybe put down what we can. But before we even carry on, just remember that P1 plus P2 is equal to 150,000, you see. So what you can do for yourself is, instead of you having two variables that you're going to refer to as P1 and P2, you can actually just, have all this put together. And this is what I mean. You know that at the end of the day, right, account number 1 should be equal to account number 2. So let's write that down. At the end of the day, account 1 should be equal to account 2. Account 1 is this thing here. It's just P1, 1 plus I to the power of N. Account 2 is just P2, 1 plus I to the power of N. If you put information in each of these, right, you're going to put, here you don't have anything for P1. Let's leave it open. For interest, you have there 8.4 over 100 times 4. For N, you have 12. On this side, for P2, you don't have anything. But then for interest, you have 9.6 over 100 times 12. For N, you have 12, you see. So as you're working it out, you can already see that, okay, fine, here you have an equation, but then your equation has two separate variables. You want to work out what P1 is, you want to work out what P2 is. So you might as well work out P1 and P2 simultaneously. Remember, anytime you want to work out two variables simultaneously, just make sure you have two equations that both have those two variables you're trying to solve. And we have those two equations. We have equation 1 up here, and we have equation 2 up here. Equation 1 up here has P1 and P2. Equation 2 here also has P1 and P2. So we might as well just work out P1 and P2 simultaneously. So the best way to do it is, it looks as though we can isolate either P1 or P2 here, and then just throw it into anywhere in our main equation here. Just the same way we work out simultaneous equations for all other kinds of questions. So up here, I mean, like, let's maybe isolate P1 instead. If you isolate P1, you're gonna have 1,500. I mean, you're gonna have 150,000 minus P2, you see. So when you see P1 over here, you're better off writing it like this. Let me make this a bit smaller so that we are not, you know, interrupting anything. Let's do this. Oh, do that. Make this smaller. So it looks as though this is going to be your best bet, right? Where you see P1 here, you want to write it as 150,000 minus P2. And then here you have 1 plus 8.4 over this. And then here you have P2, 1 point this over 100 times 12, 12, 12. So now you can see you just have one equation, and that one equation you just have to solve for P2. So you can just solve for P2 here, and then later on use that to get what P1 is. So solving for P2 here, I mean, like, you just want to keep calm. Like, you've gotten this far anyways, so you might as well, like, not panic, because I mean, at this point in time, you've gotten quite far. But then if you're maybe thinking of, okay, fine, but you know, what's the train of thought behind this? If you saw, from the moment we were reading the question, we were already sorting out the information. You see, don't wait to just read and then now want to think what to do. As you read, sort it out. You see, so we read a bit, we wrote out what we had read. We read some more, and then we wrote out some more. And then from there, they are talking about these two accounts ending up as the same value. So it technically just means that this number here has to be equal to that one. So we equated the two equations, and then from the fact that we are sharing this 150,000, we know that whatever you invest in the beginning, P1 plus P2, whatever you invest in the beginning, it's always going to add up to the 150,000 that you have. That's how we're able to have a specific equation here in terms of P1 and P2. And then here, our second equation is from how these two amounts have to be equal. And then where P1 is, we just replaced it with that, and then now we're solving for P2. So let me add whoever it is here that needs to be added, and let us go back. So solving for P2 here, we just have to work slowly. What I can suggest is, I think this thing here, right? Let us put it, you may be thinking, should we just put it in the calculator and then just work with decimals? We could do that, but it can easily get a bit messy very quickly, like very, very quickly. But then it doesn't matter, you know. So here, let's see, 150,000 minus P2. Don't be scared of what you call of decimals. You see, just write them out fully and just keep track of them. So let's put this number in the calculator here and see what it's going to be. But what I'm actually gravitating towards is maybe dividing by this bracket on both sides. But no, let's just keep it simple for everyone. Let's just write the decimals. I was about to not write the decimals because I personally don't like writing decimals, but hey, let me be considerate because most people like them anyways. So it's 8.4 over 100 times 4 there. The whole thing to the power of 12. It's giving us the number 1.2832 43 0.003. So the other thing with writing out decimals is, for most people, it's a bit nerve-wracking because it's like, decimals, so many. You know, it sometimes makes it look a bit weird, and it sometimes makes your brain start to think that what I'm writing here, it doesn't look right. So you just want to fight those kinds of thoughts, because if you keep thinking like that, yeah, that's when you start to flop, you see. But then the thing is, with financial math, I mean, it's just like that. You should not round off until you are right at the end, because if you round off too early, yeah, you're gonna lose marks unnecessarily, and you don't want to be that guy. You know, don't be that guy that just does not value marks, you know, because I don't know, they just don't see the value. Don't be that guy. So from here, we can clearly see that since we're trying to isolate P2, you may be thinking to yourself, why don't we like distribute this bracket? You don't have to do that. You might also divide both sides by this bracket here. So if you divide both sides by this long bracket here, let's see what it's going to look like. Here, you're going to divide it by 12832433003, right? So it's gonna, this is going to cancel this, and then on this side you're going to do the same. 1.2832433003. So here you're going to be left with 150,000 minus P2 is equal to P2. Let's see what this is as a fraction. This divided by this in your calculator. Let's see what it gives us. So let's see the 1.2832433003. So this number here is going to be 0.857467191. You see. So now you can see that, remember, P is just a variable. You see, I might as well have written the number in front there, but then, yeah, it's difficult. Let me also maybe color code this so that it's not too confusing. This is just like a tiny 2 there, tiny 2 there, tiny 2 there. So everything with P2, let's take it to one side. So here you're gonna have P2 with 0.857467129, 1 plus P2, and then here you have 150,000 on its own. So these are like terms, right? So you technically have this plus 1. I know it looks a bit weird, so let me actually write the P2 behind the number, because that's more normal. You know, the variable is written after the number. Here I kept on writing it, you know, in front like this, but you know, it is what it is. But now we can maybe just write it a bit more normal in a way that we can look at it nicely. So here you're basically seeing that it's this 0 point something plus 1, which is going to give you 1.85746746712912911, and then the P2 is just there. So clearly here, to get P2 on its own, you're going to have to divide by this number on both sides. So I'm going to divide by this 46712 blah 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 blah. So yeah, all those decimals that I was trying to avoid writing out, yep, cannot avoid it. You have to write them out. You just have to be strong, you know. So this is one of those cases where if you want to doubt yourself, hey, yeah, just don't do it. If this was not financial math, then yeah, you could. But the thing with financial math is the decimals, yeah, they're inevitable. So here P2 is going to be equal to, let's see what this is in the calculator. 150,000 divided by the answer. So it looks like P2 is going to have to be 80,755 point something. So I think because this is more like a final answer, you can round it off to 2 decimal places. So now we know what you may call what P2 is, you see. So as long as we have P2, we already know. Yo, what is up? I heard somebody.
How did you get the one?
How did I get the 1?
Yes.
Okay, yeah. So these are like terms.
Okay.
Yeah, so these are like terms, right? It's almost like having 3x plus x. 3x plus x is 4x. You see, that's the idea here, because the p here, this is just a variable. The p here, this is just a variable. So you can see here what's in front here is just a 1, but then what's in front here is this big decimal number here.
Oh,
You see?
okay.
Yeah, so we said this number here plus the 1 gave us 1 point something 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 something. Let me just write P1 here. So here P1 would have been 150,000 minus this 0.13, right? Let's see what this is going to be. 150,000 minus the answer. It's giving us 69,224.87. Anyway, so for 5 marks here, right? They're asking us to differentiate using first principles. So anytime you see this symbol here, they're asking you to differentiate, or rather they're talking about the first derivative. Now, I mean, it's quite important for us to understand what the first derivative is, because this is where everyone misses it. Your first derivative is just always referring to the gradient equation of the original graph. So this is just a gradient equation. So if you haven't started with differentiation, then don't worry too much about what we're going to be saying. We're going to take it slow, yes, but then you do need to like firstly learn the basics of differentiation and all that, of which that can be done like on the main channel or the course platform or whenever it is that you are going to learn it at school. So first derivative just refers to the gradient equation. So here they want us to go from f of x to this, and we need to do it from first principles. They say they're given f of x, right? For 5 marks, determine f prime from first principles. Oh yeah, that's how you refer to this. Kind of just remember that. F prime. Damn, but hey, it is what it is. Optimus prime. Anyway, so for 5 marks here, if you're gonna use first principles to differentiate this equation, fortunately, the first principles formula is on your formula sheet. So it looks like this: lim h goes to 0, and then x plus h, and then f of x. So whatever we're doing here, I mean, like, it's math, you know, so you don't like have to be like sitting there writing notes or something. No, you might as well sit there thinking of what you could ask, or just trying to analyze the question, because writing notes for maths, trust me, yeah, it feels like you're doing something, but nah, you know. So we have this equation here. Now if you're going to get your gradient equation using this formula, you have to focus on these two things. You see, this here refers to the equation of f of x if you throw x plus h where x is. This is just normal f of x. So this thing here is just the original graph. However, this thing here is the equation of f if you throw x plus h where x is. So I'll repeat. For this question, what you normally have to do is, you already know what f of x is. F of x is 2 minus 3x squared. So before you throw stuff into your formula, you also have to know what is fx plus h. So you want to get this value first. And to do that, all you do is in your equation here, wherever x is, you're going to throw x plus h. So this is going to be 2 minus 3, and then x plus h here, and then you square it. So here you just want to simplify this. So simplifying this, we're obviously just going to have 2 brackets here that look alike. And then the 3 can stay outside. Open bracket, x times x is like x squared, x times h is xh, h times x is another xh, h times h is h squared. So let's put h squared over there. Fantastic. And then what can we do now? So is here x squared here. Xh plus xh is just 2xh. And then yeah, all you'd want to just prevent here is making a silly mistake or doing something dumb like me. You see here, I'm just like dude, just zoom in and write, like, hello. So I think that's fine. So here, let's see, 2, negative 3 x squared, and then negative 6xh, and then negative. See here, I was about to make a very common error. So common errors to look out for, I mean, like, it has stuff to do with brackets and signs. If you see that you've done something and there's a small error, just look out for your signs and look out for if you used brackets, because those two things are like the main culprits. So here we now have something to throw in for fx plus h, and we have something to throw in for f of x. So we're good to go. So here, whatever you're gonna do, I mean, you kind of have to write this whole limb thing until the end. So where we see here fx plus h, we know that it's this whole thing. We literally just worked it out. So this whole thing here, where you see this, that's what you're gonna throw over there. And you may wanna, you'll be able to do all this on your answer sheet as well. And then you're gonna put your minus over there. And then you're gonna throw f of x. Don't forget your brackets, because the moment you forget your brackets, yeah, that's when you're gonna cry, you know? And there's really no need to cry in math. But hey, let's not go there, because that's kind of sensitive, eh? Like, it's kind of sensitive. So let's leave that one. So this is gonna be 3x squared minus 6xh minus 3h squared. If you multiply inside here, you're gonna have this. So at this point in time, the one thing I can say is, with first principles, there are certain things that are like always gonna happen. When I say always, I literally mean always. That's why sometimes it feels like math is just a scam, because it's like, hey, just the same things over and over again. So what I mean is, at this point in time, certain things always have to cancel out. So whatever you would have had in your equation of f of x, you usually end up canceling it. Like here, the 2 cancels the negative 2. The negative 3x squared cancels the positive 3x squared. I actually should not say usually. I should say all the time, like 100% of the time. If you see that you are not canceling stuff here at this step, you have done something wrong, guaranteed. So you just need to go back and check your answers. So don't ignore stuff like that. Otherwise, you're just going to be fooling yourself, you see? So here you're going to have negative 6xh minus 3h squared, the whole thing over h. From ISO, we're going to take out the h as a common factor. And literally all that I'm doing here, I feel like it's what? I don't know. I just feel like I'm on autopilot. Because with first principles, that's literally the idea. Whatever you're going to do, it's such a repetition of what you would do if the question was different. Because it's the same things for first principles. That's why likely for first principles, you actually always just have one question, usually out of 5 actually. So this is like always guaranteed 5 marks, because you're always going to do the exact same thing. After taking out an h here, you just cancel it. And then now you are left with what? Lim h goes to 0, and then this is like 6x minus 3h. So from here, you're home free, because now this is where this whole funny lim thing comes into play. Because this whole lim h goes to 0 thing is literally saying that at a point in time in your equation, you are able to throw in 0 where h is, if it's not going to cause your expression to be undefined. You see, from the beginning, we could not throw a 0 in our place of h, because if we did that immediately, the whole thing would be undefined. Here we could not do it, because you see we still have 0 at the denominator. All the way until down here, we can now do it because there's no h at the denominator position. So from here, you can then just say f of x, or f prime rather, is equal to 6x. And then a 0 over there. And then your answer is just 6x. And then is done. I don't even know why I'm like writing this whole thing not straight. Yeah, bo.
Like, this is just a trick I used to do when I used to do calculus. So I would, before I would even solve it using first principles, I would first derive it and then check my answer and then compare what I have if I use the first principle. So what I did before you did it, I first rearranged it and then I derived it and then I used the new equation, and then I still got the same answer as you.
Yeah, definitely. I also know I made a mistake here, because I should get a negative 6x. So as you were talking, like you actually saved the life, because you see here, there's a negative 6x there, of which this should be a negative, this should be a negative, and then this should be a negative, you know? It's like a timing, man. The timing is like, dang it, is on point. Yeah, so definitely in the beginning, right, what you may want to do for yourself is just differentiate the expression using normal differentiation. Because remember, normal differentiation says that you need to differentiate each term individually. So when you have f of x here, we know that if you're going to differentiate f of x, any constant, when you differentiate it, it just falls away. Differentiating this, we know it's the exponent times the base, and then you remove 1. It's the exponent times the base, right, which is negative 6, and then you remove 1 from the exponent. So you'll already be like working your question out, knowing that this is the answer you're supposed to work towards. Because as long as what you call as long as you know what you're supposed to work towards, it's going to be easier for you when you're done to check your answers. That's literally what I just did here now, because as you were talking, I had almost like forgotten that, you know, but fortunately as you were talking, I was like, oh yeah, definitely, that's a good idea, because you always want to work it out first, you know, and then check your answer when you're done with first principles, because them asking you to differentiate using first principles, it's a very specific question. If they didn't ask you to use first principles, you don't use it. But then if they do ask you to use it, you have to use it, and preferably only use it when they ask for it. Not preferably, like just use it only when they ask for it, because it doesn't make sense using first principles if they don't ask for it. So Dango, that's the answer. We have gotten our 5 marks over there.
Levi,
Away.
is H always 0?
100%, like all the time. All
Okay.
other time, because this formula is literally on your formula sheet. You see, so if I search here, sheet, gonna give me the formula sheet. Where's the formula sheet? There's the formula sheet. So if I open up the formula sheet here, you're going to see that one of the equations that you have, or one of the formulas rather that you have on your formula sheet, is what you may call the formula that we just used now. You see, there we go. F prime is lim h goes to 0, blah, 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 blah. You see, it's on your formula sheet, of which your formula sheet is something that you want to have like 100% of the time when you're doing your math. Have your formula sheet next to you, just because of how it's just like a calculator. So let me stop blabbing and just move the on. Let me move the on. So with all that we've said now, what you may call, here it says determine for 3 marks this. So this question is asking us to differentiate.
Levi, sorry. Before you move on, I just would like to say something.
Yeah.
It seems like to whoever that's listening, like I used to do this mistake. I would literally forget about the lim approaching, h approaching to 0. And if you leave that out, they penalize you and they wouldn't give you the full mark, even if your answer is right. So I would just say to whoever is listening, always write your lim h approaching 0.
100%. Like, I feel like crying, because that's literally something they do, you know, like it's the dumbest thing ever, but then they literally do that, you see. So in as much as it's something we just said, like brushing it off in the beginning, like when we said always have the lim and all that, you see. So even also you may ask yourself, but then what's the whole point of having this whole lim here? I mean, like, we didn't invent this whole math thing. So instead of like what you may call like fighting the system, just play the game, you know, just play the game and become good at it, and then you'll have a happy life. So yeah, you definitely don't want to leave the whole lim thing here, because like out of 5 you'll probably like get 4 or even 3, and it's like, what's the point, you know? Anyways,
So
yeah, go on.
can I also add on to silly mistakes?
Definitely, yes, please.
Guys, please don't forget to what's this? Add your lim after your equal sign, not before, because that makes everything wrong. So your lim approaching h approaching 0 is always after the equal sign. Thank you.
Yeah, definitely. So what you may call, I think with all that's being said, right, as you can see, it's on your formula sheet. So those kinds of things, I mean, like, they seem all small and dumb, but then, I mean, like, we all know how teachers can be sometimes, you know. If they're having a bad day, hey, they'll do everything by the book. And then the next thing you know, you're losing 1, 2, 3 marks here over and over again. Because remember, these kinds of things, they pile up. You lose one small mark here, you lose one small mark somewhere else. By the time you're done, you've lost a good 3, 4 marks just from admin, you know. So yeah, don't be that guy. So yeah, if you have any other tips later on going on, if anyone has anything extra they want to say, I think that's going to be super useful if you kind of share that information, because at the end of the day, yeah, it's a team sport, even though it's not. So anyways, here, this expression is asking you to differentiate what we have here. Now, if you haven't started with differentiation, then what I can safely say is just go on like the main channel, go to like the playlists tab and all that, and then go to the I was out. Go to like the playlists and then go to the calculus question, or the calculus playlist rather, and then you'll be able to learn differentiation from like the very beginning, which is what I advise you do. Because with us, whatever we're doing now, like, yeah, it'll make sense, but if you don't have the basics, then it's not gonna stick forever, you see. So let me just put that out there. But anyways, for how many marks? For 3 marks, they said we should differentiate. Now the thing with differentiating is that always simplify first. Always sim sure. I saw this S and then I was already writing. Always simplify first. So simplifying is like way too underrated, because I'm like, we do live in a fast world anyways, you know, fast everything. We just want everything now. So simplifying is something that we are most likely not going to do most of the time if we feel like we don't have to. But if you're going to differentiate, always simplify first, meaning that here, before you can differentiate using normal differentiation, you have to simplify. So you're simplifying, it just means here you just have to work until you have individual terms without anything too compound. So here you have 4x plus 5, right? And it's being multiplied by itself. So here, because we're simplifying, we have to keep this dx with these square brackets here, because the dx and the square brackets is what's telling us that our expression has not yet been differentiated. So it goes back to like what has been mentioned just now about things like lim and blah blah blah. It's all admin, but you kind of have to do all those things, otherwise you're just gonna be rogue, you know, you're just gonna do things from the top of your head, which is how you end up losing small marks. So because you're simplifying, just keep the square brackets and the dx there. So our next step here, we're just going to have 4x times 4x, which is like 16x squared. 4x times the 5, which is like 20x. And then 5 times that is another 20x. And then 5 times 5 is like 25. URC. And then here we're still simplifying. So we have 16x here. 20 plus 20 is a 40. Yo, I forgot the plus there. It's a 40. And then plus the 25 over there. There you go. So now this is simplified, and this is in a format that you can differentiate. Because I mean, like with differentiation, the whole idea is to go from an original function to an equation that gives you the gradient at any point of that function. So the essence of differentiation is whatever f of x is, right, it will always have a coefficient, a base, and an exponent. The first derivative, all you'll have to do is the base, you multiply the exponent, and then you remove 1 from the exponent. You see, this is what differentiation is. You just do this for each and every term in your expression. You're going to take a base, multiply it with the exponent, you get an answer. And then whatever your base is, right, the exponent, you have to remove 1 from there. So this is something you execute one term at a time when you differentiate. And that's what we're going to do here. So here we have just simplified. The moment you're about to differentiate, you can now put an equal to sign. You see, because now you've just said you started here, you went there, you went there, you went there. So the derivative of this is equal to what we're going to write now. So us differentiating, we just have to go one term at a time. So here it's going to be 2 times the 16, which is 32, and then removing 1 from the exponent. So you're going to have a 1 over there. Here you're going to do exactly the same thing. 1 times 40 is a 40, but then here you're going to have x to the power of 1 minus 1. So x to the power of 1 minus 1 is just x to the power of 0. Let me just write it for the sake of anyone that is not familiar with differentiation. So here you just have 40x to the power of 0. Now, with a constant, remember a constant is just a value that has no variable. So any constant, when you differentiate it, it just falls away. It literally just falls away. So this simplified is just, 32x plus 40. So over time, I'm like, you'll just be able to go from here straight to there without having any issues. So the first day of seeing differentiation, I mean, like you can see it's not something crazy. It's just doing this. But then before you can do this, you have to have individual terms, one after the other. Nothing too compact like here where we have this square here. You having this square here is what's stopping you from differentiating. I mean, like we would be able to do it using other methods that are not in the grade 12 syllabus. You see, because differentiating this, I mean, there are other ways to do it, but in grade 12, this is what you're going to use. So that's that for this question. So
Levi,
we can, yeah, boo.
why did you get 0 for 25?
Okay, so the reason why we got 0 for 25 is, let me give you the extended version as to why there's a 0 after differentiating the 25. So remember the 25 technically has, let me put it this way. If you look at your equation here just has exponents. It just has the exponents here decreasing by 1 every time. So technically speaking, if you really want to think of it nicely, what you actually have here is 16x squared, and then 40x to the power of 1, and then 25x to the power of 0. You see, but anything to the power of 0 is a 1, so we don't write it anyways, because an equation just has decreasing powers. You see, starts at 2 and then goes to 1 and then goes to 0. But because this one ends up with x to the power of 0, we don't write it. So that's why we consider it a what you call constant. So if you differentiate everything, right, by the time you get to the 20, you have to remember technically what you're doing is you're saying 0 times 25, which is just a 0. And then 0 minus 1 is just minus 1, of which anything times 0 is just a 0. That's why a constant, whenever you differentiate it, it just becomes a 0. Cool? Does that make sense?
Yeah, thanks. Yeah.
Away, mouse second. Let's see here. I need to see whoever needs to be added, but we're kind of almost done anyways. But hey, let us not deprive another children from. Oh wait, I have questions here. Oh goodness, yeah. See. Let's see. Oh yeah. So whoever, yeah. Oh yeah, you're welcome. You're welcome. I mean, no. Whoever was giving tips, yes. Thank you again. Also, yo. Yeah, it's like I'm late, yo. Oh yeah. So I think this is the last question we're gonna do for 4 marks, and then we shall, be gone. So for 4 marks here, this is going to be emphasizing what we mentioned in the previous question. You see, when you're going to differentiate anything, always simplify. Like I cannot overstate this statement over here. Like in the applications of calculus course, right, on like the course website, you'll notice that the first chapter in the applications of calculus course is literally just on differentiation, and working out how to differentiate properly, because that's like, if you can just get that down, whew, like you're gonna be unstoppable. So here you have to simplify first. Now, us simplifying, it means that we have to deal with these fractions, and we have to deal with, these surds and everything. So don't put yourself in a situation where things like surds are like still foreign to you and you still like hate them or whatever. No, just take the time to like learn how to use them. And one way to do it is obviously through the applications of calculus course, which is like chapter 1 day. But then we're obviously just going to showcase a bit of what we're saying now with this example. So in terms of us simplifying, right, before you can differentiate, this also means that you have to differentiate, you see. So from what we have just done here, we've seen like 3 ways that they can ask us to differentiate. they can just show you f prime like this. That's going to be a way of them asking you to differentiate, or they can put their dx with square brackets. That's another way of them asking you to differentiate, or they can put their dy over dx. All these questions are literally all just asking you to do the same thing. They're all asking you to differentiate, of which we know in these square brackets they'll put like a function inside it. They'll just be trying to say differentiate, but let me just rub that out, because looking at things like that, it's never the nicest thing. So let's just leave it. So here, if you're going to differentiate, you have to simplify first. Now, one way of simplifying, or the essence of simplifying is that you have to end up with a coefficient, a base, and an exponent. Each term has to have these things. It has to have a base. It has to have before the base, it has to have a coefficient. I'm making a mistake here. It has to have a coefficient first, which is the a there, coefficient, and then it has to have a base. After having a base, the base has to be to the power of an exponent, you see. So whenever we say simplify, we're just talking about this: coefficient, base, exponent. So the way this looks, clearly, it's not in that state where everything has a coefficient, a base, and an exponent. It's all just mumble jumble, you see. So let's do that. So to start off here, because we have not yet differentiated, we have to be writing our equation starting with y. You see, y is equal to whatever we are doing here. Just like here, before we differentiated, we had to keep the dx with the square bracket. So here, because we are just simplifying, we have to keep the y. Y is equal to whatever this is. So simplifying this into a format that has a coefficient, a base, and an exponent, all you do is, if you have a square root symbol here, right, always pay attention to two values. Always pay attention to the small number over here and the exponent of whatever is inside. So the exponent here is a 1, the value out here is a 4. So whenever you break this down, all you do is the 4 outside there goes under the exponent over there. And then this is what you have. So if the exponent here was like a 3, then here you'd have 3 over 4, That's all you need to remember. Moving onwards here, normally if you have a fraction, you want to, for example, here you can just have everything to the same denominator individually. So this, you can put it over x squared, and then the 8, you can also put it over x squared, you see. Because if your denominators are the same, you can write this on top. So we're just reversing that process. And we're simplifying. And when you simplify, don't feel pressured to rush. So here, x squared can cancel x squared. So we have this to the power of a quarter. This is just a 1. Now, when you get to something like this, let me actually just write it out first before we simplify it, because I don't want to do too many steps at the same time. So with what we have, these two here are okay. These two here, they are fine, nothing crazy, nothing major. This now, we have to again put it in this format. We have to have a coefficient, a base, and an exponent. So to do that, it is all a matter of dealing with the x to the power of 2 here. Because this is a fraction and this is under the denominator, all you do, if this is in the denominator position, all you do is you take it up, and then the exponent becomes a negative. You swap whatever the sign of the exponent is. So this becomes a negative 2 over there. So always remember to swap your sign. If it's a plus here, when it goes up, it becomes a minus. If it was a minus here like this, then when it goes up, you need to make it a plus. You see, it's all a matter of changing your signs from plus to negative or from negative to plus. So all this being done, this is all still just y. You see, y is equal to this, blah, 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 blah. Now, everything here, if you look at it nicely, it has a coefficient, it has a base, and it has an exponent. Everything. You see here, coefficient is a 1, base is x, exponent is a quarter. Here, coefficient is a 1. Technically, the base is x, the exponent is a 0. So we don't write it, because x to the power of 0 is just a 1 anyway. Here, coefficient is -8, base is x, exponent is -2. So now we can differentiate. So meaning here where y is, now you can write it as dy over dx, because you're now about to write out the differentiated equation. So differentiating this, it's exponent multiplied by the coefficient. So a quarter times 1 is just a quarter. And then here in your calculator, a quarter minus 1 is going to give you a negative 3 over 4. And then you're okay. You move on to the next term. The next term is just a 1. Remember, whenever you differentiate a constant, we said it just falls away. Let's just put a 0 there, you know? Moving on here, negative 2 times negative 8 is a positive 16. And then removing 1 from your exponent is just going to give you negative 3, you see? So this will be your final answer. I just put this there so that we just show what has happened to the 1, you see? So your final answer, you can leave it like this, or you can maybe just write down one extra step where you don't have that 0 over there. It's purely up to you. I mean, like, it's your ink at the end of the day. You can or use it for whatever it is that you want to or use it for, because it is free. It feels like it, actually. I mean, you bought the pen and all that, but it doesn't matter. So that's for 4 marks, and that's for the differentiation side of things. I think from what you've seen here, it's all about simplifying first. Even when dealing with first principles, you want to simplify this first, and then you can do whatever you need to do. Here, you want to simplify whatever you're given, and then you can always just differentiate. And then here, lastly, we just needed to simplify whatever we're given, and then we were able to differentiate afterwards. So that is that. Yeah, bro, what's up?
After that, don't you like write the value for dx under as a denominator, or we just leave it like that?
Oh yeah, sorry, I'd seen that I put a 3 there. Yeah, this is supposed to be 4. Okay, yeah, so if you leave it like this, it's 100% fine. But then to answer your question, right, whenever you're differentiating, right, there are cases, I mean, I'm glad you also brought it up, you know, because it's good. Questions make the world go round. So with anything that ends up with having a negative exponent, right, if let's say your question does not require you to leave your answer with positive exponents, if you leave it like this here for this specific question, it's 100% fine. You'll get all your marks. But say they added here and they said leave answer with positive exponents. If they say you should leave your answer with positive exponents, all you need to do is, when you're like completely done with your question, what you then need to do is, any of your terms that have negative exponents, all you do is you have to take them under the division line. So here, if you have a fraction, right, you have 1 over 4. So what you'll have to do is, where the 4 is down here, you have to take this whole thing, but then its exponent becomes a plus. You do the same here. You see, this is 16. Technically, 16 is over 1, you see. So this whole thing here, you have to take it under the 16 over there, and then the exponent becomes a positive value, you see. So that's to answer your question there. If they say leave your answer with positive exponents, then you do have to take the bases here with their exponents under the division line, and then the exponent has to be a plus. That's if they say they should leave it with positive exponents. If they don't say, you can always just leave it like this. But if they do say, then you kind of need to do it.
Okay, that I get, but I think you misunderstood my question. Basically, what I meant was, like, you see where it says dy over dx? So I wanted to ask if you're supposed to like write the value for dx.
Okay, wait. I think I'm okay. You'll let me know if I'm getting your question. So okay, so there are cases where when you're differentiating, right, you just differentiate and you leave it. However, there are cases where you kind of need to do something extra. But then you're saying where dx is, do we have to put a -1?
No, the value. We have the value from like the previous question for dx, right?
Oh, hectic. Okay, I think I get it now. So 7.2.1 and 7.2.2, these have nothing to do with each other, like absolutely nothing. The dx here, right, is not even the dx down here, you see. So I think that's the easiest way I can answer your question. 7.2.1 up here and 7.2.2, they are completely two different questions. So with 7.2.2, you literally are just going to get your first derivative and then you're done. The dx here is not necessarily, it doesn't have anything to do with the dx there. This dy over dx, it's just referring to gradient. You remember, gradient is literally the difference in y values over the difference in x values. That's what dy over dx is. The d there just means difference. This is saying the difference of the y values over the difference of the x values, which is supplementing what we said in the beginning. In the beginning, we said that anytime you deal with differentiation, it's just a gradient equation. And here we just said that in terms of them asking for gradient, they can use this symbol, they can use this, or they can use this, you see. So here they are just asking for the gradient equation. And we have given them the gradient equation because that's what dy over dx is. dy over dx is literally just this. Difference in y over difference in x.
So they're in no way related all the time.
They are no way related all the time. These two will not be related in any way.
Okay.
Yeah, it's just two different symbols asking the same thing. This is asking for gradient. This is also asking for gradient. And this up here is also asking for gradient. Three symbols, all asking for gradient. All of them. Gradient equation. They're asking for the gradient equation. You know, that's to be specific. They're asking for the gradient equation. When you differentiate an equation, you get a gradient equation. Meaning that what you start off with will, like, you know, it will be the function. But then what you end up with will be an equation that gives you the gradient at different points. So that's also, you know, a bit of theory over there.
Okay, thanks.
Cool stuff, cool stuff. With all this being said, we have here question 8 to deal with. It's a cubic function question, right? It says here, the graph of f of x is equal to this thing here. And then it says it is sketched below. Okay, fine, we can see it. F of x is sketched below, like it is there for all of us to see. And then it says here a, b, so where is a? A is here, b is there, and we have d there. So all these three are x-intercepts. Let me just add our fellow Ntebo. So we have been given these three x-intercepts, right? It's a, b, and d. D, they've given us the coordinate, and then for a and b, they haven't given us anything. Now they say that these are x-intercepts of f, and then they said c is the y-intercept. So don't take this information for granted, because I mean, like, for c, we practically have the x value already. You know, we just need the y value. So that's one thing. And then for these, we practically have the y values already. We just need the x values. So here we can name this x2, and then this one we can name this x1. So this is just to remind us of what we actually have, you see, in terms of coordinates. So with all this being said, for 1 mark, they're asking for the coordinate of C. They say they write down the coordinates of C for only 1 mark. So, I mean, that's quite straightforward because the x values are 0, and we have the equation of f of x. So the one thing that is, like, usually a bit too underrated with functions and graphs is the equation. You see, because most people don't realize what they have. We already know that 12 is the y-intercept, but then I mean, like, let's just go through the motions of putting a 0 there, because why not? You know, why not? But it's a 1 mark question, so you don't necessarily have to do this. But I think the reason for me doing this is to try and maybe just give you the idea that, yeah, don't be scared to use your equation, especially if the full thing is given. Any question where they've given you like the full equation of your graph, yeah, you need to make use of it very often. So here, this is a proper coordinate. You see, this is telling us C, the x values are 0, and the y values are 12. So nothing crazy there. We might as well just keep moving on until we get to, like, you know, slightly more challenging questions. I'll try to keep coming back here just in case someone has, like, texted a question. But if I forget, please just switch on your mic and stop me. So the one thing I can also say is, in terms of us going through this paper, right, like, you really don't have to, like, be making notes or something like that, blah blah blah, because it's like math, you know. Like with math, notes, it's not the way to go. The least you can do is to just, like, take note of what we're doing, You could even be going through these questions on your own as well. But it says if for 5 marks, they want the coordinates of A and B. So A and B specifically, these are our x-intercepts. So I think this is the first chunky question we're going to have to look at. So if you look at specifically where A and B is, right? A and B are our x-intercepts. Apart from A and B being our x-intercepts, the idea with A and B is that it's just 2 x-intercepts out of a total of 3 of them, because we're given 3 in total, right? We know that A, D, and B are all of our x-intercepts, but then in our question here, they're only asking for A and B because they already gave us the D. So here, we need to get the x value there, we need to get the x value there, because we already automatically know what the y values are. It's kind of straightforward, like that we know, you see. So for 5 marks, right, if you're going to get the coordinates of A and B, you have to be creative, but not too creative. You actually just need to know something very specific about cubic functions. So when you work with cubic functions, right, the equation that you have here, it is not going to help you very much to get your x-intercepts if you maybe just try to work it out by equating it to 0. This is what I mean. So for example, with the equation we have, right, we know that this is f of x. F of x is this equation, negative x cubed, blah, 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 blah. Now, if you make this equal to 0, right, I mean, like, you're technically stuck here a bit. We don't necessarily have a lot to do in terms of like our grade 12 knowledge to like try and break this up. So this is what you need to do. So me working this out on the fly, I mean, like, the realization is that, you know what, let's just do synthetic division. So let me write here synthetic division. So this is the idea behind synthetic division. Synthetic division allows you to factorize a cubic function if you at least have one x-intercept. I'll repeat that just now as soon as I've added our fellow comrade here. So let me say that again. Synthetic division is used to factorize a cubic expression if we at least have one x-intercept. So this one x-intercept here, right, you always want to look at it in this format. So x is equal to -1, right? You want to look at this as x plus 1. You're going to use this x plus 1 to help you factorize this expression using synthetic division. And this is how you do it. So with synthetic division, right, the first thing that you need to do is you need to write out something like the following. Let me just show it to you just now. You need to write out something like this. You're going to put down what you may call, what's that thing? You're going to put down something that looks like this. You see? So this that you have put here, the -1 that you know is your first x-intercept that you actually have, you're going to throw -1 in there. That's the first thing that you're going to do. Secondly, these numbers here, -1, 0, 13, and 12, you're going to lay them out here. -1, 0, 13, 12. So if n1 is lost, just to recap, what we're doing is we're using this one x-intercept to factorize our cubic expression. But then if you're going to use this one x-intercept to factorize your cubic expression, you need to make sure that this is in standard form, meaning that everything needs to be showing. You see, when I say everything needs to be showing, I literally mean that in our case, you saw that we were not given a value for b. There was nothing here. So you have to replace it with like a 0x squared, because here you have to always have 4 values. And then here you have your x-intercept. Now, this is how your synthetic division works. So as mentioned already, right, like some of you know synthetic division, some of you don't, but it's okay. So with all this being done, right, the next thing you're going to do is you're going to draw a line over here. And then this is what you do with synthetic division. Let me just get a color here so that everything pops. But then so far, before I carry on, right, if there's anyone that's lost, please take the opportunity now to just switch on your mic and then just ask. if anything is not clear, so that when we do carry on, we don't assume that everyone is here, but then someone is lost. So if anyone is confused right now, please just switch on your mic and then just ask where we need to go back to, or we can just carry on. If no one is confused, we can just carry on. Then let me just go to the chat here and just clarify, because we don't want to leave anyone behind, you know. So I don't think anyone is confused at the moment, which is perfect. So with synthetic division, right, these are the steps that we need to follow. The first thing that you do is, funny enough, the very first number here, right, you're just going to drop it. Like whatever this value is, you're just going to drop it. So here you're going to have the -1. And then this is what you do. The -1 here, right, you are basically going to, it's almost like your, what can I call it? It's more like the thing you're going to be using for you to like write out everything else that goes on up here, funny enough. So what you're going to do is you're going to say the -1 multiplied by this -1 here is going to give you a +1. You're going to put the +1 there. And then once you put the +1 over here, you're obviously just going to add up these two numbers. So the 0 plus the 1 there, you're going to add them up, and then that's just going to give you a 1. You see? So that's what we're going to be doing, like over and over again. So here, the next thing is you're just going to take this +1, right? This +1 here, you're going to multiply it by the -1. You're also getting a 1 coincidentally. And then here, the 13 plus the 1, you're getting here 14, you see. And then you're literally just going to carry on like that, you see. So here the 14, we're going to multiply it by the -1, which is going to give us, well, I think something is wrong here, because everything here should actually end up like, this should actually end up with a 0. So let me just double check if we have made a mistake here. So give me 2 seconds. So we dropped the -1 here. We said -1 times -1 gave us a 1. 0 plus 1 is 1. 1 times, oh yeah, there's the error. So here, -1 times -1 is a -1, meaning 13 minus 1 is a 12. Okay, so the moment I realized the error was when we were about to get an answer here, because whatever we get here, right, this answer should always be a 0. So anyways, to start off, right, we say you drop the -1, you have a -1 there, and then you start. -1 times -1 gave us a +1, and then 0 plus 1 gave us a 1, and then now you use this one. 1 times -1 gave us a -1, and then 13 plus this -1 gives you a 12, and then you just carry on. 12 times -1 gives you a -12, and then the 12 plus the -12 here gives you a 0. You see, so this is also one way you can check if what you're doing is correct. If what you're doing is correct, you should always end up with a 0 here. So as long as you have your 0 there at the last spot, right, like you're practically done, you know. And the reason why I say you're practically done is because these answers here, right, these numbers here, these will always be coefficients of a quadratic equation. I'll repeat, these three here will always be coefficients of your quadratic equation after factorizing this. So whenever you factorize a cubic function, right, you're going to have one small bracket, and then the other bracket is going to be like a quadratic equation. So here you'll have like a small bracket, right, which is going to be representing the x-intercept that you already have. So here our x-intercept is a -1, right? So when this is factorized, you're going to have one bracket here that looks like x plus 1. This second bracket here will always be a quadratic equation. You see, now we're saying that these answers here, these numbers 1, 2, and 3, these will always be the coefficients of your quadratic equation. You see, so what that means is when f of x is factorized, you technically have f of x is equal to the small bracket here, which is x plus 1. And then your big bracket, you're going to have here negative 1x squared, negative 1x squared, and then plus 1x, and then plus 12. You see, this always has to be a quadratic equation based on what these three values will be. Whatever this value is, you can see it's the negative 1 over there. And then for the 1 there, you can see it's the 1 there. That's the coefficient of x. And then lastly, the 12 there is the 12 that goes there. You see. So the moment you have done this, I mean, like this here, you can easily also then factorize it. Here, I think with the last bracket, I think with this quadratic equation, factorizing this quadratic equation, I mean, like you really don't have to worry too much about it. Let's actually just do this. From here, you will be easily able to get an a and a b value, because so far we already know that it's now easier for us to make f of x equal to a 0. Because if you make f of x equal to a 0, you can just work out each of these brackets individually for you to get your other x-intercepts that you don't have. So for example, here you can then say 0 is equal to x plus 1, which is just going to give us the negative 1 that we already have. But then here you can also say, oh, 0 is equal to the negative x squared plus x plus 12. And then if you want to factorize this, I mean, like you can do whatever you want. You can use normal factorization, or you can just use the quadratic formula. But then if you're going to use normal factorization, maybe here you could take out like a negative as a common factor first, if you want. If you take out a negative first, you're going to have x squared here minus x minus 12. Divide by a negative on both sides, you're going to have here x squared minus x minus 12. So factorizing this, you would need like two factors of 12 that give you a 1. Or rather, factors of 12 that give you a 1, it's clearly just 4 and 3. But then to get a minus 1, you would need to say minus 4 plus 3. You see, these will be your two brackets. And then obviously these two equal to 0, you would have the x equal to 4, or x is equal to negative 3. So these will be your two x-intercepts for A and for B. So in terms of you giving your answers as coordinates, I mean, like obviously here you have to say that A is the one with the negative 3. Negative 3 coordinate 0. And then B is the one with the positive 4. 4 coordinate 0. You see. And then you'll get your 5 marks. For 4 marks here, they're asking, determine the point of inflection of G if it is given that G of x is negative f of x. Well, I mean, we might as well start with what f of x looks like. F of x looks like this. Negative x cubed, and then what? Plus 13 plus 12 plus 13x plus the 12. Now, what we want to remember is that g of x is negative f of x. So automatically we know that g of x is negative f of x. So let's just see what its equation looks like first before we even worry about other things. If you're multiplying inside, you're going to have here this equation. Perfect. They said our graph of g of x, we should determine the point of inflection. So the fortunate thing is, if this work is new to you, then it's okay. I mean, like eventually, whenever you start with it, all this will make better sense. But the point of inflection is literally always the point right in the center of your graph. So for example, this is f of x. Let's use f of x to, to make sense of what we're about to say here. So if you're looking at what f of x is, right, let's use f of x as an example. The point of inflection of f of x is somewhere, if we're to guess, this one is a bit scary, but it looks like it's almost where C is. Almost. But the thing is, your point of inflection, let me just actually put it this way. Whatever this x value of this turning point is, right, your point of inflection is always in the middle of your two x values of your turning point. So this could be your x value of your turning point, and then this here will be the other x value of your turning point. Now, your point of inflection is always right in the center between these two, or rather, whatever this coordinate is and whatever this coordinate is, right? The midpoint of these two coordinates is your point of inflection. See? Midpoint. Literally, you can even use the midpoint formula to get a point of inflection. if you have the two coordinates here though, and if you have also that coordinate. That's the point of inflection. But then if you don't have those coordinates, one other way to get the point of inflection is you can just take the equation of your function and then use the second derivative. But we're not using f of x. We need to get the point of inflection of g. So getting the point of inflection of g, all you have to do is you have to differentiate g twice. So to differentiate it twice, you have to obviously do it once first, which will be 3 times the value in front, and then removing 1 from the exponent, 1 times the number in front, and then removing 1 from the exponent. So x will be to the power of 0 here, of which anything to the power of 0 is a 1. So we don't have to write anything here. Differentiating a constant, it just falls away. So if anyone has not yet learned differential calculus, it's okay. It's okay. Don't worry about it. You can also always check out the playlists on the main channel if you need to learn differential calculus. So this is having to have differentiated your equation once. So we need to differentiate it again. Differentiating it again, we just repeat the process. The exponent times the coefficient, and then we remove 1 from the exponent. Differentiating a constant, it just falls away. So once you differentiate twice, for you to get your point of inflection, remember your point of inflection is a coordinate, you see. So meaning you have to get the x value first, and then you have to get the y value afterwards. What we're doing here just gives us the x value of the point of inflection. Good Lord, we are adding peoples. It's fine, it's fine. We are just going to carry on. So your point of inflection here, what the method we have just used is just going to help us get the x value only. So coincidentally here, as we said already, it looks as though C is going to be the point of inflection because we're seeing that the x value is a 0. See? So if the x value of the point of inflection is a 0, I mean like throwing 0 into our equation, it's going to give us a 12 here, just like what we got right in the beginning. Right in the beginning here, they asked us for the coordinates of C. So if you throw in an x value of 0, we already know we're just going to get a 12. So we already know that the point of inflection here is just 0, coordinate 12. Coincidentally, it's C, you see. It's not to say the x-intercept is always the point of inflection. Nope. It is purely a coincidence. Purely a coincidence. Anyways, so that's that for how many marks? For 4 marks. For 4 more marks, they said here we should calculate the values of x for which the tangent to f is parallel to the line this. Okay, so to be honest, that's not a very crazy question. So for these questions to not be crazy, or for them not to sound crazy when you read them, right, you need to have gone through quite a few variations of how these questions can be asked. So for example, here, right, we have f of x. They said we should get the x values for which the tangent to f is parallel to this line. So you want to remember, you want to think to yourself, why do they give you certain pieces of information? They don't just give it to you just for the vibes. Like for example here, you can see in this equation that they've given you, they left out C to show that the C value is not important. What's important is this gradient here. Because if they're saying that your tangent to f is parallel to this line, what they're trying to tell you is that this tangent has a gradient of negative 14. Because remember, a tangent is just a straight line. Straight line. This straight line is parallel to this other straight line. Straight lines that are parallel have gradients that are parallel. So the gradient of the tangent is equal to negative 14. That's literally what all this is good for. Them telling you, oh, this is just trying to tell you that the equation, is just trying to tell you that the gradient of the tangent is just a negative 14. That's it. Absolutely nothing else. So with that being known, right, you might also want to reread your question. Calculate the values of x for which the tangent to f is parallel to this line. Okay, so if you're going to calculate the values of x for which this tangent to f is parallel to this, so the values of x here, these are referring to the point of intersection with the graph, point of intersection. Section. Calculate the values of x for which the tangent to f is parallel to this line. So remember, a tangent will always be a line that will touch the graph at a specific point. Now what we know is that this tangent has a gradient of -14. So a gradient of -14, I mean, like, it's a line that's going downwards. So let me actually just draw a random line going downwards like that, you see. So your tangent could potentially be somewhere over there, and your tangent could also potentially be somewhere over there. You see, these are just two random lines that have a gradient of a line that's going downwards. So this is just to help you maybe visualize what they could be talking about here. So our tangent here, our tangent could potentially have whatever this x value is, and then this tangent could potentially be meeting at whatever x value this is. You see, they want us to get this x value here of the point of contact between our tangent and our curve, and then they also want us to get this other x point where our tangent meets our our graph. Because I mean, like, wherever you have a tangent, you have a point of intersection. So the x values they're referring to here are the points of intersection. Now, finding out these points of intersection, it goes back to why they gave you this. They want to give you the gradient at the point of intersection, because remember, they gave you the gradient of the tangent, fine. However, more of what you need to know is that the point here, we need to remember that the gradient of the tangent is the gradient okay, that was disturbing. So the gradient of the tangent is the gradient of the curve at the point of intersection of intersection. So what I mean is, the point where your tangent meets your curve, they will have the same gradients over there, and they'll also have the same coordinate, obviously. So what you need to do is you need to use the gradient at the point of intersection to help you to work out the point of intersection. So here all we need from this point is just the x value, you see. So what you do is, because you have gradient at this point, you need to use a gradient equation for you to find out the x value over here, and you'll also be able to find out the x value over there. So this is where differential calculus comes in, because remember, you'll always hear us say that with differential calculus, right, it's all about working with the gradient equation of a graph. Because firstly, here, f of x gives you coordinates, but then the first derivative of f of x gives you gradient. You see, remember, this is going to give you this is a y value, and then this with this punctuation mark here is gradient. You see, so your first derivative is always a gradient equation. So that's where we can start off. We have f of x, right? F of x is just -x cubed plus 13x plus 12. Now, if you get your first derivative is the gradient equation. So that's like -3x squared plus 13. This is your gradient equation. Because you now have a gradient equation, you can now use it to find out the x value where the gradient is a -14. You see, because that's how equations work. If you give it one thing, it gives you another thing. If you give this equation an x value, it's going to tell you what the gradient is at that x value. But then if you give this equation a gradient, it's going to tell you the x value where that gradient is occurring, you see. So solving for x here, we're just getting the x value where the gradient is a -14. Meaning we're going to be getting this x value here that we need and this x value that we need, because those are the points where the gradient is a -14. So solving for x here, we can take the 3x squared over, and then take the 14 over, and then we're going to have here 27 divided both sides by the 3 over there, by the 9, which is scary, but it is what it is. So x as 9, I mean, like, that's not very that's not final. I mean, we have to still like square root both sides. So here, this is where your whole plus and minus thing really has to kick in, because if you don't do the whole plus and minus thing, yeah, you shall cry. So here, x is going to be equal to plus or minus 3, which kind of makes sense, you know, because it kind of looks as though from our original image here, our tangent is going to be somewhere there, and then our tangent is obviously going to be somewhere over there, where x is going to be like a 3 or a negative 3. But it's okay, it's okay. So from here, we know that our x values are just a positive 3 or a negative 3. So you can either write it like this, or you could have just written here x is equal to 3 or x is equal to negative 3. You see, it's as good as that. This is as good as just this. Any of those two ways of writing your answer would have given you your 4 marks. So the funny thing is, literally the last paper I went through, I think it was the 2019 June paper. Yeah, or the 2017, something like that. Or the 2019 paper 1. This was I think this almost a similar question was in there. But anyways, let's see. It says a right cylinder cone with radius P. So I mean the cone here has a radius of P, and it has a height of T. The whole height here is T. Is machined from a solid space, cut out from a solid sphere. Okay, that's interesting. With center C with a radius of 30 as shown in the sketch. So what they mean is you have a sphere here. It's like a ball, right? So inside this ball, they basically are cutting out a cone, of which this cone has its own radius, which is like P here, and this height of T. And then this ball has a radius of 30, because I mean like a sphere is just like a 3D circle. So that's the radius here, which is also the same radius over there. That's why you have 30 and 30 over there. Let me just try and mute somebody. Oh, there's a question. Oopsie. Let me see what the question is. Yes, we can take it slow. I haven't done calculus at school. Ooh, yeah. Okay, it's fine. If you haven't done calculus at school, then yeah, welcome to the club. So anyways, moving on from here, right? They told us that we have a sphere, right? This sphere has its own radius, and then the cone has its own radius, obviously, which is the P. Now they said here, we have been given 2 pieces of information: volume of a sphere, volume of a cone. Now for 1 mark here, they're saying, from the given information, express AC in terms of T. So whatever you're going to be asked to do, right, always try to look at one portion of the sketch at a time. Because if you're looking at the sphere as a whole, let me just draw out what the sphere looks like here. Just draw this ball ISO. So with this sphere, you have to remember that they have given us a specific radius. The radius of our sphere is 30. But then inside this sphere, they have given us a cone, you know. So our cone has its own radius, right? The cone here has a radius of P, you see, and it has a distance here of T. Fine. So with this being said, what we also need to consider is that for 1 mark, they're just asking us to get a value for AC in terms of T. So AC is this short distance over there, you see. So getting a value for AC, I don't think we should overthink it, because remember, the whole thing is T. This tiny part is 30, this tiny part is AC. So you see, T is equal to AC plus the 30 over there. You see, that's what we can write out. AC, if you add the 30, that's your entire distance of T, you see. But then here they want us to make AC the subject of the formula. So writing AC as the subject of the formula, the 30 just has to go to the other side. And then we have AC here in terms of T. So all we said was, according to our picture, the whole thing is T. So T is just AC plus the 30 over there. So AC plus the 30 gives us a T, but then they want us to have AC on its own, of which we did. So they'll give us a single mark for that. Now the reason for them to ask you to get AC on its own. It's not a coincidence. The reason why they want you to have AC on its own is because you need to usually at least work with your sketch where you have like not a lot of variables just flying around. So at least for AC, you can look at it as t minus 30. For 3 marks here, they said, you see, it's still the same question. For the given information, express the following. It says here, express p squared in its simplest form in terms of t. They want us to express p squared in its simplest form in terms of t. So what they mean is in your sketch, wherever you see p, right, try and write this distance in terms of t. Now the idea is, depending on what your sketch looks like, right, you're going to only need to focus on that portion of the sketch at a time. Like for our previous question, we just literally had to focus on this. For our next question, we have to focus on where p is. But then looking at where p is, you want to be strategic. You know, the distance p here is in this right angled triangle. So you want to now focus on that right angled triangle, because it looks like that right angled triangle is what's going to get you what you need, you see. So the distance here is p, and then this is AC, you see. And it's not a coincidence that they asked for this here, because now what you can do is in this right angled triangle down here, where AC is, you have a dimension over there. And then for the hypotenuse, you also have a dimension, because that's what your sketch is telling you. So BC here is just a 30. AC here is t minus 30. And then you need a value for p squared. And you needing a value for p squared, I mean, like, you can imagine it's a right angled triangle. So don't forget things that come with the right angled triangle, things like Pythagoras theorem, you know. So here we can just perform Pythagoras theorem and then make p the subject of the formula. So Pythagoras theorem, you have to remember, always make the hypotenuse on its own. So here b squared is equal to ab squared plus ac squared. Now bc squared is just 30 squared, ab squared is just p squared, ac squared is just t minus 30 squared. So you can see why this is just easy 3 marks being given. Because now if you're going to isolate p squared, here you're going to have 300 squared, right? What is 300 squared? Let us check in the calculator. 300 squared is just $900,000. It's 900. So 900 over there. Now this entire bracket, you're going to take it over to the left. So the whole bracket moves to the left, and then p squared is on its own. And they're going to give you 3 marks for that, you see. You don't have to simplify it or whatever. You can just, oh, but they said in its simplest form. Oh, Esan. Oopsie. We do have to simplify it. So simplifying, don't make the mistake of multiplying inside with the square there. You have to deal with the square first. So this is like 900 minus, you're going to have 2 brackets that look like this. T minus 30, T minus 30. And then you have here T times T, which is like T squared. T times that is like negative 30T. This, another negative 30T. And then that, you have a positive, positive what? 900. Oh, okay. So now in your brackets here, you're going to have 900 with t squared minus 60t plus 900. Carrying on, you're going to have 900. You're going to multiply the negative inside now. So you're going to have your 60t minus 900 equals p squared. So the 900 minus the 900, they go away. And then you have negative t squared plus 60t equal to p squared. So I think the 3 marks are coming from the simplifying part, because I mean, like, if you look at it nicely, I mean, like, you know, this question is not too crazy. So the simplifying part is what I think is giving us our marks here. The rest doesn't look so bad. So if there are any questions on this question that we've just done, I don't see there are any, so we can carry on with what it is that we're doing. So don't take these questions for granted. All the questions that you normally are asked before, like the big ones, those questions are the ones that usually help you to work out the big questions. So always try and focus on understanding what the small questions want you to do, because that's actually the name of the game. The more you can understand these small questions here, the better you're going to perform in the follow-up questions, and you'll see why. Because now we have an expression for p squared. That seems like we're going to need it somewhere, somehow. And then here you have an expression for AC. I promise you are probably going to need that as well. Or we probably have used it already. But let's see what the next question looks like. For one single mark, they are saying here, show that the volume of the cone can be written as this. Now you have to remember, the reason why they are making this a 1 mark question is because they know by now you have everything, you know. So this is why you need to focus on understanding the small question, because by the time you get to this 1 mark question, you have everything for you to end up with this. You have firstly the volume of the cone. They gave you the formula. The volume of the cone is literally just this formula. They gave it to you. So you can imagine why they are making that question a 1 mark question, because they know by now you have everything. They are literally just like what are they saying? They're just like, you know, almost like grooming you for the last question, you see. So this is what you write out first. V is equal to pi r squared times height. Now they're talking about our cone, and we have already stated what our cone looks like. This is our cone. Whoa. This is our cone here, right? Now in this cone, we need our radius and we need our height, you know. Now us needing our radius and us needing our height, the fortunate thing is, look at where you're trying to end up with. What you're trying to end up with literally just has one variable, which is a t. You know, so before worrying about that, just worry about putting this information in there. So your volume is just a third times pi. Your radius is just p. You're gonna put a p where r is, squared. And then your height is just t. So you're gonna put a t there. Boom. Here you'll have maybe half a mark if you're lucky. But then now for you to go from this to what they have here, I mean, like, you can see why we have to get an expression for p squared. You see, because this, where you see p squared here, you can just throw this whole thing now. So you're gonna have the v equal to a third pi, where the p squared is the whole p squared is just gonna be replaced by this whole thing. And don't forget your brackets, because the moment you forget your brackets, that's when, you know, yeah, that's when you're going to cry. So anyways, let's see here. This is like t. So all this, you want to simplify it now. Remember, all this, if you're going to work it out nicely, just try and put everything together first before you multiply inside the bracket. So you can write this as what you may call. You can write it as v is equal to a third pi times t in front. And then you're trying to multiply this bracket here. There you go. So let's multiply inside our bracket so we can end up with this thing here. So here our value of v is this whole thing times negative t squared is going to give you a negative third pi t to the power 3. And then this multiplied by the 60t, I mean the 60 times the 1/3 pi. You can just check what that gives you in the calculator. Or you don't even have to, you know, you can just think to yourself, a third times the 60 times the pi. You are literally just going to get a positive 60/3 pi, and then the t and the t will give you a t squared. You see, of which if you simplify this now, and you maybe write this first, the 60/3, that's where the 20 comes from. And then this, just write it next to it. Now, the last thing you want to do for yourself is to think to yourself, but then why are they making us do all this for 1 mark? That's like the worst mentality you can have. The worst, you see, because when you get questions like these, they are 1 mark questions, yes, but then you should realize why they are 1 mark questions. You see, they are 1 mark questions for a reason, because it's almost like stuff that they expect you to be able to do. But then because we've looked at these, because we've just done it now, I mean, like, it's a 1 mark question. We threw in whatever we threw in, and then now we have our final answer for 1 mark there. So that is that. So we can move on to the next question if there are no questions. So let me see here. What is the next question saying? So you can see the next question there is a 3 mark question. So let us just dive into it. Wrapping up. So with this 3 mark question, let's see what they're asking. They said, calculate the value of t for which the volume of the cone will be a maximum. Okay, so you can see this kind of a question. I mean, like, if you have gone through applications of calculus before, you know that these questions, they reign supreme. They're always asking these kinds of questions. So for you to answer this kind of a question, I mean, like, it should always be 3 marks. You have the volume equation. The volume equation, it's in terms of t, right? So it's like 20 pi t squared minus a third pi t squared t cubed. Remember, it's annoying how they've written it like this, with how there's the squared and then the cube afterwards. It doesn't make it doesn't change anything. What you want to remember is this is clearly just a cubic function. You know, it's just a cubic function. Literally, if you draw out what this is going to draw out, it's going to look something like this: down, up, and then down again. You see, because the value in front of the t cubed here is a negative, so it means your graph starts by going down, up, and then down again. So here they're asking you to calculate the value of t for which the volume is a maximum. Okay, so if you're going to work out the value of t for which the volume is a maximum, these kinds of questions, right, without overthinking it, this is all you need to do. And it may sound a bit weird, crazy, but you know, over time you'll understand. So what we're saying is, you have to remember that with this equation, right, it's going to draw something like this, you see. So without me getting too deep into things, you have to remember that one way or the other, right, there's a specific value of t here that is going to give you the highest volume possible. I'll repeat, there is a specific value of t that we can throw into this equation that is going to result in us getting the highest volume possible. Now we need to find that specific value of t, and this is how you find that specific value of t. And us finding this specific value of t is what you do for all questions that ask for a minimum or a maximum. What you always do is differentiate the equation of whatever they are talking about and then make it equal to 0. Or let me use different words. Whatever they will be referring to, so here they're referring to volume. They're asking us to get a value of t for which the volume is a maximum. So all we need is, we need a volume equation. That's the first thing we need. We need a volume equation, and we have it. Check. We also need the rate of change equation of volume. I'll repeat this. We also need the rate of change equation of volume. Now, the rate of change equation of anything is its first derivative. Let me put it this way. The rate of change equation is the first derivative. You see, because remember, we always say that the first derivative refers to gradient. Now remember, gradient just refers to rate of change. It's just different words meaning the exact same thing. So with these two things written out, right, these are the two things we need for all questions that ask us to get the minimum or the maximum of something. You see, we will always need the equation of what they're referring to, and then we will also need its first derivative. As long as you have those two things, you're good to go. So we have the first thing already, which is the equation of volume. But then we don't have the rate of change equation. Now we said here the rate of change equation is the first derivative. So let us get that first derivative. The first derivative is just you differentiating your equation once. Now, whenever you differentiate, pay attention to what your variables are. T is the variable. Everything else in front of t is the coefficient, meaning that 20 pi is the coefficient. Negative 3 pi is the coefficient. So if you're going to differentiate this, you're going to say 2 times the whole thing in front here, which is going to give you 40 pi. And then you remove 1 from the exponent. And then here, 3 multiplied by the whole thing in front here. You can even be using your calculator here. but then always try and have your answers in terms of pi. It's gonna make your life easier. So 1/3 times the 3 there is just a 1. You see, or rather, negative 1/3 times the 3 is just a negative 1. And then the pi is just gonna be there. Whoa, pi. You see, negative 1/3 pi times 3 is just negative pi. And then t here is going to be squared because you remove 1 from the exponent. You see, we have just differentiated using normal differentiation. We have just taken the exponent multiplied by the value in front and then remove 1 from the exponent. Exponent multiplied by the number in front and then remove 1 from the exponent. Let me not write this here because it's going to look a bit weird. But this is just a negative pi t squared. So we have our volume equation and we have the first derivative. Now, our first derivative is going to help us to find the specific value of t that will give us the maximum volume. You see, the first derivative is the one that helps us to get the specific value of t that we put into the volume equation to get the highest volume. Because remember, this is a volume equation. If you put a t value, you're going to get volume. But we need a specific value of t. And that specific value of t, we're going to get it from here. Now, this is how you get it from here. So in your first derivative, for you to get this specific value of t that we need, right, you're always going to make your first derivative equal to 0. You always equate your first derivative to 0, meaning where you see this symbol here, you're going to make it equal to 0, and then you're going to solve for t. You see, that's what we're going to do. We need to make, in this equation, we need to make this symbol equal to a 0, and then we need to solve for t. Solving for t, we are going to get the specific t value that we can throw in there. Now, the sad thing is this question is just 3 marks. Like, yeah, 3 marks is like, yeah, it's not the best. And I'm also thinking to myself, why do I not have space? I'm like, good Lord, the person that set up this paper, I know, man, no, did not do a good job. But anyways, here you have to be careful, right? If you're going to get a value for t, you can actually just factorize. It looks like pi t is the common factor. So here you can factorize by taking out pi t. Here, if pi t is gone, you're going to have 4t. If pi t is gone here, you're going to have negative t. But remember, if you multiply inside, you should always go back to where you started. So here you can say 0 is equal to pi t, or 0 is equal to 4t minus t. And then you just have to solve for t. So here divided by pi on both sides, your t is a 0. Or here you can take the t over, your t is a 40. If you think of it logically, only one of these answers is the value of t that produces the highest possible volume. You see, only one of them is going to produce the maximum volume. And it's obviously not the 0. Because if you put a 0 there, your value of volume is a 0. So this one, you're going to have to disregard it. It's not valid. Because if you throw a 0 there, that's going to be the minimum volume actually. Because this question can swing both ways. Here they can ask the exact same question, but put minimum here. You would do the exact same thing. Because one of these here gives you the minimum volume. One of these here gives you the maximum volume. So here for this question, we have to go with the 40. Because the 40 is the one that's going to give us a maximum volume, you see. So for 3 marks, that's literally all we have to do. Calculate the value of t for which the volume of the cone will be a maximum. So the value of t for which the volume will be a maximum is where t is a 40. You see, so all we needed was the volume equation, because that volume equation, we have to get its rate of change equation. So the rate of change equation is just the first derivative. So our volume equation that we needed, we had to differentiate it first and then make it equal to 0 so we can get our specific t value that causes the maximum volume. So 9.4 is a good follow-up, because if you look at 9.4, before we even start with 9.4, if there are any questions with what we have just done, then we can carry on. So this is not a question, it's a suggestion. Yes, definitely, we had to derive the volume. So the volume equation, so we derived it, and then we are here now. For 4 marks, we have to be careful now. They said, what percentage of the sphere was used to obtain this cone having maximum volume? Okay, yeah. it looks like we kind of have to think here. It's a 4-mark question, and like with all 4-mark questions, right? I'm like, they are so easy to judge, just like how I have just like what you call. They're so easy to judge. That's just like how I've judged this question here. You see, I literally just read it. It's 4 marks, and then I reacted. But anyways, I'm gonna have to read it again. What percentage of the sphere was used to obtain this cone having maximum volume? So with this kind of a question, you do have to think strategically a bit. So when I say you have to think strategically, this is what I mean. Let's go down here. Paste, crop. So this is why these past papers shine, you know, because past papers allow you to bump into different kinds of questions, so that you struggle with one, and then the next one that you're gonna bump into that's similar, you're gonna struggle less, and then after a few more, then you're gonna be fine. So the idea here is we have our sphere over here with our volume equation, right? They said what percentage of the sphere was used to obtain this cone, because remember they told us that this cone is being cut out from the sphere. You know, it's like being cut out from the sphere. So before we can worry about the word percentage here, like this is our last worry, like legit. The reason why I say this is the last thing you want to worry about is because all you can literally just do here is work out the volume of the sphere first, and then work out the volume of the cone. Once you have those two figures, right, it's going to be easier for you to like work with percentages or get percentages. Like literally, just do that. Get the volume of the sphere, get the volume of the cone, and then come back to the percentage part. So us getting the volume of the cone, we already know that's easy because we have the volume equation of our cone. The volume equation of our cone is this one over here. But then the specific volume that we should be gunning for is one where our value of t is a 40. So in our volume equation where t is, we're putting a 40 there because we want to see what is the volume of our cone in the first place. Let's just do that. Let me remove this arrow so that it's not confusing. So minus a third pi and then 40 cubed. Let me put all this in the calculator and then we shall see what it is. Shift pi 40 squared minus a third shift pi 40 cubed. Okay. So this answer, you might as well leave it as pi, because if you're going to do some funny business, yeah, it's not going to be friendly. Eh? So this answer is giving us 30,000. So the volume here, try and write it nicely here, is 30,000, not 32,000. 32,000 over 3 pi. That's the volume of the cone. So we need the volume of the sphere. So us getting the volume of the sphere, I mean, you can see that the volume of the sphere, we have an equation here. The volume of the sphere is just 4 over 3 pi radius cubed, you see. So we have to use the radius of our, of our cone. The radius of our cone, I mean of our sphere, is just a 30, you see. So getting the volume of the sphere is not difficult. The radius is just 30. It was given right from the beginning. So V here of the sphere is just 4 over 3 pi with 30 cubed. Let's just put all this into the calculator. Okay, let's just hope it's bigger than that number, eh? Because if it's not, it's not going to be good. So shift pi and then 30 cubed. So that's giving us, oh yeah, it is bigger, much bigger. So this is like 36,000 pi. Okay, that's not bad. So now we can now work out this whole percentage question, because now you know this is the volume of the sphere, this is the volume of the cone. Let's actually write it down. This is for the cone, this is for the sphere. You see, so if you're going to work out what percentage of the sphere was used to obtain the cone having maximum volume, this is all you do. You're going to take the volume of the sphere, and then on top here, you're going to put the volume of the cone, and then this value here, you have to multiply by 100. You see, it's almost like a test. This was the total. This is what you got. A percentage is you multiply that by 100. You see, because this is like the total volume that was available, but then the cone only used up this much volume. You see, so let's work this out as a percentage. As a percentage, let's see what that value is in the calculator. So it's a fraction button. On top, I'm going to put a bracket, and inside the bracket, I'm going to put the fraction that we have on top there, shift pi next to it. And then we're going to put 36,000 pi, shift pi. So as a percentage, so if this whole fraction, right, times 100 is giving us 29.63%. I don't know why I changed the color here. Should have just carried on with the yellow. So this is equal to 20.
Eva, there's some people that would like to know where the 30 comes from that you substituted in before you continue.
Oh, so the 30 was from what they gave us. Because remember, the 30 is the radius of the sphere, of which the 30 they told us right in the beginning here. They told us that the radius of the sphere, so here from a solid sphere with a radius of 30. So that 30, they gave it to us already. So in our image here, you can see the radius from the center of the sphere to the edge is a 30. From the center of the sphere to the edge, it's also a 30. So that's where this 30 came from. You see? And then that's how we're able to get this volume of the sphere. So we say now the volume of the cone over the volume of the sphere, if you multiply by 100, we're getting this percentage here, 29.63%. And it's kind of believable because a cone, I mean, like it starts off big down here, but then as it goes up, it like shrinks. So this is almost like close to 30% of the entire sphere, which is which makes sense, you know. So for 4 marks, this is what you would need to have done for this question. Let me see if there are, let's see here, where did we get 30? Why are we subbing 30? Okay, so we got, as mentioned, we got the 30 from the given description, and we're subbing in the 30 because that's the radius of the sphere. Whew, thank you. So as mentioned already, right, if you have questions in the future, if I'm not on this screen, right, just switch on your mic and then I will be able to stop and answer whatever question you have. But for now, I guess this is that for this question in particular. Let me actually just stop this recording. Wait, let me see what this question is. Whoa, go back. It says, when we give our answers for the volume, does unit of measurement matter? So the fortunate thing is, this is not physics. So this is one of the places where you can get away with not putting units, like legit. But the other thing is here, they're not asking specifically for the volume. They're asking for the percentage of the volume. So us putting 29.63% here, this is what actually matters. Everything else in between is really not important. So if you put your value here without a unit, it's fine. Because remember, with the information that they have given us right at the beginning here, if they've given us the 30 centimeters here, then we can assume that our measurements are in centimeters. Meaning you can put your volume here as centimeters cubed and centimeters cubed over there. But then as mentioned, for math, your units are not necessarily a requirement. But for physics, yeah, that's when you know you need to put your units. But I think if you do physics, just always put your units all the time so that it's a habit, so that you don't forget it. So question 10 says, for 2 marks, Ben, Ntlantla, Owen, Derek, and 6 other athletes. So don't forget, it's 10 athletes in total. We just have these ones being, you know, they're the special ones. They have given us their names. Maybe they're the fastest ones or the best ones or whatever. So these 4 athletes, right, and 6 other athletes take part in a 100-meter race. Each athlete will be allocated a lane in which to run. The athletic track has 10 lanes. Okay, that's useful information. Now, with all this being said, for 2 marks, they said, in how many different ways can all the athletes be allocated a lane? Now, this is one thing I've specified very aggressively in the probability course, or in the probability playlist also, the probability playlist. The one thing I've mentioned is that when you get these kinds of questions, just visualize everything. For this one, it's going to be a bit easy because you have like a track, right? And there's like 10 slots. You see, like 1, 2, 3, 4, 5. 2, 3, 4, 5. 1 to 10. There are 10 lanes, you see. So they're asking in how many different ways can all the athletes be allocated. So it's just a matter of saying, okay, fine, when everyone has not been allocated. For this first slot, you have 10 options. The moment you put one person here, you only have 9 options that can be put here, 9 people. The moment 2 people are there, here you only have 8 options, and then 7 options, going on and on and on, you see. 7, 6 options left, 5, 4, 3, 2, and then 1 at the end, you see. So the number of ways that the athletes can be allocated is just going to be 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. This you can just jump straight to the answer, which is going to be this very, very long thing. However, a number, if you're going to multiply it with everything before it, you can just write it as 10 factorial. But let me pause here because this is actually kind of new. This is like new work if you have not started with probability. So I think that's a mini disclaimer. If you have not started with probability, this is gonna be new, like brand spanking new. Now, yeah, it's actually making me think. Yeah, if you haven't done probability at all, I think only question 11 might be useful to you because this one is purely grade 12 work. So factorial is just saying you're multiplying with a number by everything that comes before it. So just use it sparingly actually. So 10 factorial in your calculator, I think it's like 3 million something. This is a really, really long number, but let me get this calculator here. 10 times 9, 8, 7, 6, 5, 4, 3, 2. Yeah, it's 3,628,800. This is what that's the number of ways that these athletes can be allocated. You can see it's like many, many ways. Now, here they said for 10.2, right? They said here, 4 athletes taking part in the event insist on being placed in lanes next to each other. In how many different ways can the lanes be allocated to the athletes now? Now, the idea is with these kinds of questions, they're so common, very, very common, and you just need to know how to work with them. So the idea is you need to visualize what you have. You have 10 lanes. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individual lanes. Now the idea is these 10 individual lanes, we just said that they can all people can be allocated to these lanes in 10 factorial ways. Now the thing is, here they said 4 athletes insist on being placed next to each other. So with a situation like this, what you do is you literally think of these 10 lanes, but then you paste 4 of them together and you look at it as like one chunk, you see, because the 4 that insist on sticking next to each other, you just look at them as like one thing, one big thing, meaning now you have like one big thing, which is like 1, 2, 3, 4, 5, 6, 7 individual items, right? That can be arranged in 7 factorial ways. What I mean is you have 7 individual items now that can be arranged in 7 factorial ways. So 7 items can be arranged in 7 factorial ways because it's item number 1, which is this one here, item number 2, 3, 4, 5, 6, 7. So these 7 items can be arranged in 7 factorial ways. However, these items that are stuck together, it's 4 items. These 4 items can be arranged in 4 factorial ways, you see. So all the items, including this group, can be arranged in 7 factorial ways, but then this group in itself, they can be arranged in 4 factorial ways, these people, as long as they're stuck together, you see. So the total number of arrangements where the 4 people are stuck together, it is just going to be 7 factorial multiplied by 4 factorial. This is going to be your final answer, whatever this is in your calculator. Because the idea is you have 10 lanes, but then 4 of the athletes insist on being together. So you put 4 of them together, and then you look at it as like one giant option, one giant thing. Now, as long as you have put this stuck together, you know that this is like 1, 2, 3, 4, 5, 6, 7 items, 7 factorial ways. That's how they can be arranged. And then these 4 that are stuck together, they can be arranged in like 4 factorial ways. So all that in the calculator, let's see, it's going to be 7 times 6, 5, 4, 3, 2, 1. So this is going to be 5040 multiplied by, let's see, 24. Yep. Multiplied by 24. Why am I writing so bad? It's bad. So again, if I see something that is not very meaningful, if it doesn't make sense to you, you can always just pause me, and you can always just ask a question. And if you know that this is like one of those topics that you guys have like not touched on at all, then I mean, feel free to only maybe worry about this like later on when you've started with it, you see. So meaning, yeah, bo. So to just maybe expand on that, right? If let's say 4 people wanted to be stuck together and another 2 wanted to be stuck together, this would be the idea. So let's say 4 people wanted to be stuck together and then 2 other people wanted to be stuck together. The number of arrangements would look something like this. So you'd have 10 options in total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to put people. But then if they tell us that 4 want to be stuck together and 2 want to be stuck together, the number of arrangements that you will now have is now going to be 1, 2, 3, 4, 5, 6 factorial, because you have like 6 items, multiplied by 4 factorial here, multiplied by 2 factorial here. You see, this will give you the number of arrangements if 4 people want to be stuck together and if 2 other people want to be stuck together, you see. Because when you group 4 together and you group 2 together, you now have a total of like 1, 2, 3, 4, 5, 6 slots to put those groups of people. Now, the moment you arrange those 6 items in 6 factorial ways, you have to consider how here you have 4 people, they can be arranged in 4 factorial ways. Here you have 2 people, they can be arranged in 2 factorial ways, you see. And then that will give you a total number of arrangements. So the more questions like these that you're going to do, the easier it's going to get. And the more often you draw pictures for questions like these, it definitely does get easier. So for 2 marks here, right, it says, if lanes are randomly allocated to athletes, determine the probability. Now we're dealing with probability. So these 2 questions, it's basically just been, the fundamental counting principle. See, the fundamental counting principle. So if you check in your textbooks, you'll see that there's a topic somewhere on the fundamental counting principle, which is there within the probability chapter. Hence why they're asking probability here. So here they're saying if lanes are randomly allocated to athletes. So lanes are being randomly allocated to what you may call to athletes, right? Determine the probability that Ben will be placed in lane 1, Ntlantla in lane 3, Owen in lane 5, Derek in lane 7. It's a 2-mark question. The reason it's a 2-mark question is because they don't want you to overthink. Like, I cannot stress enough how drawing these images is going to help you. The reason why I've drawn these images here, it's not literally because it's not because I'm like explaining the questions. No, it's because that's how I figured them out in the first place. There's no ways I would be able to work any of these out without drawing these images. Whether it is that I'm like explaining to someone or I'm literally just doing the question on my own, there's no ways I will not draw these images at all, because without the pictures, it's going to be difficult for you to see how maybe simple the question is. So for example, here we have 10 lanes in total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They said we should work out the probability. So before you worry about probability, right, this is what you should keep in mind first. The probability, we need to work out the probability that Ben will be in lane number 1. So in lane number 1 here, we have Ben. And then lane number 3, we have Ntlantla. So N here is Ntlantla. And then lane number 5 is Owen. So we have Owen over here. And then lane number, let's see, 1, 2, 3, 4, 5. And then lane number 7, we have Derek. So let's put Derek in lane number 7 over there. There you go. So before you can work out the probability that Ben is here, Ntlantla is here, Owen is here, Derek is here. Before you can work out that probability, what you just need to work out first is how many arrangements are there where Ben is here, Ntlantla is here, Owen is here, and Derek is here. I'll repeat. Before you can worry about working out the probability of this happening, before you can worry about the probability of it happening, you firstly just need to find out how many ways or how many arrangements are there where this scenario is playing out. Now, to do that, you just have to think the way we have been thinking. And this is how you go about answering a question like this one. So the number of arrangements, right, where this is the way these people are placed. Firstly, you just want to structure the question based on what you want. So if you want Ben to be here, it means that there's only one option for this slot. Only one person can be here, which is Ben. If you want Ntlantla to be here, it means that there's only one option for this lane, which is Ntlantla. If we want Owen to be here, I mean, like, we're going to put him there. So there's only one option for that lane here. It's one person that can potentially go there. And then for this lane, we want Derek to be there. So there's only one option for that lane. So once we have put Ben where Ben is supposed to be, Ntlantla where Ntlantla is supposed to be, Owen where Owen is supposed to be, Derek where Derek is supposed to be, now we can deal with the rest of the athletes. Because now we know that Ben is here, Ntlantla is here, Owen is here, Derek is here. So all the 6 people that are still standing, all we now have to do is to put them in these open spaces. And this is how we do it. We have 6 people in total. So when all 6 people are still standing, here we have 6 options, you see. The moment we put one person here, we only now have 5 options for this one. The moment we put one person here, we only now have 4 options for the next one. The moment we put one person here, we only have 3 options for this one. The moment one person goes there, we only have 2 options for this one. And the moment we put a person here, we'll only have 1 option for the last one, you see. So this here is the number of ways that our athletes can be arranged if Ben is here, Ntlantla is here, Owen is here, and Derek is here, you see. We're almost like forcing the situation, you see. This is the number of arrangements if Owen is here, Ben, blah, 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 blah. Now, those total number of arrangements, it's literally just you multiplying all these numbers together. You see, it's just a matter of multiplying all these numbers together, and you can just use your calculator to do that. So using your calculator, let's see what this is going to give us. It's like 1 times 6 times 1 times 5 times 1 times 4 times 1 again times 3 times 2 times 1. So it's 720 ways where these people can be arranged in this order. You see, there's 720 ways where Ben is here, Ntlantla is here, Owen is here, Derek is here. Now, the probability of that happening is all a matter of you saying, remember, probability is all a matter of you taking into consideration all the options without any restrictions, and this here. Okay, let me give an example. If you have, let's say, 3 calculators, right? Calculator 1, 2, and 3. Let's say 2 of them are blue, and then 1 of them is pink. If the question is, what is the probability of getting a pink calculator? The probability of getting a pink calculator here, the first thing you ask yourself is, how many pink calculators do you have to begin with? You have 1, you see. And then the next question you ask yourself is, how many calculators in total do you have? You have 3. So the probability of you getting a pink calculator is just 1 over 3. Same if they ask for the probability of getting a blue calculator here. If these were calculators, if they said, what is the probability that we get a blue calculator? You would firstly ask, how many blue calculators do we have? You would say you have 2. And then you would then ask, how many calculators do we have in total? We have 3. So the probability of blue calculators is just 3/2. The analogy is the same here. We first needed to find out how many ways can Ben, Owen, and all these guys be arranged in this way. There is 720 ways that can happen. The next question will now then be, how many ways in total can these athletes be arranged? They can be arranged in 10 factorial ways, which is this 3 million, whatever. So the probability that Ben, Owen, and everyone is in these lanes is going to be 720 out of the 3,628,800. You see, this we might as well just leave it the way it is. You know, whether your calculator gives it to you in its simplest form, it's fine. I don't have a calculator right now on me. It's like somewhere very far. But then this is your probability that Ben will be placed in lane 1, Ntlantla in lane 3, Owen in lane 5, and Derek in lane 7. That is the probability of this happening. It's a 2-mark question only. You can imagine why they're making it a 2-mark question. It's because over time, these kinds of questions, there's just like a way of working them out. And as you see here, the one way to work them out is see it on your paper. Don't just keep it in your head. If you keep it in your head, it won't make sense. The moment you start drawing it out, that's when it at least starts to make sense. So if there are any questions on 10.3 or any questions at all really about anything, remember, you can always just switch on your mic and then you can always just ask based on whatever it is that would have been said. So that was for 10.3, right? We can now move on to question 11, which is also some more probability. So question 11, we're dealing with a two-way contingency table. Interesting. So this two-way contingency table, it says a survey on their preference of exercise is conducted amongst 140 people. The way I'm reading this is just so weird. A survey on their preference of exercise was conducted amongst 140 people in 2 age groups. The information is summarized below. So they took 140 people. You had people that were 30 years and younger, 35 years and younger, and then you had people that were 35 years and older. No, 35 years and younger, and then older than 35 years. Okay, fine. Now, amongst the number of sports or exercises that they could choose from was tennis, running, going to the gym, or rather, amongst the preferred exercises, you had 3 options: tennis, running, and gymming. So, with the two-way contingency table, what we know is from left to right, everything always adds up to this number. You see, A plus this plus C adds up to 80. B plus 21 plus D adds up to 60. Going downwards, it's the same. A plus B gives you 21. 28 plus 21 gives you the 49. C plus D is 70. So, yeah. So anyways, what do we need to do? We need to look at what the question is asking us. For 3 marks here, it says, if it is given that preferring to play tennis and age are independent of each other, determine the value of A. So this question is important because this question needs you to know your probability theory. Now here they're talking about independent events. Independent events. Now the theory that you need to know is that with independent events, the probability of event number 1 multiplied by the probability of event number 2, this will always be equal to the probability of event 1 and the probability of event 2. This is more like a formula. Probability of A times probability of P is equal to probability of A and B. You see, that's for independent events, meaning that the probability of one thing happening multiplied the probability of the other thing happening is equal to the probability of them happening at the same time. You see, that's what independence That's what independent events are. This is just in interpretation, the probability of A and B, the probability of A and B is equal to the probability of A multiplied by B. You see, as in the probability of, yeah, I think you get it. Let me not be that guy. So what is important though about what they have told us is we have to know how to use our two-way contingency table. They said here, if it is given that preferring to play tennis and age are independent. So what that means is the probability of tennis multiplied by the probability of a certain age, this will be equal to the probability of tennis and a specific age. Just to put it in simple ways based on this formula, this is just saying that if it is given that preferring to play tennis and age are independent, so it means the probability of tennis, what is the probability of playing tennis? The probability of playing tennis is just 21 out of 140 people, because you have 140 people in total, but then a total of 21 play tennis. So the probability of playing tennis is just 21 over 140. The probability of, let's see here, if it is given that preferring to play tennis and age are independent to each other, determine the value of A. So we have the probability of playing tennis. Now the other issue here is, before I even carry on, right, what I maybe need to ask so that you give yourself a chance to ask the questions is, if anything that I'm going to say here is a bit off, right, and it's like not making sense and it's not something I'm familiar with, you can just ask a question and then we'll be able to like explain it. Otherwise, you know, yeah, it's going to be a bit of a mess. So I hope everybody can what? Yeah, just be open. So here it says, if it is given that preferring to play tennis and age are independent of each other, determine the value of A. So before we even worry about anything else, right, let me even remove this because we have already said it. So there's no need to keep it here. So what we need to remember is that, firstly, what we know about tennis is that, let's just explain what each of these blocks mean. So in this column here, right, you have the number of people that are younger than 35 and play tennis. Here you have ones that are older than 35 and also play tennis. Now here you have the total number of the people that play tennis, right? It's just 21. Now what we know is that the probability of being younger than 35 and playing tennis will just be A over 140. Let me repeat. The probability of being younger than 35 and playing tennis is just this number over 140. Furthermore, the probability of you being older than 35 and also playing tennis, that number is just E over 140. Going on and on and on and on and on. Now, the only annoying thing here with this specific question is that when we're thinking of age, right? I mean, like just the nature of this question, you can see it's not very straightforward. And any probability question that's going to have like 3 marks, any probability question that's usually going to offer you like 3 marks, there's usually a reason for that. And for this question in particular, I mean, we can almost already see why they're offering us 3 marks for this question, because it's just not straightforward. But the reason why it's not like straightforward is because the one thing we have to be asking ourselves here is, okay, fine, I mean, like, how do we incorporate age in this question? Because the unfortunate thing with this question is, I mean, like, we have 2 sets of ages. There is the There's the what? There are the people that are older than 35, and then there are the people that are younger than 35. Yeah, it's just a mess. It's really just a mess. But then for this kind of a question, you just want to keep it simple, because look, because there are like two different ages to deal with. For you to like choose which one you're going to focus on, just let the question help you. The question is talking about A, of which A is dealing with people that are 35 years and younger. So before you even do anything, in terms of you worrying about age, just worry about the guys that are 35 years and younger. So this question again, if it is given that preferring to play tennis and age are independent to each other, determine the value of A. So what you're going to need to do in this kind of a situation is, firstly, you need to ask yourself, what is the probability of playing tennis? Probability of playing tennis, we said it is 21 over 140. So because they're talking about A, you then need to ask yourself, what is the probability of being 35 years and younger? 35 years and younger. You see, because remember here we're talking about tennis and a specific age. So in terms of tennis players, you consider all these 21 people. And then in terms of a specific age, you consider all these people that are 35 years and younger. The reason you're considering the ones that are 35 years and younger is because you are dealing with getting a value of A. And you getting a value of A, it's you dealing with this age group, you see. So here, if it is given that preferring to play tennis and age are independent of each other, determine the value of A. So this is the probability of playing tennis. The probability of being younger than 35 years or 35 years is just going to be 80 over 140. 80 over 140. So the fortunate thing is that because these are independent events, it means that the probability of playing tennis multiplied by the probability of being 35 years and younger, this is going to be equal to the probability of playing tennis and being 35 years and younger. You see, so the probability of playing tennis and being 35 years or younger is just going to be A over 140. But before I write that out, let me put this here, T and A. The probability of T and A, we know it is just A over 140. The probability of being this specific age that they're talking about, we worked it out to just be 80 over 140. The probability of playing tennis, we worked it out to be 21 over 140. So based on the information they gave us, right, and based on how the independent events formula works, we just wrote out the independent events formula. And then we just identified what are the events here. The events that we are dealing with here is the probability of playing tennis. We got it. The probability of being a certain age. We got it. The probability of playing tennis and being that age. We got it. So we put all that into our formula. Now in this formula, we just have to solve for A, of which solving for A in this formula, we can see is just straightforward. Here, we can just put this left side in our calculator and then do whatever it is that we need to do. So let's see what our value of A is going to be. Let me just put it in the calculator. So on the top there, it's going to be 21 times 80, which is like 1680. At the bottom, 140 times 140. That's going to give us 19,600. 19,600. Goodness. 19,600. This is equal to A over 140. Yo, I don't know, I'm running out of space here, and it is like so annoying. Whoo-wee. Let me just straighten this also. Make this a bit smaller. So from here, solving for A, you can just cross multiply. Let me just give myself some space here by making some of these smaller than what they are. Give me 2 seconds. Give me 2 seconds. I shall work out the answer just now. Move this, make this bigger. Zoop. There we go. And then here, let's put this over there. Put this over there. There we go. So working out A here, we can just cross multiply. We actually don't have to. We can just multiply by 140 on both sides because that's how we can have A on its own. Multiply by 140, multiply by 140. Your A value here is going to be at 12. See? So that's how you're going to get a value of A. So for 3 marks, you can see how important it is for you to know your theory. Because if you don't know your theory, it's going to be a big, big mess. And messes are not good. So I'm trying to add this person. Are they gone? Oh, they're gone. So anyways, let me see. So what is the question? What is the question? So why did we use 80? The reason we used 80 is because we want to get a value of A. Now, if you're going to get a value of A, the only age that's relevant is these 80 people. Because A is in the row where you're dealing with people that are 35 years and younger. So people that are 35 years and younger, you have 80 in total. So based on our question, if it is given that preferring Euclideanness and age are independent, the moment they're talking about age here, the age that you're supposed to deal with is this one, people that are 35 years and younger. The reason why you're dealing with people that are 35 years and younger is because we're asked to get a value of A, you see. And A is in this row here, where you're dealing with people that are 35 years and younger. That's why we chose to deal with the 80. I hope that answers your question. And this person, let me just add them and carry on talking because we are far. So for 5 marks now, okay, 5 marks. That's quite interesting for probability because 5 marks, it says if it is given that A is 12. Well, okay, we do know A is 12. If it is given that A is 12, determine the probability that a randomly selected person prefers going to the gym or is in the same age group. Or is in the age group 35 years and younger. So this question is quite weird. Probably have to reread it, maybe twice. But then before we even reread this question, the one thing we need to remember is now that we have worked out A, we might as well fill in the rest of this table. Like we kind of need to. It's almost like our duty to do it. So as long as this is 12, it means that if this is 12, 28, and the total is 80, it means that we can just reverse engineer everything, So here, 80 minus 12 minus 28 should give us the C there. So let's see here, 80 minus 12 minus 28, that's going to be a 40. So the total number of people that are 35 years and younger and go to the gym, we know that those are 40. Let's put a 40 over there. And then, let's see, if this is a 12, it means that the B here is going to be what? Let's see, 21 minus 12, that's going to be a 9. So let's put that there. It's going to be a 9. So if this is a 9 and this is a 60 and this is a 21, remember everything has to add up to 20. So here we can say 60. I mean, everything has to add up to 60. So here we can say 60 minus these two has to give us the D there. So let's see what that is. 60 minus 9 minus 21. Man, let's see. 60 minus 9 minus 21. It's like 30. Okay, so that's like 30. Fine, because we could have just said 40 plus what gives us 70. Whichever way you use, it doesn't matter. Now that our two-way contingency table is complete, we can reread this question. If it is given that A is 12, determine the probability that a randomly selected person prefers going to the gym or is in the age group 35 years and younger. Okay, so this question is giving me like Venn diagram vibe. It really is. But then the thing now is, what kind of a Venn diagram would that look like? Because it's just gonna be so messy, It is just gonna be so messy. But I am willing to just like, I don't know. I don't even think we could think of a Venn diagram because they didn't mention anything about people doing both. They literally just spoke about, yeah, let me not think of a Venn diagram. I feel like that's just going to make life unnecessarily difficult. So, I mean, for questions like these, right, don't overthink it. Just try and make use of your question, because your question always gives you hints. Now, the fortunate thing with probability is probability also has formulas. Now, you need to know how to use your formulas. Just like this previous question. The previous question had mentioned something about these two are independent of each other. So it reminded us of this formula. Now, this question is talking about something gym or something else. So as long as there's an or here, it should remind you of a formula that also has or in it. What I'm talking about is the addition rule in probability. The addition rule in probability looks like this on your formula sheet. It has P, probability of A, or the probability of, I think it looks like this. It says here, the probability of A or B is equal to the probability of A plus B minus the probability of A and B, like that. You see, this is the addition rule of probability. It's a general probability formula. Addition, no man, addition rule of probability. I'm pretty sure everyone has seen this formula at some point in their life. Now the reason why we're thinking of this formula is because of the word or here. You see, it says here, determine the probability that a randomly selected person prefers going to the gym or is in the age group 35 years and younger. So already you now know what to put as A and B, because A and B is technically gym and people that are in the age group 35 years and younger. Those are the events that you're gonna put where A and B is, you see. So already you can just put here for 35 years and younger, I mean we can just use the variable what you call A or something. So here we can say the probability of G or a specific age is equal to the probability of G plus the probability of A minus the probability of G and A. The G here is referring to gym. The A here is referring to age group 35 years and younger. So that's where we can start off. Just like how we started off with the previous question where we were dealing with the, what you call, independent events. All we did was we identified what events would go here and here, you see, and then we just used the formula. Same here, we're just identifying what events would populate this formula. It's just the probability of going to the gym, the probability of being that specific age group, and then the probability of going to the gym and being that age group. Will be able to work out this question, which is what they're asking for. So let's just put in the information we have. This is the probability of going to the gym. The probability of going to the gym, total people that go to the gym is 70, and then everyone in total is like 140. So the probability of going to the gym is just 70 over 140. The probability of being 35 years and younger is just going to be 80 over 140, because being 35 years and younger, you have 80 people in total. So 80 out of 140, that's the probability of being 35 years and younger. It's just 80 over 140. The probability of going to the gym and being 35 years and younger is just, let's see here, 35 years and younger and going to the gym, it's 40 people in that cell. Because you see, 35 years and younger, gym, they meet here. So it's just 40 people out of 140. So the probability of going to the gym and being 35 years and younger is just 40 over 140. You see, so the probability of going to the gym or being in the age group 35 years and younger, this is what we're trying to work out, right? And our probability addition rule is helping us. It's 5 marks. Now you can imagine where the 5 marks are going to come from. First is going to be your formula. Secondly, subbing in correctly. Thirdly, the final answer. You see, the final answer here is something you can get from your calculator, because 80 minus 40 is 40, and then 70 plus 40 is like what, 130 over 140. 1/3 over 140 is like 13 over 14. But then that's no, that's wrong. Sorry, I made a mistake. It's not 13. It's not 130. Goodness. Oopsie. I don't know where I got that from. It's 110, which is just 11 over 14. There we go. 11 over 14. So that is the probability of going to the gym or being 35 years and younger. That's going to give you a whopping 5 whole marks for just using a formula on your formula sheet.